Hello, my shimmering stars. Today, I, Shaurya Grover, welcome you all to this amazing platform of PW English. Students, I welcome you all to NEET Maha Marathon, and today we are going to discuss with our physical chemistry. I guess each and every one are excited today and are ready for physical chemistry. Yes, students, if my voice is audible and I'm clearly visible to you people, please let me know in the comment section so that we can start our today's session. Yes, everyone. Good morning, everybody. Good morning. So, yes, students, before starting the session, there are few lines for you all. Speak kindly to your inner self. Speak kindly to your inner self. Don't take your demon's view. Don't take your demon's view. You are you and no one else. You are you and no one else will lead the life you do. Will lead the life you do. Kill your inner critic. Kill your inner critic and silence all his chatter. And silence all his chatter. Then write this truth inside your brain. Then write this truth inside your brain. I am worth it and I matter. I am worth it and I matter. So, students, with this quote, we shall start our today's session with a beautiful smile. I guess each and every one of you are ready. Good morning, happy morning, everyone. Yes. So, as you all know, physical chemistry, it is really important for your examination, right? And many of the students, just because of the numerical section, skip this part or don't practice about it, right? So we are going to practice a lot of questions. Mostly the questions are going to be from your previous year, so that is going to be like an idea how questions arise in your examinations. You are going to get an idea over here and you are going to practice along with me. Yes, everyone. So what actually you need to do is I shall be giving you 2 to 3 minutes in order to solve each and every question, and then we are going to match our answers, right? You have to see the method by which I am solving the question, because sometimes what happen is you go by tricks, and sometimes that trick is not right. So you need to check your way and you need to check my way, that whether you are going right or not. So it is a self-analysis for you before your NEET examination, that how well you are prepared for your NEET, right? And if you're not prepared, that means it is an alarm for you that which of the following topics you need to prepare again, or you need to practice more upon that topic. So you have to filter out those topics where you are weak, right? After looking at this session, after going through this session, right? So shall we start, students? If you all are ready, then let me know in the comment section, put a thumbs up, okay? Or you can put your fire symbol so that we can start our first question. Start with the very first question. Yes, students, ready? Okay, so basically you all very well know that we are going to do complete physical chemistry, my shimmering stars, right? Okay, so here is your very first question. Now I am going to go from like this, from class 11th to class 12th. We are going in this way. So this is your first chapter that I am going to discuss over here. That is some basic concepts of chemistry. Again, the question is in front of you, and this question is your previous year question, right? This question is your previous year question. I shall be giving you 2 minutes in order to think about it, and we are going to go with topic wise. Okay, so the very first topic that we are going to cover from the very first chapter is going to be regard to the significant figures, right? Again speaking, this is a previous year question, students. You have 2 minutes. I'm reading the question for you people. Question is, given the numbers 161 centimeters, 0.161 centimeters, 0.0161 centimeter, the number of significant figures for the three numbers is. Oh my god, that's too great. Students have answered also. That's great. That's great. Kavishri has answered. Diksha Sharma has answered. Ramesh has answered. Pooja, Sneha, Badal Kumar. Very good, students. I want a full energy over here, full focus over here, full concentration over here. Right? So basically, see, this is your chapter that we are talking is about some basic concepts of chemistry. And this is your question number first. So if I talk about significant figures, students, basically in the case of significant figures, we have certain rules, right? So let us see over here. We have been given with 161 centimeter. In the case of significant figures, you should know that all the non-zero digits are your significant. Now, what are non-zero digits, ma'am? Other than 0, all are non-zero. From 1 to 9, that means 1, 2, 3, 4, 5, 6, 7, 8, 9, they all are significant. So in this case there is no 0, that means they all are non-zero, hence here the significant figure is going to be 3. Now in the case of 0.161, if I talk about 0.161, you have to see the very first non-zero digit. The very first non-zero digit is 1. So 0, before the very first non-zero digit is not counted as significant. So this 0 is not counted. Hence you will get how many significant figures over here? Again you are going to get 3 significant figures over here. Yes, Pooja, other than 0 are the non-zero digits. Exactly. Right? Now talking about 0.0161 centimeter. Again, my question is again over here. The very first non-zero digit is which one, ma'am? This one. So the zeros before that won't be counted as significant. Hence it is going to be how much, ma'am? Significant figures are going to be 3. So the answer over here is going to be 333. 333. That means option number D, my dear students, is going to be your correct answer for this particular question. Yes, everybody? Yes, everybody? Very good. Very good. Okay, one of the students, Soumya Singh, has answered A and Leah has answered A. Rest, everybody has answered D. Your A is 3, 3 and 4. Where do you get 4 over here? This 0 won't be counted. Why? Because the very first non-zero digit over here is this 1. So zeros before the non-zero digits are not counted, my dear students. Hence again 161 are the 3 numbers. So the significant figure is going to be 3. Leah and Soumya, is it clear to you both also? If you have written A option over here. Right, everyone? Right? Shall we proceed to the second question? If it is done, I want you all to either take screenshot of this question or you can write it down. It is up to you. You'll get the notes of this PDF also after the completion of the chapter. After the completion of this session. Right? Great. So, shall we proceed on to the second question of ours? So, students, your second question again is a previous year question is in front of you. The question is, what volume of oxygen gas measured at 0 degrees Celsius and 1 atm is needed to burn completely 1 liter of propane gas measured under the same condition? Okay. Now students, think about it. Options are given to you. A option is 5 liter, B option is 10 liters, C option is 7 liters, D option is 6 liters. Think about it once. Think about it once. Yes, students, just think about it. What they are asking you. They are asking you what volume of oxygen gas measured at temperature and pressure they have given you is needed to burn completely 1 liter of propane gas measured under the same condition. Now see, propane is basically, now really sorry, here C3H8 will come. Okay? Okay? C3H8 will come. Sorry, there is a typing mistake. This is 8. Now see, C3H8 plus O2. When you are going to burn it, you are going to get CO2 and then you are going to get water. Right? Now, first of all, you need to balance this equation out. So, in order to balance this equation out, count the number of carbon atoms on both the sides, left and the right. Here are 3, but here are 1. So, you will multiply it by 3. Now, how many hydrogen? 8 hydrogen. How many hydrogen? 2 hydrogen. So, you will multiply it by 4. How many oxygen? 2 over here. How many oxygen? 2 into 3, 6. 6 plus 4 is 10. 10 oxygen you require and here is 2. So, you will multiply it by 5. You will multiply it by 5. So, Venkata Anusha has answer A, Garv has answer A, and Parveen has answer A. Right? Right? So let us see. See over here, if we see that here the stoichiometry, let us talk about the stoichiometry. What stoichiometry over here is the numbers that are present over here in front of the reactants and the products. So if I look up to this following over here, I will say that 1 C3H8 is reacting with 5 O2. 1C3H8 basically is reacting with 5 O2, no? So 1 liter of propane gas will react with how many liters of O2? It will be react with 5 liters of O2. It will react with 5 liters of O2. So the option is directly, it is going to be option number A. Answer is going to be option number A. Very good. Golu Mishra has answered A. That's great. Okay. And Pratipa has answered A. Praveena has answered A. Vaibhav Tripathi has answered A. That's great. That's great. Clear? So shall we move on to the third question of ours if it is done, students? Great. Great. Let us see our third question for today. Let us see our question number third for today. Question third is, an element X has the following isotopic composition. An element X has the following isotopic composition. For the very first X, whose atomic number is 200, has the composition of 90%. Then the element X, whose atomic number is 199, has the percentage composition at 8%. And the one which has atomic mass is 202 has a percentage composition of 2%. The weighted average atomic mass of the naturally occurring element X is closest to A option 201 AMU, B option 202 AMU, C option 199 AMU, D option 200 AMU. Okay. So students, think about it once. Think about it. It's very simple. It is based upon the average atomic mass. It is based upon what, ma'am? It is based upon average atomic mass. Yes, everyone? Pinky has answered with D option. NEET aspirants have answered with A option. Okay. Okay. Anyone else? Anyone else, students? Vikanta has answered. Vikata has answered D. Sorry, Venkata has answered. Sorry, my mistake if I spoke your name wrong. Okay. Now, Ravina has answered with D. Okay, let's go now. Let us see. If I'm talking about average atomic mass over here, what I'm going to do, the atomic mass 200 into its percentage composition 90 plus atomic mass 199 into percentage composition 8 plus atomic mass 202 into percentage composition 2 divided by total percentage, that is 90 plus 8, 98 plus 2, 100. Right? Right, everyone? Right, everyone? So when you're going to solve it out, students, you are going to get your answer as 200 AMU. When you're going to solve it out, if you want to solve it out, you can do so. You'll get your answer as 200 AMU approximately. Approximately, answer is going to be 200 AMU. Ma'am, do we always need to form the equation in question number 2? Yes. Without forming the equation in the question number 2, how will you, you can tell that, yes, one propane will react with 5 liters. How can you tell that without looking up to the stoichiometry? In order to see the stoichiometry, in order to, see after balancing, you'll get stoichiometry, So without writing equation, you cannot do that, right? Clear, everyone? Clear, everyone? Shall we move on to the next question? Yeah, approximately answer is 200 AMU. Clear, everybody? Okay, let us see question number 4 for today. Let us move on to the question number 4 for today. Question number 4 over here is, which one of the following has maximum number of atoms? Which one of the following has the maximum number of atoms? Now, how do you calculate number of atoms? How do you calculate? First, I'll give you 1 minute in order to think about it. Then I'll let you know how to solve this question. Options are 1 gram of Ag, whose atomic mass is 108. B option is 1 gram of Mg, whose atomic mass is 24. C is 1 gram of O2, atomic mass is 16. And then is 1 gram of lithium, whose atomic mass is 7. Right? Think about it once and try to solve it out. Kavya Devi Singh, ma'am, can you please do a formula revision in this session, ma'am? Please, ma'am. We'll automatically do a revision of formula by solving the question. So there is, you won't feel any of the problem, right? Students, do have a water bottle with you all as you all are preparing for your NEET examinations. I have seen that you all are preparing really very hard. Right from the last 2 days, you have been participating in the NEET mega marathon for for your inorganic chemistry, for your physics. So in order to be stay for such a longer period, you need to be hydrated also. So do have water time to time, eat healthy fruits for your health also, because health is also really very important, right? Golu Mishra is saying D. Sundara is saying D. Pooja is saying sure, ma'am. Kavya Devi is saying okay, okay. Okay, let us solve it out now. Everybody, you have tried on your own. Anusha is saying D. Yes. Shall we try if everybody has done this? Okay, okay. Let's come back to the question, ma'am. So basically over here is, see, whenever you need to calculate number of atoms, it is very simple. See, number of atoms is equivalent to your number of moles into your Avogadro's number into total atoms present over there. Right? Right? Very simple. Okay, so basically 1 gram of Ag, if I talk about over here, it is 1 gram of Ag. Now what is N? If you don't know, students, N is number of moles, which is given mass divided by molecular mass. So given mass is 1 gram, molecular mass is 108 into your Avogadro's number, that is Na. And how many Ag is there? Only 1. So total atom is 1. So basically over here is number of atoms comes out to be Na, that is Avogadro's number, by 108. See, you can write the value of Na also. If you don't know, students, let me tell you. Na value is 6.022 into 10 raised to the power 23. You can write this value, but see, if you see all of the 4 option contains Na in it, so there is no need to write the value of Na. There is no need to write the value of Na in that. Right? Clear? Let us go for the option number B. Again, here number of moles is given mass 1 gram by molecular mass is 24 into Na, and into total atoms 1 only magnesium. So this comes out to be Na by 24. Right? Now let us see for option number C over here. In option number C, what do we have? We have given mass as 1 by molecular mass. Now see, here it is O2 written. That means 2 into oxygen mass, and oxygen mass is 16 into Na into total atoms. Total atoms is how many oxygen? 2. So basically this 2 will get cancelled. What you will get over here? Na by 16. What you will get over here? Na by 16. At last, now what do you have over here? Here it will be given mass is 1. Molecular mass is how much? 7 into Na. Into total atom is 1. So this comes out to be Na by 7. This comes out to be Na by 7. Yes, everyone? Yes, everyone. Now what they are asking in this particular question, ma'am? What they're asking in this particular question, the maximum number of atoms. So when you're going to divide it, if you'll see, this will come into 0.0000 something. These all will come like this, but this is the value that will be more than these, right? If you'll see the denominator over here, this one will have more value over here. The maximum number of atoms will come in option number D. So option number D, my dear students, is going to be our correct answer. Now again speaking, in your question paper, you won't have much time to solve a particular question. So there is no need to write the value of directly of Na. You can keep Na constant in all of 4 options over here. So it will be easy for you. Write Na along with it and solve 1 by 108, 1 by 24, 1 by 16, 1 by 7. And then you can automatically let your answer, because you have very less time. You have to save your time in case of physical chemistry also, because see, some questions will be, time consuming. So you need to save your time for that. Yes? Clear? Clear, clear, clear. Kindly take a screenshot of it or write it down so that we can move on to the next question of ours for today. Shall we move on to the next question if it is done? Okay, now let us move on to the question number 5th for our today's lecture, today's session. Question 5th is, suppose the element X and Y combine to form 2 compounds XY2 and X3Y2. When 0.1 mole of XY2 weighs 10 gram and 0.05 mole of X3Y2 weighs 9 gram, the atomic weight of X and Y are. A option is 40 and 30, B option is 60 and 40, C option is 20 and 30, D option is 30 and 20. So think about it, students, giving you few minutes in order to think about it. Yes. Yes, students. Shall we start it? Everybody, kindly focus over here. Everybody, shall we start? Shall we start solving this question if it is done by you all? Yes, I am not observing any kind of spirit in you people. You are so dull. Why? Why, students? You are my shimmering stars, and I always say, what is the role of a star? Is to shine. So shine out. What are you doing? Everybody. Yes. Yes, that's great. Okay. So, Anusha is saying A and Yakesh is saying C. C, A. Okay. Okay. Let us see who is going to be the correct one. Golu Mishra is saying A. Pooja is saying A. That's great. Okay. Let us see now. Okay. Let us start. Suppose the element x and y combine to form two compounds xy2 and x3y2. So we have initially one compound as xy2 and another one is x3y2. What else, ma'am, they have given us? When 0.1 mole of this weighs 10 gram. That means here mole is given to you, that is 0.1, and given mass is being provided to you, that is 10 grams. Right? So with the help of number of moles and given mass, can we calculate molecular mass? Yes, ma'am. Number of moles, ma'am, is equivalent to given mass upon molecular mass. What is number of moles? It is 0.1. What is given mass? 10 divided by molecular mass. What will be molecular mass? It will be 10 divided by 0.1. I can write it by 10 into 10 by 1. That means it is 100 grams. So, ma'am, molecular mass came out to be 100 grams for the case of xy2. Similarly, can we calculate for x3y2? Yes, ma'am. Now, over here, number of moles is being provided to you as 0.05 moles. Yes, everybody. And what is the given mass given to you over here? Ma'am, it is 9 grams. How much? 9 grams. So, ma'am, we know that number of moles is given mass upon molecular mass, right? Number of moles is 0.05. What is given mass? 9 gram. What is molecular mass? Ma'am, we don't know. Let us cross multiply them. If we are going to cross multiply them, what we will get? 9 divided by 0.05. That means we can write 9 by 5 into 100. The decimals will go, and 5 20s is 100, right? So this comes out to be how much, ma'am? 180 grams. It comes out to be how much? 180 grams. Now what we have calculated, ma'am? We have calculated the molecular mass for xy2 as 100 grams and the molecular mass for x3y2 as 180 grams. Right? Now we basically know how to calculate a molecular mass. See, molecular mass of xy2 is going to be what? It is going to be 1 into x mass plus 2 into y mass. Now this value is 100. That means I can say x plus 2y is equivalent to 100. Right? Similarly, can I write for x3y2 over here? What I am going to write? I am going to write molecular mass for x3y2 is going to be 3 into x plus 2 into y. This value is 180. Yes. Now, if I compare both of them, can I write 2y over here? What is 2y? 2y, ma'am, is going to be 100 minus x. Equate this value over here. Equate this value over here. What you're going to get? You will get 3x plus 100 minus x is equivalent to 180. Now, 3x minus x will come out to be 2x. 2x plus 100 is equivalent to 180. Let us take this 100 over here. It will be 2x is equals to 180 minus 100. That is 80. X comes out to be how much, ma'am? 40. X comes out to be how much, ma'am? 40. Now let us put the value of x over here. What you'll get? What you'll get? You'll get 2y is equivalent to 100 minus 40. That means 2y is equivalent to 60. Y comes out to be how much? 30. So x is 40, y is 30. X is 40, y is 30. That means, ma'am, option number A is going to be your correct answer. Option number A is going to be your correct answer. Now, Pooja, how is your answer? D. See, first of all, you'll write x and then you are going to write y, no? So, you have written y first and x afterwards. Got it? Got it, everybody? Yes. Answer is going to be x and y. That means 40 and 30 respectively. Clear? If you want to take a screenshot of this question, you can. If you want to take a screenshot of this question, you can. Now we are going to start with your next question. That is question number 6. Shall we? Okay. Now comes your next question. That is your question number 6. Let us read your question number 6 for you all. If Avogadro number Na is changed from 5.022 into 10 raised to the power 23 per mole to 6.022 into 10 raised to the power 20 per mole, This would change. A option, the mass of 1 mole of carbon. B option, the ratio of chemical species to each other in a balanced equation. C option, the ratio of elements to each other in a compound. D option, the definition of mass in units of grams. Yes? So students, kindly tell me. Kindly tell me which of the following is the right answer for this question. Okay, KV Santosh is saying A, Pravina is saying A. Think about it once, students. Think about it. Anyone else? Only 2 students have yet answered this particular question. Okay. See, if I talk about if Avogadro number Na is changed from this much to this much. So basically, you know what is N. N is basically number of moles. Number of moles is number of atoms by Avogadro number, right? So basically, number of moles depends upon given mass and molecular mass. If you are changing number of atoms, that means you will change moles. If you are changing moles, then that will affect the mass. That means it will affect the mass of 1 mole of carbon. So option number A, students, is going to be your correct answer for this particular equation. Clear, everybody? Clear? It was very simple question. It was very simple question. Shall we see the next question for us? Okay, now comes your question number 7th. Now comes your question number 7th. The number of water molecules is maximum in. The number of water molecules is maximum in. A option, 1.8 gram of water. B option, 18 grams of water. C option, 18 moles of water, while D is 18 molecules of water. So you should know, now only I have told you one formula, that number of moles is equivalent to number of molecules divided by Na. That is Avogadro's number. So you need to calculate number of molecules. What will be number of molecules, ma'am? Number of molecules will be number of moles into Na. So this is what you have to calculate over here. This is what you have to calculate over here, right? So see, 1.8 gram of water. Here, N will be what? First of all, calculate number of moles. What is number of moles, ma'am? Number of moles, ma'am, is given mass upon molecular mass. What is given mass? Given mass is 1.8. What is molecular mass of water? Water is H2O. If you don't know what is water, water is H2O. So it is 2 into hydrogen mass plus 1 into oxygen mass. Hydrogen mass is 1 and oxygen mass is 16. So this comes out to be 18 grams, right? So molecular mass is 18. This comes out to be how much? 1 by 10. This is now number of moles. What is number of molecules? Number of molecules, ma'am, will be equal to number of moles, that is 1 by 10 into Na. Into Na. Right? Now see over here, 18 grams of water. Again, number of moles is given mass, that is 18, by molecular mass is 18. So this is 1. Now what is number of moles in molecules in this case? Number of molecules is number of moles, that is 1 into Na. Into what? Na. Clear? Now let us see the next one. Here they have given you moles. Moles already given to you. So what is number of molecules? Ma'am, number of molecules is moles into Na. And in last, they have already given you 18 molecules. They have already given you 18 molecules. So in which of the following the water molecules is maximum? Ma'am, option number C. In which of the following it is maximum? Option number C. Clear? Very good, students. Very good. I am seeing that everybody is writing C in the options. So the answer over here is going to be option number C for this particular question. If you want to take a screenshot of this question, you can, so that we can start with the next question of ours. Shall we start with the next question? Okay. Now comes your question number 8, students. Question 8 is, which has the maximum number of molecules among the following? Which has the maximum number of molecules among the following? A option, 44 grams CO2. B option, 48 grams O3. C option, 8 grams H2. While D option, 64 grams SO2. Ma'am, where we will get the notes? After the completion of this session, you will get notes, okay? Notes will be uploaded, right? In the description itself, it will be uploaded. right? Now, which has the maximum number of molecules? Again, in order to calculate molecules, that means number of moles into Na. Now only we have calculated, right? So here in this case, 44 grams CO2. What is number of moles? Given mass upon molecular mass? What is given mass? 44. What is molecular mass of CO2? See, CO2 molecular mass will be 1 into carbon mass plus 2 into oxygen mass. Carbon mass is 12 and oxygen mass is 16. So this is 12 plus 32, that is 44 grams. How much, ma'am? 44 grams. So number of moles came out to be 1. So what will be number of molecules? Ma'am, it will be 1 into Na. Yes. Now in this case, it is given mass upon molecular mass. Given mass is 48. What will be molecular mass? 3 into 16. That is again 48. This comes out to be 1 mole. So 1 mole, that means number of molecules in this case will be how much? Number of molecules will be 1 into Na. 1 into Na. Yes, everyone? Okay, let us see the C option. Given mass is how much? 8. By molecular mass is 2 into hydrogen mass, that is 1. So this comes out to be how much? 4. Number of moles is 4. So what will be number of molecules? That is number of moles into Na. That is 4 into Na. Right? Now let us talk about the D1. 64 grams SO2. 64 grams SO2. 64 is the given mass. What is the molecular mass? Sulfur mass is 32 plus 2 into oxygen mass is 16. So this is 64 by 64. That is 1. Number of moles is 1. So what will be number of molecules? One into Na. So they are saying maximum number of molecules is present in what? Maximum number of molecules is present in 4 into Na. Rest everybody is 1 Na. So the answer is going to be option number C. Again repeating, there is no need to write the value of Na and start solving it. You need to save your time. Akshay, Praveen, Sushrita, Pooja, Divya, Mathwan, Kamlesh, Golu, Ovia, Mohammed. Everybody has written C. Very good, my dear students. Very good. That's great. Okay. Now, shall we move on to the question number 9? If it is written, you can take a screenshot of this question as well, so that we can move on to the question number 9 over here now. Shall we? Okay. Now comes your question number 9, students. Your question number 9 is, which has maximum molecules? Which has maximum molecules? A option 7 grams N2, B option 2 grams H2, C option 16 grams NO2 and D option 16 grams O2. Yes, students. Now see, which has maximum molecules? See again, maximum molecules, that means number of moles into Na. See over here, now number of moles is given mass upon molecular mass. What is given mass over here, ma'am? 7 gram. What is molecular mass? 2 into nitrogen mass. Nitrogen mass is 14. That means 7 by 28. That means 1 by 4 moles. How many moles? 1 by 4. Now what will be number of molecules over here, ma'am? It will be number of moles into Na. Number of moles into Na. Clear? Now let us talk over here. What is number of moles in this case? Given mass upon molecular mass. What is given mass, ma'am? 2 gram. What is molecular mass for H2? 1 into hydrogen mass. Sorry, 2 into hydrogen mass. Again, it is going to be 2, ma'am. Here, number of moles is 1. So, what it comes out to be number of molecules? Number of molecules will be number of moles into Na. Number of moles into Na, right? Now, let us talk about 16 grams NO2. 16 grams NO2. What is number of moles? Given mass 16 by molecular mass. Nitrogen mass is 14 plus 2 into oxygen mass is 16. So that means 16 by 14 plus 32. That means 16 by 46. How much it is? 16 by 46. Right, everyone? Now this is your number of moles. If you want to simplify it, you can. Now on the table of 2, I have divided it, right? So what is number of molecules? number of moles into Na, and at last we have 16 grams O2. Given mass is 16 and molecular mass is 32, that means 1 by 2. Now what will be number of molecules? It will be 1 by 2 into Na. So which of the following has maximum molecules? It is very simple. It is very simple, ma'am. It is option number B. It is option number B, that is 1 Na. Rest will have, in terms of decimals. Right? Yes, exactly, everybody. So the answer is going to be option number B for this particular question. Shall we move on to the 10th question of ours? Shall we move on to the 10th question now? Okay. So question number 10th is, the number of atoms in 4.25 grams of NH3 is approximately. The number of atoms in 4.25 grams of NH3 is approximately. A option is 4 into 10 raised to the power 23. B option is 2 into 10 raised to the power 23. C option is 1 into 10 raised to the power 23. While D option is 6 into 10 raised to the power 23. Think about it once, students. What is given over here? See, they are asking you number of atoms, right? And they have given you the given mass. This is your given mass. What will be the molecular mass, students, for NH3? Very simple, ma'am. 1 into nitrogen mass plus 3 into hydrogen mass. Nitrogen mass is 14 and hydrogen mass is 1. This comes out to be how much? 17 grams. Right, everybody? Now, what will be number of moles, ma'am? It is given mass upon molecular mass. Given mass is 4.25 by molecular mass is 17. So you can write it as 425 by 100, because if you are taking off the decimals. Now see, if you multiply 17 with 25. If you multiply 17 with 25, let us see over here. It is 425, right? That means 17, 25 is 425. So this is 25 by 100, that means 1 by 4. So number of moles came out to be how much? 1 by 4. Now you have to calculate a number of atoms. So number of atoms is number of moles into Na into total atoms. What is number of moles? It is 1 by 4. What is Na? It is 6.022 into 10 raised to the power 23. Into total atoms, how many nitrogen? 1. How many hydrogen? 3. So total atom is going to be 4. So 4 will get cancelled. What you will get? 6.022 into 10 raised to the power 23. 6.022 into 10 raised to the power 23. That means option number D, students, is going to be your correct answer. Option number D is going to be your correct answer. Yusuf is saying C. Tejasvi is saying C. How C is correct? D is correct. How C is correct? D is going to be your correct answer. How come you are saying C is correct? Madhavan is saying, C. How C is correct? Pooja is saying C. C is not correct. Check again. Check this question again. Take a screenshot of this question. Yes, everyone. Vishnu is saying, ma'am, these questions cover all the important topics for NEET. Yes, I am covering all the topics, and questions from each topic are more than, 5, 6. I have tried my best to bring a lot of questions from a single topic so that you can revise all over it again. Right? D. Great. Okay, let us see the question number 11th now. Question 11th is, the total number of valence electrons in 4.2 gram of N3 negative ion is. Okay, you have to tell the total number of valence electrons. Silly mistake. See, Pooja, silly mistake you can do over here. But in your NEET examination, you need to be very attentive. You need to be very attentive, because over there is negative marking. This is your practice session. You can do mistakes, but you have to learn from that mistakes. You don't have to repeat it again and again, right? So this information is for each and every one student who is watching this video, that you have to avoid your silly mistakes. You can do mistakes over here, but not in the examination. Right? Let us talk about the question. The total number of valence electrons in 4.2 gram of N3 negative ion is. Now see, if I talk about the valence electrons in the case of nitrogen is 5. How many nitrogen? 3. So 5 into 3. Now if there is a negative charge over here, you are going to add 1. This comes out to be how many? 16 electrons. How many electrons? 16 electrons. Now just see, we have to calculate the total number of valence electrons. So total number of valence electrons is just similar to, the total number of atoms. How we used to calculate it? We used to calculate as number of moles into Na into total atoms, similarly into total electrons. So what is number of moles given mass upon molecular mass? Into Na is written as it is in the option, so no need to write it. Total electrons is 16. What is given mass, ma'am? 4.2. What is molecular mass? Now what is molecular mass for N3? For nitrogen, ma'am, it is 14 into 3 for, because it is 3 nitrogen, into Na into 16. 4.2 can be written as 42 by 10, and 14 threes are, is again 42. So this will get cancelled into Na into 16. That means this comes out to be 1.6 Na. This comes out to be 1.6 Na. That means, ma'am, option number C is going to be your correct answer. Option number C is going to be your correct answer. Clear, everybody? Clear, everyone? Very good. Narija is saying Sneha, Arihant, Nandana, Praveena. Very good, everybody. That's good. So option number C is going to be your right answer. Now this is your question number 11th. Kindly take a screenshot. We can start with question number 12th of ours for now. Shall we? Yes, now comes your question number 12th. Question 12th is the number of gram molecules of oxygen in 6.02 into 10 raised to the power 24 CO molecules is. You need to calculate the number of gram molecules of oxygen in this much molecules is. Yes, everybody think about it, how you need to solve this question. What is gram molecules or gram atoms? It is another word for moles. So calculate moles first of all. Moles is number of molecules divided by Na. What is number of molecules? 6.02 into 10 raised to the power 24 divided by Na is 6.022 into 10 raised to the power 23. So that means it comes out to be 10 moles. Now see, there are 10 moles of CO molecules. How many oxygen are there? 1 oxygen. That means 10 moles of oxygen, or in other word I can say 10 gram molecules of oxygen. It is one of the same thing. Now in the case of they are asking the number of gram molecules of oxygen in this. Now see, this is of single O, but you have to calculate for O2. You have to calculate for O2. That means 5 gram molecules of O2. How much? 5 grams, because it is 2, so you will divide by 2. That means 5 gram molecules of O2. So option number B, students, is going to be your correct answer. Option number B is going to be your correct answer. 10 gram molecules is only for oxygen. They are asking you only for a single oxygen atom, but they are asking you to the number of gram molecules of oxygen. What is oxygen? Oxygen is always written as O2. So that means we have to calculate for O2, right? For O2 it is going to be 5 gram molecules. Let us see the next question, that is question number 13th. Question 13th is number of oxygen atoms in 4.4 gram of CO2 is. A option 1.2 into 10 raised to the power 23, B option 6 into 10 raised to the power 22, C option 6 into 10 raised to the power 23, and D is 12 into 10 raised to the power 23. Right? Now let us see over here. Number of oxygen atoms they are asking. So what is number of oxygen atoms? It will be equal to number of moles into Avogadro number into total atoms. What is number of moles given mass? That is 4.4 by molecular mass. The molecular mass of CO2. How many carbon? 1. How many oxygen? 2. So 1 into 12 plus 2 into 16. That means 44 grams. Into Na is 6 into 10 raised to the power 23. Why I have not written 6.022 into 10 raised to the power 23? Because over here if you'll see the answer is in one decimal place only. So I have directly written 6 into 10 raised to the power 23 into total atoms. In the case of CO2, how many oxygen are there? 2. So you'll write 2 over here. The 4.4 can be written as 44 by 10. And here we have 44, they will get cancelled. We have 6 into 10 raised to the power 23 into 2. Now 6 into 2 is 12. 12 by 10 into 10 raised to the power 23. That means it is 1.2 into 10 raised to the power 23. So which of the following is the correct one, ma'am? Option number A is the correct one. Option number A is the correct one. Yes, everybody. Yes, everybody. Clear? Clear to everyone? Shall we move on to the next question if it is clear, everybody? Okay, let us see your question number 14 for now. Your question number 14 is, an organic compound contains 78% carbon and remaining percent of hydrogen. The right option for the empirical formula of the compound is, whose atomic weight of carbon is 12 and hydrogen is 1. The empirical formulas are written over here. I am giving you 2 minutes in order to think about it, and then we are going to solve this question out. Giving you 2 minutes to think about it. Shall we? Okay. Now let us write element over here. Then let us write percentage composition. Then let us write atomic mass. After that, let us write percentage by atomic mass. And then we are going to write simplest ratio. Yes, everyone. So see over here, they have given us a compound containing 78% by weight of carbon and remaining of hydrogen. So it basically has two elements, carbon and hydrogen. What is the percentage composition for carbon, ma'am? 78%. And for hydrogen, they are saying remaining is hydrogen. That means hydrogen will be how much? It will be 100 minus 78. That means it is 22%. How much it is? 22%. So yes, it is 22. Now what is the atomic mass of carbon? 12. For hydrogen, 1. What you have to do is divide percentage by atomic mass. Percentage over here is 78. Atomic mass is 12. Percentage over here is 22. Atomic mass is 1. This comes out to be 22. This comes out to be how much, ma'am? 22. And if we'll go with on the table of 6, 12 6 is 72. So this comes out to be 6.5. This comes out to be 6.5. Now what do you have to do in simplest ratio? Among these two numbers, which is the smallest one? 6.5 is the smallest one. So what you're going to do? Divided by that only. 6.5 divided by 6.5. This comes out to be how much? This comes out to be 1. Now the rest is 22 divided by 6.5. We have to divide with the smallest number. 22 divided by 65. Right, everybody? So this will come out to be how much? This will be 20. 10 will go above. Divide by 65. On the table of 2, 110. Sorry. On the table of 5, it will be 44 and it will be 13. 44 by 13. It is going to be approximately, if I divide 44 by 13, students, this comes out to be on the table of 3. 13 3 is 39, right? This comes out to be 3.3 approximately. How much, ma'am? 3.3. How much, ma'am? 3.3. This comes out to be 3.3, my dear students. That means approx value we can take 3. Now what is the round off of 3.3? It is 3 only. It is itself 3. So we have taken the value as 3. Now how many carbon, ma'am? Carbon is 1, ma'am. How many hydrogen, ma'am? 3. So the empirical formula is CH3. Empirical formula is CH3. So option number D is the right one. Option number D is the right one. Clear, everybody? Clear, everyone? Yes. Shall we move on to the next question if it is done? Take a screenshot of this now. Moving on to the 15th question of ours. Okay, let us see your question number 15th. Written, everyone? If it is written, shall we move on to the next question? Great. Now comes question number 15th. Question 15th is, an organic compound contain carbon, hydrogen and oxygen. Its elemental analysis gave carbon 38.71%, hydrogen 9.67%. The empirical formula of the compound would be. The empirical formula of the compound would be. Now options are CHO, CH4O, CH3O, CH2O. Right? Now see over here, write elements. Then write percentage composition. Then write atomic mass. After that, write percentage divided by atomic mass. And then write the simplest ratio. Clear? Now, what are the elements, ma'am? It is carbon, hydrogen, oxygen. What is the percentage of carbon? Ma'am, it is 38.71. What is percentage for hydrogen? 9.67. What is for oxygen? For oxygen, they have not given you. So, you'll calculate for oxygen. Ma'am, but smallest number is 22. How 6.5? 6.5 is smallest number or 22 is smallest number? 22 is the largest number, no? What are you doing? Yes. Now see, for oxygen, percentage will be 100 minus how much? It is 38.71 plus 9.67. So it is 100 minus, right? So this comes out to be 1 second, students. This comes out to be 51.62%. 51.62%, right? Now, percentage of atomic mass of carbon is 12, hydrogen is 1, and oxygen is 16. Yes? Oxygen is 16. Yes, everyone? Now, what's the next part? Now, what's the next part, ma'am? We have to divide it. So, this is 38.71 divided by 12. This is 9.67 divided by 1. This is 51.62 divided by 16. So, this, students, comes out to be near 3.3 something. This is 9.6. And this also comes out to be 3.3 something. 3.3 something. When you're going to divide it, it will be 3.3 or 3.22 something. On the table of 12, 3 is 36, 2, then we are going to get, yes. It is 3.2 something. It is 9.6, it is 3.2. Right? Now divide by the smallest number. Smallest number is 3.2. So 3.2 by 3.2 is 1. 9.6 by 3.2 is how much? It is 3. Now 3.2 by 3.2 is again 1. How many carbon, ma'am? 1. How many hydrogen? 3. How many oxygen? 1. So CH3O is going to be the correct answer. That means, ma'am, option number C is the correct answer. Option number C is the correct answer. Clear? Yes? Yes, students. Where is your spirit? Everybody, I want your answer in the comment section. Yes, everyone. So, yes, option number C is the correct answer. Shall we move on to the next question of ours for today? Okay, now comes your question number 16th. Now comes your question number 16th. What mass of 95% pure CaCO3 will be required to neutralize 50 ml of 0.5 molar HCl solution according to the following reaction? You have been given with the 4 options. This is your question number 16th. This is your question number 16, students. So think about it. Shall we do this now? See. What mass of 95% pure CaCO3 will be required to neutralize 50 ml of this much HCl solution? Now see, can we calculate the number of moles of HCl if volume and molarity is given? Yes, ma'am. See, basically, what is the molarity? Molarity, ma'am, is number of moles by volume of solution. Right? What is molarity? 0.5. Number of moles by what is volume? 50 ml. Now we always take volume in liters. That means if it is in ml, that means we have to divide it by 1000. So 0 will get cancelled. Let us cross multiply. What is number of moles? 0.5 can be written as 5 by 10 into 5 divided by 100. This is what will happen over here. So this comes out to be 25 divided by 1000. That means it is 1 by 40. How much, ma'am? 1 by 40. How much, ma'am? 1 by 40. This is what? This is number of moles? Yes, ma'am. Now let us see, for they are asking how much mass of 95% pure CaCO3. So let us write the reaction. CaCO3 plus 2HCl gives CaCl2 plus CO2 plus water. See over here. Here 2 is written. Right. Now just see over here. 2HCl is reacting with 1 CaCO3. I can write 2HCl is reacting with 1 CaCO3. 1 HCl will react with how much? It will be 1 by 2 CaCO3. And this much moles of HCl will react with 1 by 40 moles of HCl. Will react with how much? It will be 1 by 2 into 1 by 40 moles of CaCO3. That means 1 by 80 moles. That means how much moles of CaCO3 produced? How much moles of CaCO3 produced, ma'am? 1 by 80. Yes. Now can we calculate mass? Can we calculate mass? Number of moles we have with us is 1 by 80. It is equivalent to given mass upon molecular mass for CaCO3. Calcium mass is 40 plus carbon is 12 plus 3 into oxygen is 16. So 40 plus 12 plus 48. This comes out to be 100 grams. Let us cross multiply. It comes out to be 100 by 80. That means 5 by 4. This is your given mass. This is your given mass, everybody. This is your given mass. Till here it is clear to everybody. We have calculated the given mass for CaCO3. This is for the case of CaCO3. This is for the case of CaCO3 and this is for HCl. Have we calculated the mass of CaCO3, everyone? Yes. Done. Now see, they are asking to calculate the mass for 95% pure CaCO3. So how much it will be? It will be 5 by 4 divided by 95%. So mass required is going to be how much? Mass required will be, it will be 5 by 4 divided by 95%. So what it will be? It will be 5 by 4 into 95 and here it will be 100. On the table of 5, if I go for, it will go by 19, it will go by 25. So this comes out to be 25 by 19. This comes out to be 25 by 19 students. That means nearly 1.32 grams. How much? 1.32 grams. So option number B is going to be the right answer. Option number B is going to be the right answer. How come option number C? How come option number C? It is in front of you. How come option number C, students? Clear? Shall we move to the next question? Kindly write it down. Then we can move on to the next question of ours. Done, everybody? Kindly write it down. Okay, let us see the next question. Yes. Taken screenshot. Okay, now comes question number 17th. Now comes question number 17th. What is the mass of precipitate formed when 50 ml of 16.9% solution of AgNO3 is mixed with 50 ml of 5.8% NaCl solution? Think about it once, students. This is a previous year question yet again. Think about it once. Yes, think about it once. What mass of precipitate formed when this much solution of AgNO3 is mixed with NaCl? AgNO3 mixed with NaCl. NaNO3 will be formed and AgCl will be formed. They are asking you the mass of precipitate formed. What they have given you 150 ml of this much solution. See, what do you refer to as 16.9%? It will be 16.9 grams in 100 ml. But this depicts in 100 ml. They are asking you when 50 ml is used. So in 50 ml, how much mass will be used? You will divide by 2. You will do it half because it is 100 by 2 is 50. No. They are asking in 50 ml. So what it will be basically? 18.45 grams. How much, ma'am? 18.45. Similarly, in this it is written 5.8%. That means 5.8 grams in 100 ml solution. But they are saying in 50 ml. With 50 ml you are doing. That means again you have to divide by 2. That means 2.9. That means how much? 2.9 grams everybody. 2.9 grams everybody. Now see here. Let us balance equation Ag. Nitrogen, oxygen 3, Na1, Cl1. Now see, we have to calculate mass of precipitate form. We have to calculate for AgCl respectively, right? Because precipitate is that. So 1 AgNO3 and 1 NaCl is producing 1 AgCl. First, let us calculate the limiting reagent. How we will calculate limiting reagent? Number of moles. Number of moles for AgNO3. For AgNO3, given mass is 8.45. By molecular mass of AgNO3. Molecular mass, Ag mass is 107.8 plus nitrogen mass is 14 plus 3 into oxygen mass, that is 16. This is 8.45 by 48 plus, this is 121 plus 48. 8.45 and this comes out to be 169. That means approximately 170 because it is going to be 121.8 plus 48. That means approximately 170. Now this is number of moles, right? Divide by stoichiometry is 1 over here. And for this case, given mass is how much, ma'am? 2.9. Divided by molecular mass. For Na it is 23 and for Cl it is 35.5. So this is 2.9 divided by how much? 0.58. 58.5. 58.5. If you are going to divide both of them, students, you will get your 0.049 and 0.049 respectively. Moles. Okay, now see. 1 AgNO3 is giving 1 AgCl. This much moles will give this much AgCl. So AgCl moles we have got. Number of moles is 0.049. But they are asking to calculate the mass. So it is given mass upon molecular mass. What is molecular mass for the case of AgCl? For Ag it is 107.8 plus for Cl it is 35.5. It is 143.3. How much it is? 143.3. Ma'am, can you explain but problem once again? Yes, I will explain. No need to worry. Now see, this is molecular mass. It is going to be 0.049 is equivalent to given mass upon molecular mass is 143.3. 143.3. Yes, everyone? Yes, everyone? Now when you're going to cross multiply them, what you're going to get your answer as? 7.02 grams. Approximately 7.02 grams. So the answer is going to be 7 grams. Answer will come out to be 7 grams. That means option number B. See, very simple question, but in a tricky way they have given you. Yes. Pooja is saying 7.1, approximately 7 answer is going to be there. Yes, option number B. Okay, Madhu is saying, can you please explain it again? Okay, I'll read it for you again. For once, kindly take a screenshot of this question. For once, you can take a screenshot. I'll explain you all over here again. Okay, now see students. They are saying, what is the mass of precipitate formed when 50 ml of 16.9% solution of AgNO3 is mixed with 50 ml of 5.8% of NaCl? Right? So students, over here, if you'll see, they have given us 16.9%. What is 16.9%? You have studied about mass by mass percent. You have studied about mass by volume percentage. So this is mass by volume percentage. See, that is 16.9 grams in 100 ml. Now, see, observe, this is in 100 ml, but they are asking when 50 ml is used. So that means you will divide it by, if you want 50 over here, you are dividing by 2. That means mass also will be divided by 2. Right? Similarly, in this also, it is 5.8%. That means 5.8 grams in 100 ml. So divided by 2, you will get 2.9 over here, right? That means given masses you have calculated. Molecular mass you can calculate with the mass given over here. You can calculate number of moles for both of them. Now, what is limiting reagent? Limiting reagent is the one which is going to help you calculate the values for the product. So, how to calculate limiting reagent? Number of moles by stoichiometry. Number of moles is given mass by molecular mass. Stoichiometry is the number that is present over here. So, both of the values comes out to be 0.049, 0.049. That means they have the same value. No one is the limiting reagent. So, we can say 1 AgNO3 is giving 1 AgCl. So, 0.049 will give how many AgCl? 0.049. Right? So, this is number of moles given mass upon molecular mass. Now, you have to cross multiply and you will get your answer. Great, everybody. Clear? Okay, giving you a minute in order to write it down so that we can move on to the next question of ours. Clear, everyone? Shall we move on to the next question? Okay, next question. Question number 18th now. Question 18th is, when 22.4 liters of H2 is mixed with 11.2 liters of Cl2, each at STP, the moles of HCl formed is equal to. The moles of HCl formed is equal to A, 1 mole of HCl, B, 2 mole of HCl, C, 0.5 mole of HCl, D, 1.5 mole of HCl. So yes, students, think about it, what they have given you. They have told you that when 22.4 liters of H2 is mixed with 11.2 liters of Cl2, you are mixing H2 with Cl2 and you are forming HCl, right? Yes, ma'am. Now let us balance this equation out. 2 will come over here, right? Now see, what else they have given you? They have given you that here 22.4 liters and it is mixed with 11.2 liters. Now see, understand. First of all, we have to calculate the moles of HCl. In order to calculate moles of HCl, we should know what is limiting reagent. How to calculate limiting reagent? Calculate number of moles. See, in this case, number of moles will be 22.4 liter by 22.4, because what is number of moles? Given volume by 22.4 liters. So this comes out to be, ma'am, 1. What is number of moles in this case? 11.2 liters divided by 22.4. That means 1 by 2. Right? Now, what is the limiting reagent? Number of moles by stoichiometry. What is stoichiometry? 1, 1 over here. So, 1 by 1 and it is 1 by 2 by 1. This is 0.5. Which is lower value? Ma'am, this is lower value. That means Cl2 is your limiting reagent. The one which has a lower value is the limiting reagent. The one which has a lower value is the limiting reagent. So, this is the limiting reagent. That means 1 Cl2 will give 2 HCl. See, the one which is limiting reagent will help you to calculate the answer for the product. The one which is limiting reagent will help you to calculate for the product. So 1 Cl2 is giving 2 HCl. So 0.5 moles will give how much HCl? It will be 0.5 into 2. That means 1 mole of HCl. That means 1 mole of HCl. That means 1 mole of HCl. So option number A over here is going to be your correct answer for this particular question, students. Option number A here will be your correct answer for this particular question. Clear, everyone? Clear? If it is clear to each and every one of you, kindly take its screenshot so that we can move on to the next question of ours. If it is clear to everyone, shall we move on to the next question of ours? Yes, students, kindly write it down. Take its screenshot. Okay, students. Now there is one question for you, homework also. Now there is one question for you as a homework also. Clear? Clear everybody? Okay, now comes your question number 19. See, when we are practicing, I want you all to participate also. So this question answer you have to write in the comment section just after the video ends. You can solve this question. You can take a screenshot of this question. This is your homework question. Question number 19th is your homework question with regard to the chapter Some Basic Concepts of Chemistry. From each chapter, I am going to give you one question as your homework. Okay? Now see, the question is 6.02 into 10 raised to the power 20 molecules of urea are present in 100 ml of its solution. Okay, what they're asking you the concentration of the solution is. The concentration of the solution is A is 0.001 molar, B is 0.1 molar, C is 0.02 molar, D is 0.01 molar. Right? You can take a screenshot of this question. This is your homework question for today for this chapter. Now let us see the next question. If everybody has taken a screenshot. Everybody has taken a screenshot of this question. Now comes your question number 20th. Let us read the question number 20th for you today. The question 20th is, in the reaction 4NH3 plus 5O2 gives 4NO plus 6H2O. When 1 mole of ammonia and 1 mole of O2 are made to react to completion, which of the following is going to occur? A. All the oxygen will be consumed. B. 1 mole of NO will be produced. C. 1 mole of H2O is produced. D. All the ammonia will be consumed. All the ammonia will be consumed. Think about it, students. What is given in this particular question? Ma'am, it is given as our reaction is 4NH3 plus 5O2 is producing 4NO plus 6H2O. Am I right? Yes. Now over here they are saying when 1 mole of ammonia and 1 mole of O2 are made to react. 1 mole of ammonia and 1 mole of O2. We have to answer in terms of either NO, H2O or oxygen. Okay, so what we are going to do is we are going to see the limiting reagent first of all. What is limiting reagent? How to calculate the number of moles by stoichiometric coefficient. What is number of moles? 1. What is stoichiometric coefficient? 4. So this is 0.25. And if I talk over here, it is number of moles is 1. What is stoichiometry? 5. It is 0.2. So which is the lower value? It is 0.20. It is 0. How much? 25. So this is the lower value. That means this is your limiting reagent. This is your limiting reagent. That means this is going to help you out to solve the question. Now see, if 5O2 is producing 4NO, 1 O2 will produce how much NO? 4 by 5 NO. And 0.2 moles O2 will produce how much? 4 by 5 into 0.2. That means 4 into 5 into 10. Right, everybody? That means 0.8 by 5. That means 0.8 by 5. Right? So option number B will be incorrect, that 1 mole of NO is produced. No, not at all. Now 1 mole of water is produced. See, 5O2 is producing 6H2O. 1 O2 will produce 6 by 5 and 0.2. That means 1 by 5 will produce how much? It will be 6 by 5 into 1 by 5. That means 6 by 25. So here also this is incorrect. 1 mole is not produced. Now all the oxygen will be consumed, all the ammonia will be consumed. See, which is limiting reagent? That will be consumed. So O2 will get consumed. It is the limiting reagent. So option number A is the right answer. Oxygen will get consumed because it is the limiting reagent. The other one will be your excess reagent. It will not get consumed. So option number A is your correct answer. Now students, this ends your very first chapter, some basic concepts over here. Now we shall start with the next chapter, that is structure of atom. Till then, giving you a minute in order to write this question. Yes, everyone, return. This ends your very first chapter, some basic concepts of chemistry. Now we shall start with structure of atom. Shall we? Okay. Now students, starting with your question number 21st, that is structure of atom or atomic structure. This is your question number 21st. Let me read question for you. From the following pair of ions, which one is not an isoelectronic pair? Which one is not an isoelectronic pair? A option Fe plus 2 Mn plus 2, B option O2 negative F negative, C option Na positive Mg plus 2, while D option Mn plus 2 Fe plus 3. So students, what do you refer to as isoelectronic? Isoelectronic is same number of electrons. What is isoelectronic, ma'am? Isoelectronic is same number of electrons. So you have to tell in which of the following it is not same. In which of the following it is not same? Yes, everyone. So go for it. Tell me fast. Okay, let us talk about the very first, Fe. What is the atomic number of Fe? What is the atomic number of Fe? Anyone in the comment section? What is the atomic number of Fe and Mn? Fe and Mn. Nada Nasreen has written A. Narottam has written A. Okay, that's good. Sneha has written A. Okay, that's great that your speed is increasing. Very good, students. Okay. Now see, if I talk in the case of Fe, what is the atomic number, ma'am? It is 26. See, if it is written plus 2, you are going to subtract 2. How much you are going to get? 24. How much you are going to get, ma'am? 24. How much you are going to get, ma'am? 24, right? And in the case of Mn plus 2, Mn is 25 atomic number. Plus 2 is written, so you are going to subtract 2. What you will get? 23. What you will get? 23. Are they same? No, ma'am. Are they same? No, ma'am. Are they same? No, ma'am. They are not same. That means it is not an isoelectronic pair. So hence we got as our answer as directly option number A. Hence we got our answer as directly option number A. Clear, everyone? Let us see the next question. Question number 22. Question number 22 is in front of you. The number of protons, neutrons and electrons in this selective element respectively will be what? A option 71, 104, 71. B option 104, 71 and 71. C option 71, 71 and 104. While D is 175, 104 and 71. Right? So giving you 1 minute to think about it, then I'm going to tell its answer. Yes, students. Okay, see over here. Now we have been given with the species as here 175 is written and here is 71. Let me tell you, the number that is written over here is your atomic number Z, and the number that is written over here is your mass number A, or the atomic mass. This is your Z or atomic number, or I would say protons. When it is a neutral species, it is protons. So protons you have got as your 71. Well, how you have to calculate neutrons? How neutrons are calculated? See, protons plus neutrons is equivalent to atomic number. Is equivalent to mass number. Protons is 71, neutrons we don't know, but mass number we know, it is 175. So what will be neutrons? 175 minus 71. So this is 104. How much, ma'am? 104. Okay, what is electrons? See, if it is a neutral species, number of protons is equivalent to number of electrons. So electrons is 71, neutrons is 104. So it is 71, 104 and 71. Hence option number A is going to be your correct answer. Hence option number A will be your correct answer. Clear, everyone? That's great. That's great. Kindly write it down or take a screenshot so that we can move on to the next question of ours. Now comes your next question, that is question number 23. Now comes your next question, that is question number 23. Question 23 is Be plus 2 is isoelectronic with which of the following ions? Beryllium plus 2 is isoelectronic with which of the following ions? A option is H positive, B is Li positive, C is Na positive, D is Mg plus 2. So see over here, students. Beryllium atomic number is what? 4, right? How many plus 2 is written over here? That means you have to subtract 2, you will get 2 electrons. How many? 2 electrons, right? Isoelectronics, that means same electrons. So in H positive, atomic number is 1, but plus 1 is written, so we'll subtract 1, 0 electron. Okay, hydrogen, helium, lithium. Lithium atomic number is 3. Here plus 1 is written, so you'll subtract 1, you'll get 2 electrons. Now in the case of sodium, atomic number is 11, but plus 1 is written, so you'll subtract 1, that is 10. In the case of magnesium, atomic number is 12, plus 2 is written, so you'll subtract 2, you'll get 10. They are saying Be plus 2 is isoelectronic with lithium positive. Over here also, it is having 2 electrons and it also has 2 electrons. Clear, everyone? Creator is saying Mg plus 2. How Mg plus 2? Mg plus 2 has 10 electrons. See, if it is a positive charge, that means you are going to subtract it. If it is a negative charge, that means you are going to add it. Positive 1 will be subtracted, negative 1 will be added. Clear? Kindly write it down, students. अंकित चौधरी सिंह मैम थोड़ा हिंदी में भी बोल दिया करिए, थोड़ा कम समझ आ रहा है. See, basically this is your English channel, so my priority will be English. But yes, if somewhere you feel like this question you are not able to understand, I will explain you in Hindi also, you can say over there. Okay? Okay, B is the right answer. Shall we move on to the next question as question number 23rd or 24th? Now comes your question number 24th. Question 24th is which one of the following is not isoelectronic with O2 negative? Which one of the following is not isoelectronic with O2 negative? Now I want its answer from you people, because we have done 2-3 questions based upon the isoelectronic spaces. Now this you should know. Very simple. See, if I talk about oxygen, 8 as the atomic number, right? Now -2 is written, so you are going to add 2, that means you are going to get 10 electrons, right? Now you have to check in all of these cases, in which of the following cases 10 electrons is not coming. In which of the following cases 10 electrons is not coming? It is very simple. Without looking to the question, you can itself tell. Why? Because you know the titanium atomic number is large. So how it can be? It cannot be. If I talk about sodium, its atomic number is 11. Plus 1 is written, so you'll subtract 1, 10 electron. In the case of nitrogen, you can do simply 7 electrons. -3 is written, so you are going to add 3. That means 10 electrons. Here again, 9. You are going to add 1. That means 10 electrons. Only titanium you already know. There is no need to even calculate. Because its atomic number is high, that means it is not going to have same electrons. So option number A is the right answer for this particular question. Kindly take a screenshot of this so that we can do the next question of ours. Now comes question number 25th. Let us see question 25th. Which of the following series of transition in the spectrum of hydrogen atom falls in the visible region? You have to tell which of the following will fall in the visible region. A. Bracket series. B. Lyman series. C. Balmer series. D. Paschen series. Think about it, students. They are asking in visible region. So students, let me tell you, Balmer series is the one which falls in visible region. It is the one which falls in visible region. Right, everyone? If I talk about Lyman, it will fall in UV. And if I talk about bracket series and Paschen series, it will fall in IR region, infrared region. So which of the following is the correct one which falls in visible region, ma'am? Balmer series. Option number C is the correct answer. Clear, everyone? Yes, yes. Exactly. Shall we move on to the next question? The next question is, this is your question number 26th now. The question is, the value of Planck's constant is 6.63 into 10 raised to the power minus 34 joule second. The speed of the light is 3 into 10 raised to the power 17. Which value is closest to the wavelength in nanometer of the quantum of light with a frequency of 6 into 10 raised to the power 15? Giving you 2 minutes in order to think about it. If anybody don't know that lambda is equivalent to C by V. C value they have already given you. They are asking you about wavelength, frequency they have given you. What is C value, ma'am? 3 into 10 raised to the power 17 divided by frequency is 6 into 10 raised to the power 15. This goes on the table of 2. This goes as 100. So it is 100 by 2. This comes out to be 50 nanometer. 50 nanometer. Option number A will be your correct answer. Clear, everyone? Clear, everyone? Everybody, is it clear? Is it clear? Yes, 50. Yes, 50. Ananya is saying C. How C, Ananya? Vani is saying A. Very good. Sneha is saying A. Very good. Now let us see question number 27th. Question number 27 says that the energies E1 and E2 of two radiations are 25 electron volt and 50 electron volt respectively. The relation between their wavelength, that is lambda 1 and lambda 2, is going to be what? You have to calculate the relationship. A option is lambda 1 is equals to lambda 2. B option is lambda 1 is equals to twice of lambda 2. C option is lambda 1 is equals to 4 into lambda 2. While D option is lambda 1 is equals to half into lambda 2. Now think about it, students over here. Think about it. What is the formula of E? Ma'am, energy is hc by lambda. So if I talk, what will be E1? E1 will be hc by lambda 1. What will be E2? hc by lambda 2. H is Planck's constant, c is speed of light, right? Now see, that means I can say that if I have to divide E1 by E2, what it will be? It will be hc by lambda 1 divided by hc by lambda 2. hc will get cancelled. What we will get? E1 by E2 is equivalent to lambda 2 by lambda 1. Now what is E1 by E2? E1 value is 25 and E2 value is 50. It is equivalent to lambda 2 by lambda 1. 25 2 is 50. So 1 by 2 is equivalent to lambda 2 by lambda 1. Let us cross multiply. Lambda 1 is twice into lambda 2. Lambda 1 is twice into lambda 2. So option number B, my dear students, will be your correct answer. Option number B will be your correct answer. Right, everyone? Clear, everyone? Shall we move on to the next question if it is done? Shall we move on to the next question if it is done, students? Okay, let us see question number 28 now. Question 28 is, for the given energy, E is equals to 3.03 into 10 raised to the power minus 19 joules. Corresponding wavelength is, you have to calculate the value of wavelength. H value is being given to you. What is the value of H? 6.626 into 10 raised to the power minus 34 joule second. C value is 3 into 10 raised to the power 8 meter per second. Right? So basically, what is the formula? It's very simplest formula again. Here lambda is equals to C by V. Same formula. You have to calculate wavelength. What is the value of C over here? Now, this is simplest formula. This is the simplest formula. Or here you see, sorry, now only I have written E is equals to hc by lambda. Sorry, kindly correct it. E is equals to hc by lambda. So over here, for the given energy, E value is 3.03 into 10 raised to the power minus 19 is equals to, what is the value of H? 6.626 into 10 raised to the power minus 34. This is Planck's constant into C. C is 3 into 10 raised to the power 8 by your lambda. Now what will be lambda? Lambda will be 6.626 into 10 raised to the power minus 34 into 3 into 10 raised to the power 8 divided by 3.03 into 10 raised to the power minus 19. Let us divide on the table of approximately 2. I will calculate answer in approx values. I'll let you know how to calculate answer in approx values. Now this is going to be 2 into 3, that is 6 something, into 10 raised to the power. See, when this will go, this will become a positive value, 27. 27, if you're going to subtract, that means 10 raised to the power 7 something will come. The approx answers, when you're going to calculate, this comes out to be your 656 nanometer. Answer will come out to be approximately 656 nanometers. Students, please forget about the comment section. Kindly study about this. Okay, kindly see the question over here. Ma'am, what's your name? My name is Shaurya Grover. Okay, clear? Now let us focus over here. This is option number D. Kindly take a screenshot of this question so that we can start with your question number 29th. If everybody has taken the screenshot, let us start with question number 29th. Yes, everyone, clear? Okay, shall we go with next question of ours? Done with this question. Now comes your question number 29th. Question 29th is, if radius of second Bohr orbit of helium plus 2 ion is 105.8 picometer, what is the radius of third Bohr orbit of lithium plus 2 ion? A option is 158.7 picometer, B option is 15.87 picometer, C option is 1.587 picometer, while D is 158.7 picometer. Ma'am, any shortcut to reduce the calculation? See, in the previous one, I don't feel there was any such calculation. I just told you to calculate the approx answers, and then you're going to see the 10 raised to the power something, right? So you have to calculate the approx answer. That's it. Approx answers. You don't have to see here. Also, I've written approx value. I've not calculated exactly. So I've got my answer as that 6 will come over there. But now when it is into 10 raised to the power something, then I calculated it will come exactly approx answer. That is 656 nanometer. Coming back to the question, giving you 2 minutes in order to think about it. The radius they have provided you, and the radius are asking for the another lithium plus 2. For the third orbit of lithium plus 2. You all very well know that radius is equivalent to R naught into n square by z. N basically is your shell number or the orbit number, I would say. Z is your atomic number. Now here we are talking about second Bohr orbit of helium plus 2. Second Bohr orbit of radius of this is given. Radius is 105.8. R naught value we can calculate. What is n square by this? Second Bohr orbit. N is 2 over here. Now for whom? For helium plus 2. Hydrogen, helium. Hydrogen, helium, lithium. Helium is second. Atomic number is 2 now. Let us solve it out. See what you will get. 2 into 2 is 4. So basically it is 105.8 divided by how much? 2 will come. 4 by 2 is 2. So you'll cross multiply it. This is the value of R naught. This is the value of R naught. Right? Now the next is we have to calculate the radius for the third Bohr orbit. Again, the radius is equivalent to R naught into n square by z. Now what is the value of radius? We'll calculate. For whom? For Li plus 2. See, R naught value we have calculated, it is 105.8 by 2 into what is n square. We have to calculate for third orbit, that means 3 square divided by for whom? Lithium. Hydrogen, helium, lithium. Lithium is going to be your third. What you will get? 105.8 by 2 into 9 by 3, that is 3 over here. Now this is 1058 by 10 into 2 into 3. This you are going to solve it 5. Then you'll go on the table of 2, 9. Okay. This comes out to be how much? 2 carry 6, 8, then 15 divided by 10. It is 158.7. 158.7. Answer is going to be 158.7. Clear, everyone? Answer is going to be 158.7 picometer. Clear, everyone? Mohammed Shariq is saying, ma'am, my answer is wrong again. No need to worry. This is your just a practice session. If your answer is wrong, You can correct your answer. You can understand from your mistakes, learn from your mistakes, and never repeat them all over again. Clear? So the answer comes out to be option number A for this question. This is question number 29. Kindly take a screenshot. Now we shall move on to the question number 30th. We shall see our next question, that is question number 30th. Shall we? Shall we, ma'am? Okay, next question is question number 30th. Questions 30 state that according to Bohr theory, which of the following transition in the hydrogen atom will give rise to the least energetic photon? The question is, they are saying, according to the Bohr theory, which of the following transition in the hydrogen atom will give rise to least energetic photon? A, n is equals to 6 to n is equals to 1. B, n is equals to 5 to n is equals to 4. C, n is equals to 6 to n is equals to 5. While D is basically n is equals to 5 to n is equals to 3. Think about it. Which formula? About delta E, it will be 1 by n1 square minus 1 by n2 square. It is directly proportional to that. You are going to use this formula. So think about it. How to solve this question out. Yes, students. I have already told you. Delta E will be directly proportional to 1 by n1 square minus 1 by n2 square. So when I'm going to see the transitions over here from n6 to n5, this is going to be our correct answer. This is going to be, yes, C option. Very good, very good. Anushka, Nadha, very good. It is going to be our correct answer. Great. Option number C is going to be our correct answer for this particular question. Done, everybody? Kindly write it down. Now let us move on to the next question of ours. Shall we move on to the next question? Okay. Let us do this question first of all. This is question number now your 31st. This is your question number 31st. The energy of an electron in the nth Bohr orbit of hydrogen atom is. The energy of an electron in the nth Bohr orbit of hydrogen atom is 13.6 by n4 electron volt, 13 by 6 by n cube electron volt, 13.6 by n square electron volt, and 13.6 by n electron volt. This is the direct formula, students. This is your direct formula. Yes, C is going to be correct answer. It is minus 13.6 n square electron volt. Yes, everybody. C is your correct answer for this particular question. Shall we move on to the next question? That is question number 32. Shall we move on to the next question? Okay. Now let us see the next question of ours. That is question number 32. Question 32 is, the spectrum of helium is expected to be similar to that of. The spectrum of helium is expected to be similar to that of A option hydrogen, B lithium positive, C Na, and D is neon positive. Now see, helium, hydrogen, helium. Helium basically has atomic number as what? Your 2. Right? Atomic number has 2. Okay. If I ask you about how many electrons will be there, electrons will be 2 because it is neutral. Right. So over here, ma'am, it is 2 electrons. Now in the case of hydrogen, how many electron? 1 electron. In the case of lithium, hydrogen, helium, lithium, atomic number is 3. Plus 1 is written, so you'll subtract 1, you'll get 2 electrons. How much? 2 electrons. You'll get how much? 2 electrons. In this case, sodium, it is 11. Now, in the case of neon also, how it is possible that 2 electrons will come? That means 2 electrons and 2 electrons. That means option number B is going to be right answer. Clear? Very good. Very good, everybody. Option number B is going to be right answer. Why? Because helium contains 2 electrons each, right? Okay, let us see question number 33rd now. have solved Hello, hello, hello. Okay, students. So now you can hear me? Yes, everybody. Now you can hear me? My voice is audible or not? Please let me know in the comment section. Checking, checking. Oh yes, voice is now back. So we shall smile now. Yeah, right? So now, yes, shall we proceed? Everybody? It's working? Yes? Okay, you can hear. That's great. That's great. Okay, coming back to the question. Coming back to the question. Everybody has done this question. Shall we proceed to the next question of ours? Okay. That's great. That's great. Oh my God. You got so worried, no? Yeah. It's okay. It's fine. It's fine. Okay. So now students, after a break of quite 2 to 3 minutes, we shall proceed to the next question of ours, right? Shall we proceed to the next question of ours? Everybody ready? Okay. Now comes your question number 34. Do I need to explain this question again? Anybody? Do I need to explain this question again? If yes, then please let me know. Ma'am, please explain again. Or shall we move on to the next question of ours? Yes. Yes. Shall we move on to the next question of ours, or do I need to explain it all over again? Okay, once explain. Okay, see. A 0.66 kg ball is moving with the speed of 100 meter per second. The associated wavelength will be how much? Okay. Now see, over here they have given you some options, right? We know that lambda is equals to h by mv, right? And then we just have to equate all the values. H is your Planck's constant, right? Okay. Then mass is given to you, velocity is given to you. You just have to equate it. You just have to write all the possible given situations. Ma'am, is it possible to get 80 marks from studying now? See, it depends upon how you study. See, smart work is also really very important. The topics that are most important, focus on them and do not panic in last situation, and solve all the questions that we are doing in today's session, because this is really based upon the previous year segment, right? Okay. Now comes your next question. Question number 34th. Question number 34th. 34th question is, in uncertainty in position and momentum are equal. If will come over here. If uncertainty in position and momentum are equal, then uncertainty in velocity will be. You have been provided with 4 options, my dear students, over here. You have been provided with 4 options over here. What do you feel is the right answer? Yes, everybody. What do you feel is the right answer? If uncertainty in position and momentum are equal. Now here you have to use Heisenberg's uncertainty principle. Heisenberg's uncertainty principle you have to use over here. Right, everyone? Kindly focus on your questions, students. Your time is really very crucial. It is really very crucial. What is this? This is the change in momentum, uncertainty in momentum into uncertainty in position is more or less equal to h by 4 pi. Yes, everyone? Yes, everyone? Okay, answer I am already getting. Answer is option number D, students are saying, but everyone has done or not? Everybody has done or not? Now see, we know that momentum is m into delta v. Now into delta x is more or equal to h by 4 pi. Now see, they have said that they both are equal. So can I write it like this? Whole square by h by 4 pi, because it is same. Right? What will be my delta v square? It is more or equal to h by 4 pi m square. What will be my uncertainty in velocity? It will be more or equal to root of h by 4 pi m square. Now one m will come out. It will be equivalent to what? 1 by 4 can be is 2 into 2. So 1 by 2 will come out. M will come out. What we will be left with? H by pi. So is this equivalent to option number C? Is this equivalent to option number C? Why you are saying D? I am not getting my point. Why you are saying D? Where is M gone? Why you are saying D? Where is M gone? Option number C is going to be correct answer for this particular question. Option number C is going to be your correct answer for this particular question. Clear, everyone? Shall we move on to the next question of ours? Shall we move on to the next question of ours? Yes, C is the right one. Okay, let us see your question number 35 now. Question number 35 is, the uncertainty in momentum of an electron is 1 into 10 raised to the power minus 5 kg meter per second. The uncertainty in its position will be what? You have to tell the uncertainty in its position. Yes, students, you have following 4 options over here with you. Yes, now see. Basically, we know that uncertainty in momentum into uncertainty in position is more or equal to 4h by 4 pi. Now, over here, the uncertainty in momentum is given to us, that is 1 into 10 raised to the power minus 5. Into uncertainty in position, you have to calculate, is equivalent to h is 6.62 into 10 raised to the power minus 34 divided by 4 pi. 4 into, now pi value is 22 by 7 or 3.14, whatsoever you want to equate. What will be delta x? It is uncertainty in position 6.62 into 10 raised to the power 34 divided by 4 into 3.14 into 10 raised to the power minus 5. This you will take over here. This you will bring over here. Yes, everyone? Now, approx answer we will calculate. See this, let us consider that it is 6, it is 3. So, approximately 2 into 2 is 4. Now, approx answers again and again I am speaking in front of you that we are going to calculate. Let us take this over here. What we will get over here? We will get as 29. Now, this will be 0.5 something that we are going to calculate. It is 1 something, that means 0.5 into 10 raised to the power 29 something. 0.5, that means if I come in the terms of 5, if I talk in the terms of 5, what it will be? If I talk in the terms of 5, it is coming out to be 0.5 into 10 raised to the power minus 29 something. When I am writing in terms of 5 point something, it will be 10 raised to the power minus 30. That means option number A is going to be your correct answer. Approx answer will be option number A. Option number A will be your right answer. Shall we move on to the next question if it is done? Now let us move on to question number 36 if it is done. Everybody. Okay, now comes your next question, question number 36. Question 36 is basically, the position of both an electron and a helium atom is known within 1 nanometer. Okay. Further, the momentum of the electron is known within 5 into 10 raised to the power minus 26 kg meter per second. The minimum uncertainty in the measurement of the momentum of the helium atom is what? A option is given to you as 8 into 10 raised to the power minus 26 kg meter per second. B is given as 80 kg meter per second. C is given as 50 kg meter per second, while D is given as 5 into 10 raised to the power minus 26 kg meter per second. Think about it, students. What will be your answer? Now see, according to Heisenberg uncertainty principle, if I talk about the uncertainty in momentum, their product, the uncertainty in momentum and the uncertainty in position, the value will become out to be a constant value. So, if we can see over here that their uncertainty in position is same, then uncertainty in momentum will also remain same. Hence, option number D is going to be your correct answer. Option will be option number D. Right? Clear? Shall we move on to the next question? This is your question number 36. Moving on to question number 37. Now we shall move on to the question number 37th of ours. Okay. This is your question number 37, students. Let us see this now. Question 37 is, which of the following statements do not form a part of Bohr's model of hydrogen atom? Which of the following statements do not form a part of Bohr's model of hydrogen atom? A. Energy of the electron in the orbits are quantized. B. The electron in the orbit nearest the nucleus has the lowest energy. C. Electrons revolve in different orbits around the nucleus. D. The position and the velocity of electron in the orbit cannot be determined simultaneously. Now students, think about it once. What will be your answer? C. Energy of an electron in the orbit are quantized. This we talk in the Bohr's model of atom. Electron in the orbit nearest the nucleus has the lowest energy. This is also discussed in Bohr's model. Electron revolve in different orbit around nucleus in Bohr model. But if I talk about uncertainty in position and velocity, this we talk in the topic Heisenberg uncertainty principle. Heisenberg uncertainty principle. Hence, this is not yet, not the topic that we discuss in Bohr model. So, option number D is going to be your correct answer. Option number D, students, is going to be your correct answer. Let us move on to your question number 38 if it is done, everybody. Let us move on to your question number 38 if it is done, everybody. Shall we? Shall we? Great. Now comes your question number 38. Question number 38. What is the question? Identify the incorrect from the following. Identify the incorrect from the following. A is all the 5d orbitals are different in size when compared to respective 4d orbitals. B is all the 4d orbitals have shapes similar to the respective 3d orbitals. C is in an atom all the 3d orbitals are equal in energy in free state, while D is the shapes of dxy, dyz and dzx orbitals similar to each other, and dx square, y square and dz square are similar to each other. Think about it, students. Think about it once. Identify the incorrect one. Identify the incorrect one, everyone. Identify the incorrect one. Statement of the following. Yes, okay, let us talk. All the 5d orbitals are different in size when compared to respective 4d orbitals. Is this the correct one or the incorrect one? Yes. Next, all the 4d orbitals have shapes similar to the respective 3d. Okay, 3d will have same. Okay, in an atom all the 5d orbitals are equal in energy in the free state. Yes. Now see, the shapes of dxy, dyz are similar to each other, and dx square and dz square are similar. No, dz square shape is different. dz square shape is different. So this is wrong. This is the incorrect one. So option number D is going to be your right answer because this is the incorrect one. The shape is different for the case of dz square. Yes, everybody, D option. Sneha, Subramaniam has written B, Sneha has written D, Yaku has written D, Lakshmi has written D. Good. Priyanka has written D. Great. Shall we move on to next question if it is done, everyone? Shall we move on to our question number 39 if it is done? Question number 39 is in front of you now, everybody. Question number 39 is over here. Question 39 is 4d, 5p, 5f and 6p orbitals are arranged in the order of decreasing energy. Are arranged in order of decreasing energy. The correct option is, you have to tell the correct option. In the decreasing energy, you have to tell. Now this over here, which rule will be followed? N plus L rule. Which rule? N plus L rule. So just apply the N plus L rule. Higher the value of N plus L rule, higher is the energy. Very simple rule. See, in the case of 4D, what is N? The number that is written over here is N. And L, see, L basically, if it is 0, then it is S. If it is 1, then it is P. If it is 2, it is D. If it is 3, it is F. Now, for the case of D, L value is 2. So, N is 4 and L is 2. That means 6 for this case. Now, for next one, 5P. N is 5 plus what is L? L for P is 1. It is also 6, ma'am. Now for the next one, 5F. N is 5. What is F, ma'am? F is 3. L is 3 for the case of F. It comes out to be how much? 8. At last, what we have? 6P. N is 6 and what is P? P is 1. So this comes out to be 7. Highest is 5F. Highest is 5F, then 6P. 5F, then 5F, 6P. This is wrong. This is wrong. 5F, then 6P. Anyone? Now see, lower the value of N, lower will be the energy. If it is same, here it is 6, here it is 6. Lower the value of N. N here is 4 and here is 5. Lower will be the energy. So 4D will have the lower energy and 5P will have more energy. So option number B is going to be the correct answer. Clear, everyone? Option number B. Yes, everybody. Awesome World, Lakshmi, Kavishri, Sneha, Subramaniam. Yes. Clear? Subramaniam is saying A. How A? B is going to be a correct answer. If the values are same for our N plus L, lower the value of N, lower will be the energy. Clear, everyone? Clear, everyone? Yes? Great. Shall we move on to the next question? Now comes your question number 40th. Now comes your question number 40th. Question 40 is basically orbital having 3 angular nodes and 3 total nodes is. Orbital having 3 angular nodes and 3 total nodes is. A is 5p, B is 3d, C is 4f, D is 6d. Now tell me fast. Tell me fast, students. See, total nodes. Angular nodes formula is very simple. If you don't know, angular nodes value is equivalent to L. And angular nodes is L. What is the value of another node, spherical nodes? It is N minus L minus 1. If I talk about spherical nodes, it is N minus L minus 1. So what will be total one? Total is L plus N minus L minus 1. This will get cancelled. You will get N minus 1. Now they are saying orbitals having 3 angular nodes. That means L value is 3. 3 total nodes. That means this is 3. So N minus 1 is equal to 3. N is equals to 3 plus 1. That is 4. N value is 4. See, if N value is 4 and what is L? L basically comes out to be how much? 3 angular nodes. L is 3. So L for 0 is S, for 1 it is P, for 2 it is D, for 3 it is F. So F will come over here, 4F. So answer is going to be 4F. That means option number C is going to be your correct answer. Yes, exactly students. Exactly Sneha, Shahrukh, exactly. Dipta, exactly. Afipa, exactly. Answer is going to be your option number C. Clear everybody? Clear everyone? So shall we move on to the next question? Your question number 41 if it is done. Shall we move on to question number 41 if it is done? Okay, let us see your question number 41 for now. Question 41 is, how many electrons can fit in the orbital for which n is equals to 3 and L is equals to 1? A is 2, B is 6, C is 10, D is 14. Yes students, see for this question, n value is 3, L value is 1, L is 0 for S, 1 for P. Yeah, that means 3p. How many electrons can fit in the orbital? In 3p, how many electrons can be filled, ma'am? 3p orbital. Now, we are talking about orbital. Just remember orbital. One orbital can exhibit only 2 electrons. That means 2 electrons. Don't put the value as 6. You will get your answer wrong. They are asking you about an orbital. An orbital can accommodate only 2 electrons. Orbital, they are talking about orbital, students. Clear? Clear everybody? Shall we move on to the next question? Okay, shall we move on to the next one? Now comes your question number 42nd. 42 question. 42 question is, which of the following pairs of d orbitals will have electron density along the axis? Along the axis. A option is dz square dxz, B is dxz dyz, C is dz square dx square minus y square, D is dxy dx square minus y square. Now it is very simple. See, if I am taking it as x, if I am taking it as y, how is dxy made? Anybody? How is dxy, dzx, dxz made? Along the axis or in between the axis? Along the axis or in between the axis? It will be made like this. If I talk about dyz, if about xz, in between the axis. Now if I talk along the axis, that is going to be, this is your x, this is your y. This is dx square y square. This is along the axis. And last is dz square. That is also along the axis. So dx square y square and dz square, that is along the axis. So option number C over here will be your right answer. Yes everybody, option number C over here will be your right answer. Clear? Clear? Okay, let us see your question number 43rd now, 43. Question 43 is, 2 electrons occupy the same orbital are distinguished by. Two electrons occupying the same orbital are distinguished by A. Azimuthal quantum number, B. Spin quantum number, C. Principal quantum number, D. Magnetic quantum number. Yes, students. They differ by what? They differ by what? Two electrons will differ by what, ma'am? Very simple question. See, no two, exactly, B answer. B, why? Either one will have plus half spin or the another one will have minus half. Either one will show clockwise, other one will show anti-clockwise, right? So, option number B over here is going to be your right answer for this particular question. Shall we move on to question number 44? Okay. Now comes your question number 44. Question 44 is the number of d electrons in Fe plus 2 is not equal to number of electrons in which of the following? Number of d electrons in Fe plus 2 is not equal to number of electrons in which of the following? Now see, atomic number is 26 for Fe. How we are going to write? Argon, 18 electrons are already there, 8 electrons yet to be filled. So it is basically 4s2 3d6. Yes, everybody, 4s2 3d6. Is there any doubt over here? Is there any doubt over here, students? So in Fe plus 2, what will happen? In case of Fe plus 2, 2 electrons will move from here. What you will be left with? You will be left with 3d6. 4s2 will be 0. 4s2 will be 0. Now over here is equal to which one of the following? See, d electrons in Fe. It is equivalent to d electrons in Fe. Yes, in Fe how many d electrons are there? 6. So it is 6 over here. Yes, so simple, ma'am. P electrons in, see, option is in front of you. You don't have to move on to the other questions. Option is in front of you. But see, one thing. Here you need to check that you are saying d electrons in Fe. Here you are saying d electrons. See, read the question. The number of d electrons in Fe plus 2 is not equal to the number of electrons in which of the following? Here they are asking you is not equal to which one of the following? Here it is equal to 6. So answer is in which it is not equal. This is right. This is the right. 6 is there. In neon Z is 6. Z is 10. Now see, right, for Z is 10 in p electrons. Now for this configuration you can put 1s2, 2s2, 2p6, how much? 2 plus 2, 4, 4 plus 6 is 10. Now p electrons, how many p electrons? P is also 6, 6 electrons, 6 electrons. This is also right. Now in magnesium, it is going to be 1s2, 2s2, 2p6, 3s2, how much? 12. Now s electrons, if you have to see in magnesium, 2 plus 2, 4, 4 plus 2 is 6. In S also 6. Now in this p electrons in Cl, Cl is 17. 1s2, 2s2, 2p6, 3s2, how much it is? Now see, now here will be 3p, 3p will be how much? Now see, it is 2 plus 2, 4, 10, 12, 12, how much are left, ma'am? 5 are left, 3p, 5. P electrons are 5, this is not same. P electrons are 6 plus 5, 11, 11 electrons, which is not same. Total 6 plus 5, 11, which is not same. Clear everyone? Which is not same. Hence option number D is going to be right answer. Yes, everybody, option number D is going to be right answer for this particular question. What is an interesting question? It is a previous year one and also an important one. Clear everyone? Shall we move on to question number 45? Now comes your question number 45. Let us see question 45. The angular momentum of electron in d orbital is equal to. The angular momentum of electron in d orbital is equal to A, 2 by root 3h, B, BH, C, root 6h, and D is root 2h. Root 2h. Angular momentum basically is L plus 1 h. Now see, basically this is your angular momentum. This is your formula that you are going to apply for angular momentum. Now in the case of d orbital, what is the value of L? See, L for S is 0, for 1 it is P, for 2 it is D. That means for D it is 2, so 2 plus 1 into H. Now see over here, it is root 2, 2 into 3 H. what you are going to get over here? Root 6h. Option number C is going to be the correct answer. Option number C is going to be the correct answer. Clear? Yes. Joshni, Kavishri, Muhammad, exactly. Everybody. Shivanshu, great. D is the correct one. Shall we move on to the next question if it is done? Shall we move on to the next question if it is done? Okay. Okay, students, now just see your next question. This is your question number 46 now. Question 46 is maximum number of electrons in a subshell with L is equals to 3 and N is equals to 4 is. With L is equals to 3 and N is equals to 4 is. So students, you have options over here as A option 14, B option 16, C option 10, while D option over here is 12. So be fast. Now we are going to complete our second chapter over here after question number 50th. So be fast everybody. Maximum number of electrons in a subshell with L is equals to 3 and N is equals to 4 is. Now see, L will be 3 where? L will be 3 where? When L it is 0, it is S, it is 1, it is P, it is 2, it is D, right? So it is 3, it is F. It is 3, it is F. Now N4, that means it is 4F. That means it is what, ma'am? It is 4F. Now in F, how many electrons will be there? 14 electrons. Very simple. Very simple. Yes. So option number A over here is your correct answer. Option number A over here is your correct answer. Clear everybody? Shall we move on to the next question of ours? Now comes your next question, that is your question number 47th. Question number 47th. Sorry. Question number 47th. If N is equals to 6, sorry, really sorry. If N is equals to 6, the correct sequence for filling of electrons will be. If N is equals to 6, the correct sequence for filling of electrons will be what? Be fast, my dear students. This is very simplest question. This is the very simple question. Be fast everybody. A, okay. Dipta is saying A, Ramesh is saying A, Alpha is saying S, where is S? Okay, A, Shivanshu, A, yes, exactly everybody. A is going to be your correct answer. Put value of over here, it is 6S, 4F, then 5D, 6P. Clear? Clear? Okay, let us see your next question. Next question now comes out, oh, sorry. Next question is your question number 48. Question 48 is, which of the following is not permissible arrangement of electrons in an atom? Which of the following is not permissible arrangement of electrons in an atom? Here you have 4 options over here. A option is N is equals to 5, L is equals to 3, M is equals to 0, S is equals to plus half. B option is N is equals to 3, L is equals to 2, M is equals to minus 3 and S is equals to minus half. C option is N is equals to 3, L is equals to 2, M is equals to minus 2, S is equals to minus half, while D option is N is equals to 4, L is equals to 0, M is equals to 0, S is equals to minus half. Be fast students, very simple question, very easy peasy question. Now see, if N value is 5, L they are saying as 3. That means for S, for L 0 for S, 1 for P, 2 for D, 3 for F. F, now see, M is 0. Now what M? M basically lies from minus L to plus L. If L basically in this case is 3, that means minus 3 to plus 3. So M can be 0, S can be half. This is right. Now let us see for this case. If N is 3, L is 2. L is 2, that means D. Now M is minus 3. Now see, when L is 2, that means it will lie from minus 2 to plus 2, no? So how the value can be minus 3? This is wrong. So option number B over here is the right answer. Option number B over here is your right answer. Clear everyone? Is it clear to everyone? Shall we move on to the next question? Okay, now comes your question number 49th. Now comes your question number 49th. Question 49 is, consider the following sets of quantum number. What of the following sets of quantum number is not possible? Which of the following is not possible? Yes, exactly, Rams, you are correct. Shivanshu, you are correct. Ritik, you are correct. Very good. Kaveshri, you are correct. Okay. Praveen, you are correct. Okay, now this question, which of the following is not possible? Now see, again I am writing L value. If it is 0, it is S. If it is 1, it is P. If it is 2, it is D. If it is 3, it is F. Now see, N value, if it is 3, now N is 3, L is 0. L is 0, that means it is 3S. See, M value will lie from minus L to plus L. L, if it is 0, that means 0, M is 0. This is right. This is right. First is right. Now let us move on to the next one. Move on to the second one. N is 2. What is L? L is 2. L is 2, that means it is D. Right? M is 1. Now again speaking, if L is, minus L to plus L. L is 2. So minus 2 to plus 2. M can be 1. Okay. Now. Third one. Yes. Yes, do the third one. Do the third one. Is second correct? First of all, tell me. Is second correct? Is second correct? Just think about it. Is second correct or not? Yes, everybody. Yes, everyone. See, in the second, how you can check? L lies from 0 to n minus 1, right? N here is 2. So 2 minus 1, that is 1. 0 and 1. So L cannot be 2 over here. L cannot be 2. That's why you have not seen this. That's why you have not seen exactly. 2D will not be seen. Exactly. Exactly. How you have proved this? Because see, L lies from 0 to n minus 1. N, if it is 2, 2 minus 1 is 1. 0 to 1. 0 to 1, either it can be 0, it can be 1, it cannot be 2. So 2 is not possible. 2 is not possible. This is wrong. This is also wrong. Because first is correct one. Now let us see the next one. Let us see the third one and you will get your answer. See, N value is 4. What is L value? 3. Now 0 to n minus 1. 4 to 1, 3. This is possible. 3 L value will lie when it is F. Now, M value, when L is what? 3, so it is minus 3 to minus 3 to what? Plus 3, so it can be minus 2. Yes, 3 is possible. 3 is possible. So, answer is going to be option number B. Answer is going to be option number B. Yes. Yes. Answer is going to be option number B. Clear, everyone? Clear, everyone? Now, moving on to the last question for this particular, chapter, question number 50th. Last question for this chapter. The orientation of an atomic orbital is governed by A, the principal quantum number, B, azimuthal quantum number, C, spin quantum number, and D, magnetic quantum number. D, magnetic quantum number. Last question for this chapter. The orientation of an atomic orbital is governed by what? The orientation is governed by what? Everybody. Yes. Yes, exactly. Joshni Singh, magnetic, exactly. Orientation is governed by magnetic quantum number. By magnetic quantum number. Clear? By magnetic quantum number. Okay, now your homework question for this chapter. Now your homework question for this chapter is question number 51. This is your homework question for this chapter. Just as I've told you, one question I will be giving you homework from each chapter. This is your homework question. An iron has 18 electrons in the outermost shell. It is. An iron has 18 electrons in the outermost shell. It is. A option, Cu positive, B option TH4 positive, C is CS positive, D is K positive. Kindly take a screenshot of this, students. Kindly take a screenshot of this, students. Now we shall proceed to the next chapter of ours. Now we shall proceed to the next chapter of ours if it is done, everyone. Shall we? Now we shall proceed to states of matter chapters. Shall we proceed to the next now? Next chapter. Now comes the states of matter. Now comes states of matter. Shall we start, everybody? Shall we start with the question number 52, states of matter? Everyone ready? Okay, everyone ready? Okay. This is your question number 52. Question number 52. Question is, dipole-induced dipole interactions are present in which of the following pairs? Dipole-induced dipole interactions are present in which of the following pairs? A option HCl and helium atoms, B option SiF4 and helium atoms, C option H2O and alcohol, D option Cl2 and CCl4. Be fast, very simple question, I guess. This is very simple question. Dipole-induced dipole. Dipole-induced dipole interactions. Basically, let me explain you. One of them will be polar and another one will be non-polar. The polar one will go to the another one and it will induce its dipole, its charge, and it will become dipole-induced dipole. So students, let me tell you, HCl and helium atoms is the right answer. HCl is a polar molecule, helium is a non-polar one. So this is basically an example of dipole-induced dipole. Ambika Ashutosh Sahu has told the correct answer. Rest Lakshmi, Mayank and Afipa has said C. Rams has also said A, right? So option number A will be your correct answer for this particular question. Shall we proceed to the next question? Haan, Mohammad Sharik is saying option A lag raha hai. Exactly. Vishnu is saying A. Great. Let us see the next question. That is your question number 53. Question number 53 is basically, which one of the following is the correct order of interactions? Which one of the following is the correct order of interactions? A option, covalent, then hydrogen bonding, then van der Waals, then dipole-dipole, that is more stronger. Then is covalent is more, then dipole-dipole, then hydrogen bonding, then van der Waals. The next one is covalent is more stronger than hydrogen, then dipole-dipole, then van der Waals. And at last, covalent is more stronger than hydrogen, then van der Waals, then dipole-dipole. So what do you feel, students? Which of the following is going to be the correct answer for this particular question? Which of the following you feel is the correct answer for this particular question, students? Students, see, van der Waals forces are the weak forces, you know that. So they will be the weaker ones. This cannot be right, this cannot be right. Now after that, if I talk about covalent is the one which is more stronger, covalent one is the more stronger. And now talking about hydrogen and dipole, let me tell you, dipole-dipole will be more stronger in comparison to the hydrogen bonding. Dipole-dipole will be more stronger in comparison to hydrogen bonding. So option number B, my dear students, is your correct answer. Is your correct answer. Clear? Great. Let us see your question number 54 now. Let us see your question number 54. Question 54 is, at 25 degrees Celsius and 730 mm pressure, at 25 degrees Celsius and 730 mm pressure, 380 ml of dry oxygen was collected. 380 ml of dry oxygen was collected. If the temperature is constant, what volume will the oxygen occupy at 760 mm pressure? What volume of oxygen will acquire at 760 mm pressure? A option 569 ml, B option 365 ml, C option 265 ml, D option 621 ml. Ma'am, is this structure of atom? No, now only I have told you this is states of matter. This is states of matter that we have started. This is states of matter chapter that we have started. We have already covered some basic concepts of chemistry. We have covered structure of atom. Now this is your third chapter, that is your states of matter. States of matter. Giving you 2 minutes in order to solve this question, students. Very simple question. Now see, they are saying if the temperature is constant. See, when temperature is constant,
Then what is the formula that we apply, ma'am? Very simple. P1 V1 is equal to P2 V2. Simple. What is P1, ma'am? P1 is 730. What is V1? 380. What is P2? P2 we need to calculate. P2 is 760, ma'am. V2 we need to calculate. So what it will be? 730 into 380 by 760 is equivalent to V2. Now 380 2s are basically is 760. Now this, if I am going to divide 365. So I will get volume as 365 ml. Volume will be 365 ml. That means option number B, students, is going to be your right answer. Option number B will be your right answer. Clear, everybody? Clear? Was it a simple question? Yes. Yes. Was it a simple question? No. Shall we proceed to question number 55? Kindly write it or take a screenshot. Kindly write it down or take a screenshot once. Kindly write it or take a screenshot. Now let us see the next one. Question number 55. Question number 55 is, which one is not correct mathematical equation for Dalton's law of partial pressure? Which one is not correct mathematical equation for Dalton's law of partial pressure? Here, pressure is equals to total pressure of gaseous mixture. Here, pressure is equal, P is equals to total pressure. Which of the following they are asking is not correct mathematical equation? A, P is equals to P1 plus P2 plus P3. B, P is equals to N1. C, Pi is equals to XIP, where Pi is partial pressure of IH gas, Xi is the mole fraction of that. And next is Pi is equals to Xi into P naught, where Pi is the mole fraction and P naught is in the pure state. So which of the following is going to be the right answer? Which is not the correct statement? Which is not the correct statement for Dalton's law of partial pressure? In case of Dalton's law of partial pressure. So very simple, yes. Very simple, option number D is the right answer. Shall we proceed to the next one now? Question number, which question it is? 56th. Is in front of you. A 10-liter flask contains 64 grams of oxygen at 27 degrees Celsius. Assume O2 behaving as ideally. The pressure inside the flask in bar is what? R value is given to you. R value is provided to you. So how you are going to solve this question? Very simple. Very simple, ma'am. PV is equals to nRT. Why we are applying this formula? Because they have given that it is behaving ideally. Assume it is behaving ideally. Right? So now see, pressure, if I talk about over here, pressure we have to calculate. Into volume, if I talk about 10 liter, number of moles is given mass upon molecular mass. What is the value of R? Ma'am, it is 0.0831. What is the value of temperature? Where is temperature? Temperature is here, 27 degrees Celsius. Convert into Kelvin. So if you convert into Kelvin, it is 27 plus 273. This comes out to be 300 Kelvin. Yes, ma'am. So now, pressure into volume is equivalent to given mass. What is given mass, students? Given mass is 64 by molecular mass for O2. For oxygen, it is 16. 16 into 2 is going to be what? 32 into 0.0831 into 300. Now 32, 2 is 64, no? Right? And this 0 will get cancelled. What we will get? We will get pressure as 2 into 30 is 60. 60 into 0.0831. That means if I am going to multiply 60 into 831 by 1, 2, 3, 4, 0 will get cancelled. We will get 6. 18, 1 carry, 4, 19 divided by 1000. We will get 4.986. We will get 4.986. That means option number D is going to be your correct answer. Option number D is going to be your correct answer. Option number D is going to be your correct answer, my dear students. Yes, D ko lock kiya jaye. Yes. Option number D is going to be your right answer for this particular question. Let us see the next question of ours. Yes, everybody. Ready? Ready for 57th question? Ready for the 57th one? Okay. Now comes your question number 57. Question 57 is, choose the correct option for the total pressure in a mixture of 4 grams O2 and 2 grams H2 confined in a total volume of 1 liter at 0 degrees Celsius. Now R value is given to you, temperature is provided to you. Think about it, students. Calculate the pressure for O2 and H2 first of all. Calculate the pressure for O2 and H2 and then calculate the total pressure. See, for the case, we know that PV is equivalent to nRT. Let us calculate the pressure for O2. It will be like this. Now the pressure for O2 will be what? What is N? N is number of moles, that is given mass upon molecular mass. Given mass for O2 is 4. Molecular mass is 32. Into the volume of 1 liter. So volume will go over here. R value is 0.082. Into temperature is 273. This is the pressure for the case of O2. Now 4 8 is 32, right? And the pressure of O2 comes out to be what? 0.082 into 273 by 8. Right? Similarly, can we calculate the pressure of H2? The pressure of H2 into volume is equivalent to nRT. Now pressure of H2 will be what? Volume is 1. So number of moles, given mass upon molecular mass, given mass is 2 by molecular mass for water is for H2 is 2 into R is 0.082 into temperature is 273. So the pressure of H2 comes out to be 0.082 into 273. Everybody, till here it is clear or not? Till here it is clear or not? Now we have to calculate total pressure. Total pressure, that means we have to add both of them. Very simple. Ma'am, total pressure is equivalent to the pressure of H2 plus the pressure of O2. Pressure of H2 is basically 0.082 into 273 plus for that is 1 by 8 into 0.082 into 273. This is what the value that you have. Now when you are going to calculate the value, when you are going to calculate, answer will be 25.2. Answer will be 25.2. That means approximately answer is going to be option number D. When you are going to solve it, answer will be option number D. Answer will be option number D. 22.2 something will come. Oh sorry, 25.2 something will come. Clear everyone? Shall we move on to the next question if it is done? Shall we move on to question number 58 if it is done, everybody? If it is done, can we move on to the next question of ours? Yes, everyone. Okay, shall we move on to the next question? Yes, okay. Now comes your question number 58. See your question number 58. A mixture of N2 and argon gases in a cylinder contains 7 grams of N2 and 8 grams of argon. If the total pressure of the mixture of the gases in the cylinder is 27 bar, the partial pressure of N2 is what? Right? You have to tell the partial pressure of N2. Very simple question again. See, they have given a mixture of N2 and argon gases. If the total pressure of the gases in the cylinder is this, the partial pressure. What is the formula for the partial pressure? Partial pressure is equivalent to the mole fraction of N2 into total pressure. Now, what is mole fraction of N2? It is number of moles of N2 divided by total moles for N2 also and for argon also. Now see, for moles of N2 it is given mass by molecular mass, given mass is 7 and molecular mass for N2. For nitrogen it is 14, for 2 it is 28. Right? Now divided by number of moles is 7 by 28 plus for argon given mass is 8 and argon mass is 40. So this is 1 by 4 and this is 1 by 5. So what we'll get over here, we'll get 1 by 4 divided by 20, we'll take it as LCM, 5 plus 4. Right? What we will do, 1 by 4 into 9 and this 20 will go over here. This comes out to be 5 by 9. How much? 5 by 9. That means what will be the partial pressure? It will be 5 by 9 into what is total pressure? Total pressure is 27. So 3 9s are 27. So this comes out to be 15. This comes out to be 15 bar. That means option number C, students, is going to be your correct option. Option number C is going to be your correct option. Clear everybody? Clear everyone? Clear everyone? Okay, shall we move on to the next question of ours now? Shall we move on to the next question of our students? Okay, now comes your question number 59. Now comes your question number 59. What is the density of N2 gas at 227 degrees Celsius and 5 atm pressure? What is the density of N2 gas at 227 degrees Celsius and 5 atm pressure? R value is given to you over here. Right everybody. Now see students, density of N2 gas. See, we know that PV is equals to nRT. We also know that N basically is given mass upon molecular mass into R into T. Can I take this over here? Pressure into molecular mass is equivalent to given mass upon volume RT. Can I write given mass by volume as my density? What I will get? Pressure into molecular mass is equivalent to density into R into T. Now what is pressure over here? Pressure over here, ma'am, is given as 5 atm. Molecular mass for N2 will be 28. Density you have to calculate. R is 0.082 and T, temperature, 227 degrees Celsius. Convert in Kelvin. 227 plus 273. This comes out to be 500 Kelvin. This comes out to be how much? 500. So what will be density? 5 into 28 divided by 0.08. 2 into 500. This will go as 100. Now you will calculate your density. Students. Density may come out to be near about 3.41. Option number C. Density will be about option number C, 3.41. Clear everybody? Clear? Option number C will be correct. Not D को lock नहीं किया जाए. Option number C will be your correct one. Clear everyone? Shall we move on to the next question of ours? Now comes your question number 60. Question is, two gases A and B having the same volume diffuse through a porous partition in 20 and 10 seconds respectively. The molecular mass of A is 49 mu. The molecular mass of B will be what? They have given you two gases A and B. They have same volume through which they diffuse, but in different time. The molecular masses they have given you for one, and for the another it is asking you. Option A is 15 mu, option B is 12.25 mu, option C is 6.50 mu, and option D is 25 mu. Yes? Yes, be fast. Now let me tell you, if I talk about rate for diffusion of A by rate of diffusion of B, it will be equivalent to the volume diffused by time taken for A and volume diffused by time taken for B, and it is equivalent to, now this is really very important, it is equivalent to the root of the molecular masses. Now the root will be of the molecular masses of B by A. Remember this thing, don't get confused in this. If you are writing, the rate will be equivalent to the root of mass of B by mass of A. Now see, they are saying the same volume, so volume will get cancelled. What you will get? TB by TA is equivalent to root of MB by MA, because it is in divide, no, so it will go out like this. So what is time for A? Time for A is 20, and time for B is 10. It is equivalent to molecular mass of A is 49 and B we have to calculate. So this is 1 by 2, this will go and it will become square. 1 by 2 whole square, it is equivalent to MB by 49, right? So what we will get? 1 by 4 into 49 equivalent to the molecular mass for this. So it is 12.5, 12.25 I guess. One second. Yeah, 12.25. It comes out to be 12.25. Hence, option number B is going to be your correct answer. Option number B is going to be your correct answer. One is saying, ma'am, in question number 59, we use molecular mass 14 or 28. 28. See, over here it is written N2, no? So 2 into 14, that is 28. Clear? Clear, students? Yes, everybody? Now students, we shall take, okay, a 10 minutes break. After this 10 minutes break, we are going to rejoin again, and then we are going to proceed with the next questions. And then after that, we are going to take a break for the lunch time. So basically, I am going only a few minutes break, 10 minutes break, not more than that, because after that, we will study and then we'll take a break for, you know, a 15 to 20 minutes for the lunch one. So I am taking this as a short break for 10 minutes. Clear everyone? So till now, we have done 60 questions and then we will move further, right? So this is going to be your 10 minutes break. Is it sufficient for each and every one of you? 10 minutes is sufficient? I want you all to have something, eat something, okay? Have fruits, take some water, okay? Go and freshen up, right? Okay, great. So now it's a 10-minute break, and after that we are going to start with this question only. Okay, that's great. That's great. Okay. This is a question number 61 that we are going to start, right? Clear? Shall we? Okay, 10 minutes break I'm taking. Okay, it's 42. Okay, then I'll continue with 55. It's a 13 minutes break. Okay, it's already 42. We'll continue with 55. So, your timer starts now. We shall meet after 13 minutes. So yes students, I guess everybody has taken this 10 minutes break, right? So shall we start again? Shall we proceed again with the question of ours? Now your break is over. Yes? Your break is over. Is my voice audible? So yes students, please let me know if my voice is audible so that we can start with our session. We can continue our session further. Yes, kindly join everybody. Kindly join everyone. We are going to do question number 61 now. Don't worry, I'll give you a break for your lunch time also. So like if you're sitting at home, you can tell your parents that you are going to have lunch near about 3 to 3:30, okay? So I'll give you a break at that spot of time. You can have your lunch at that spot of time. Great. Yes ma'am, audible? Okay. So I'm reading the question 61 in front of you. You have to answer it accordingly. The question says that a bubble of air is underwater at temperature 15 degrees Celsius and the pressure 1.5 bar. If the bubble rises to the surface where the temperature is 25 degrees Celsius and the pressure is 1 bar, what will happen to the volume of bubble? Okay? What will happen to the volume of bubble? Now, option A is volume will become greater by a factor of 1.6. Option B is volume will become greater by a factor of 1.1. Option C is volume will become smaller by a factor of 0.70. While option D is volume will become greater by a factor of 2.5. See, I'll give you a hint regarding these questions. Anuj Rai saying, ma'am, mock में marks नहीं आ रहे हैं. No need to worry, you need to learn from your mistakes. Check and analyze your mock test and see which chapter you are lacking. For example, you are lacking from a chapter like structure of atoms, so that means you need to work more on that chapter, give that chapter more time. So analyze rather than being sad, okay? This is what I will suggest to you. Now, I have read question for you people. I was telling you a hint in order to solve this question. The hint is that students, for this question, you can apply your PV is equals to nRT. Find a relationship of volume, temperature and pressure. Volume will be directly proportional to what or directly inversely proportional to what. And compare both of them and you'll get your answer over here. Compare both of them and you'll get your answer over here. Okay, the ones that have joined just right now, I have just read the question for you people. I am giving you 2 minutes in order to read the question and then try by your own. Okay? Okay? Shall we do this? Okay, now see students, over here as I've told you that we are going to apply PV is equivalent to nRT. Now we know that N and R for this case is going to be constant. That means volume, if I talk about, will be directly proportional to temperature and inversely proportional to pressure. Yes, everybody? Yes. Now see, many of the students have started answering also. For example, KV Shri has answered option number A. Very good. Okay, till then we can check over here. See, as I told you, volume is directly proportional to temperature and inversely proportional to pressure. As per the given question, if we see over here, the initial temperature is 15 degrees Celsius. First of all, convert it into Kelvin. That means 15 plus 273. This comes out to be how much? 288 Kelvin. Right? How much? 288 Kelvin. Pressure is 1.5 bar. If the bubble rises to the surface where the temperature is 25 degrees Celsius. Again, 25 plus 273 we are going to do. That means it is going to be 298 Kelvin. Then the pressure is 1 bar. So if I talk about the very first one, volume, V1 if I say, it is directly proportional to temperature is 288 by pressure is your 1.5 bar. If I talk about V2, it is directly proportional to temperature is 298 and the pressure is 1 bar. So if we are going to compare both of them, we are going to compare V1 and V2, we have to see what will happen to the volume of bubble. Okay, so we will do V1 by V2. What we will get over here? We will get 288 by 1.5 into 298 into 1. This is what we'll get, everybody. This is what we'll get over here. If I'll do V1 by V2, so this comes out to be near about 1.6, 1 by 1.6 when you're going to divide it, cross multiply it, V2 comes out to be 1.6 times of V1. That means volume will become greater by a factor of 1.6. Volume will become greater by a factor of 1.6. So option number A is going to be your right answer. Right? Right. Clear, everybody? Kindly take a screenshot of this question. Now I am going to proceed with question number 62 over here. If this is done, shall we proceed to question number 62, everybody? Okay, now comes your next question. Question 62 is the pressure exerted by 6 gram of methane gas. The pressure exerted by 6 gram of methane gas in 0.03 meter cube vessel at 129 degrees Celsius is what? Atomic masses are being provided to you over here, right? Right? So basically options are given to you in Pascal. Now see over here, students, one by one. They have given us the given mass. Given mass is 6 grams. And they're talking about methane gas. What is molecular mass for methane? Ma'am, it is CH4. 1 into carbon mass plus 4 into hydrogen mass. Carbon mass is 12, so 1 into 12 plus hydrogen mass is 1, so 4 into 1. It comes out to be 16 grams. Great. Now, see, there we are talking about volume. Volume is how much, ma'am? 0.03 meter cube. Am I right? Now, temperature they have given you in Celsius. What is temperature? Temperature is 129 degrees Celsius. In order to convert into Kelvin, we will add 273. So, 129 plus 273. This comes out to be 402. This comes out to be how much, ma'am? 402 Kelvin. Now, see, we know that, students, basically PV is equivalent to nRT. What is pressure? We need to calculate. What is volume? Volume is 0.03. What is number of moles? Given mass upon molecular mass. What is the value of R? R is 8.314. What is temperature? 402. What is temperature? 402. Clear, everyone? Simple question. So when you are going to solve it, students, your answer will come out to be about, 41648 Pascal. When you are going to solve it, your answer will come out, yes, exactly, option number C. Answer will come out to be option number C. Exactly. Kavishri, very good. Kavishri and Priyangu Singh, they both are doing very good. Very good, very good, very good. Shall we proceed to the question number 63 if it is done? Shall we proceed to question number 63, students, if it is done? Shall we move on to the question number 63 if it is done, everybody? Okay, question number 63 is in front of you. Question number 63 is in front of you. Select one correct statement in the gas equation PV is equals to nRT. Select one correct statement in the gas equation PV is equals to nRT. A. N is the number of molecules of gas. B. V denotes volume of 1 mole of gas. C. N moles of gas have volume V. D. P is the pressure of the gas when only 1 mole of gas is present. Now tell me fast, students, which of the following is going to be the correct answer for this particular question? First of all, N is not the number of molecules, it is number of moles. Secondly, V denotes volume of 1 mole of gas. No, V denotes the volume of complete gas. N moles of the gas have volume V. Yes, this is the right statement. Option number C is the right statement. Clear, everyone? Clear, everyone? Yes. Kaveshri, Vishnu, Sargi, Sneha, Lakshmi, Priyangu, Vishnu. Very good. Option number C, Mithil Sai. Very good. It is the right answer. Let us see your next question. Question number 64. Question number 64. At constant temperature in a given mass of an ideal gas, a constant temperature in a given mass of an ideal gas, A option, the ratio of pressure and volume will always remain constant. B, volume always remain constant. C, pressure always remain constant. D, the product of pressure and volume always remain constant. When there is a constant temperature, they are asking at constant temperature, which law is obeyed? Ma'am, Boyle's law. Which law is obeyed, ma'am? Boyle's law. Now, when we are talking at constant temperature, ma'am, we always say P1 V1 is equivalent to P2 V2. How this came? Because PV was equivalent to constant. PV was constant. So, the ratio of pressure and volume always remain constant? No. This is incorrect. Volume always remain constant? No. Pressure always remain constant? No. The product of pressure and volume always remain constant? Right. Right. So option number D, my dear students, is going to be your correct option for this particular question. Option number D will be your correct option for this particular question. Clear, everybody? Clear, everyone? Clear? Shall we see the next question if it is done? This is a question number 64. Now moving on to question number 65. Let us do now question number 65. It is done. Done, everybody? Now comes your next question. Question number 65. Question 65 is basically, if P, V, M, T and R are pressure, volume, molar mass, temperature and gas constant respectively, then for an ideal gas the density is given by, A, RT by PM, B, P by RT, C, M by V and D is PM by RT. Simple question. Now see, density. See, we know that, ma'am, PV is equivalent to nRT, right? So we can say that P into V is equal to what is N? N is given mass upon molecular mass into R into T. Now we can cross multiply P into molecular mass is equals to given mass by volume into R into T. What is given mass by volume? It is density. So what we can say is pressure into molecular mass is equivalent to density into R into T. So what will be density, ma'am? Density will be pressure into molecular mass divided by RT. Pressure into molecular mass divided by RT. So option number D, students, is going to be your correct answer for this particular question. Option number D. Priyangu, Lakshmi, Nirbhan, Sneha, Mithil Sai, Akshay, Acting Girl, everybody. D. Very good. D is going to be your correct answer for this particular question. Clear, everyone? Shall we move on to the next question? Okay, now comes your next question. Question number 66. What is question number 66? Correct gas equation is. A is, options are given to you, very simple. Options are given to you, giving you 1 minute in order to solve it out. Be fast, students. Correct gas equation is. So it is very simple, ma'am. P1 V1 by T1 is equal to P2 V2 by T2. Yes, everybody. Now see, P1 V1 by T1. Here is no P1 V1 T1. But they have written in terms of cross multiply. Let us cross multiply. P1 V1 by P2 V2. T1 will go over there. It will be equivalent to T1 by T2. Let us check this if it is there. Yes, it is option number B. Answer is going to be option number B. Yes, Vishnu, Priyangu, Mithil Sai, Sneha, Sargi. Yes, everybody. Exactly. Answer is going to be option number B. Clear? Shall we move on to question number 67 if it is done? Students? Shall we move on to the next question of ours? Okay, now comes the next question. Question is your 67th. Question 67 is, at STP, 0.50 mole H2 gas and 1 mole helium gas A have equal average kinetic energy B, have equal molecular speed C, occupy equal volume D, have equal effusion rate. Kindly let me know its answer. Giving you 1 minute, students. Kindly let me know its answer. Yes, students, at STP. Yes, students. Let me tell you, they will have equal average kinetic energy. Why? See, they will have equal kinetic energy because kinetic energy won't depend upon temperature. Kinetic energy is 3/2. Basically, if I talk about here, they have given us moles. Here they have given us moles. So, sorry, I have spoken it will not depend on temperature. Kinetic energy will only depend on temperature. See, let us understand in general terms. If you increase temperature, the kinetic energy of molecule will increase. If you see from the with the help of an mathematical formula, kinetic energy is 3 by 2 kT. Now that T basically is temperature dependent term for kinetic energy. So kinetic energy is not dependent upon the moles over here. So that means if I am talking about any of these gases, at STP they will have equal average kinetic energies, because they will depend upon, you know, only and only temperature. And at STP the temperature are going to be same for both of the cases. Right? Right? So A option is going to be the right answer. A option is going to be the right answer. A option is going to be the right answer. Clear? Shall we proceed to the next question, students? Next question is question number 68. Question says that a closed flask contains water in all its three states, solid, liquid and vapor, at 0 degrees Celsius. In this situation, the average kinetic energy of water molecule will be greatest in all these three states, greatest in vapor, greatest in liquid, or greatest in solid. In which of the following will have the same value? Very simple question, very simple question. Yes, Lakshmi, you have exactly told right that volume will remain, you know, in that case at STP. If I talk about how they will occupy equal volume. My question is, see, if you are going to apply kinetic energy is equals to half mv square, or if you are going with different moles, then the mole concept will start. If they have different moles, that means they will have different volume, because number of moles will be different. Number of moles is given volume by 22.4, right? So they have same kinetic energy, because kinetic energy only and only will depend on temperature. It won't depend upon mole and all of that stuff. So coming back to this question, B, yes, exactly. They will have, you know, highest, I would say the maximum average kinetic energy seen in the vapor phase or the gaseous phase. Why? Because the molecules are at a far distance from each other. That's why. The molecules are present at the far distance from each other, so they can easily move. They have a maximum velocity in that case. So option number B, students, is going to be your correct answer for this particular question. Let us see the question number 69 if it is done, everybody. Question number 69. Question 69 is, a gas such as carbon monoxide will most be likely to obey ideal gas law at A option, low temperature and high pressure, B option, high temperature and high pressure, C option, low temperature and low pressure, D option, high temperature and low pressure. So they have told you, for example, you have a gas carbon monoxide, how, at what, you know, situation it will behave as an ideal gas. What are the conditions basically? Very simple. If real gases want to behave like an ideal gases, it will have high temperature and low pressure. Very simple question. Very simple question, but most asked one. Mostly they ask you this question. At what temperature and pressure a gas will behave as an ideal gas? Got my point, everybody? Now comes your question number 70th. Now comes your question number 70th. Reading the question for you. For real gases, van der Waal equation is written as P plus An square by V square, V minus Nb is equals to nRT, where A and B are van der Waal constant. Okay. Two sets of gases are O2, CO2, H2 and helium, CH4, O2 and H2. The gases given in set 1 are in increasing order of B, and D gases given in the set 2 in decreasing order of A are arranged below. Select the order from the following. Be fast, students, giving you 2 minutes in order to think about it. Let me tell you, over here B represents intermolecular forces, and over here A represents size. So upon them, on the basis of that, you are going to define it. On the basis of that, you are going to define it. So if I see with the size of CH4, O2 and H2, CH4 will have highest size, then O2, then H2. So this is also wrong. This is also wrong. This is also wrong. So directly we have got our answer. If you have to see the interactions, then CO2 will have more interaction than O2, then H3, then H2. So option number C is the right answer. Option number C is the right answer. Answer is going to be option number C. Clear, everyone? Now comes your question number 71. Question 71 is, van der Waals real gas act as an ideal gas at which condition? A. High temperature, low pressure. B. Low temperature, high pressure. C. High temperature, high pressure. D. Low temperature, low pressure. Now only we have done this question. Just now we have done this question, ma'am. At low pressure, high temperature. That means option number A. That means option number A is your right answer. Now comes your question number 72. Now comes your question number 72. If van der Waals gas equation of state for a non-ideal gas, the term that accounts for intermolecular forces, now only we have done, where there is B, that is intermolecular forces. That means A is the right answer. V minus NB is the right answer. When we take N as 1, V minus NB. Exactly, A is the right answer. Vishnu, Yaku, Sergi, okay. Problem of life name as an account A, okay. Rames A, Vishnu A, exactly. A is the right answer. Let us see question number 73rd. Question 73rd. Now this is your homework for this chapter. Question number 73rd is your homework for this chapter. Given van der Waals constant for NH3, H2O2 and CO2 are respectively given to you. This is your homework for this chapter. 4.17, 0.244, 1.36 and 3.59. Which one of the following gases is mostly easily liquefied? Question number 73 is your homework. Kindly take its screenshot, my dear students. Kindly take its screenshot, everybody. Take its screenshot. Done everyone, done everyone. So now we end our this chapter over here only. Right, now we are going to start with question number 74 and the chapter thermodynamics. Question 74, chapter thermodynamics. Right. Shall we start? Shall we start with thermodynamics? Question 74, 73, taken screenshot. Chemistry means A means intermolecular forces. See, basically when I'm talking about A and B over here, you have seen, I've just written over here. What is confusion over here? I'm not getting your point. What is the confusion between A and B? What's the confusion over here? A will represent intermolecular forces of attraction, sorry, and B will represent size. Yes, A will represent, I have written opposite, A will represent intermolecular forces and B will represent size. 1 second. Okay, now in set 1 they are saying with regard to B, that is according to the size, and set 1 with regard to A, that is your intermolecular forces. Okay, so if I talk about H2 and O2, H2 is hydrogen is being bonded to itself. Yeah, B means size. No, the next question is right, because the next question they asked you, sorry, where is that question gone? Yeah, so in this question also, sorry, kindly make it correct. Sorry, kindly make it correct. Here also they are talking about intermolecular forces. That means they are talking about A. That means we are going to see the option number C as the correct answer. Kindly correct this one also. Kindly correct this one also. Okay, by mistakenly I have written that. Right? Now, according to this, what is going to be your answer? Everybody in the comment section. According to this, what is going to be your answer in the comment section? Be fast. Now that makes me feel so proud that you students, you know, are observing it very carefully and you are rectifying that what we did by mistakenly. So very good, very good. You are paying so much attention. That's great. It's okay. Okay. Clear? So yes, Ashok Katwani is saying A, problem of life is saying A. For which question? For this one, no. I am talking about this question now. We'll move on to the next question. First, complete this question. For this question, what do you feel is going to be the right answer? Then we are going to start with thermodynamics. Everybody, then we are going to start with thermodynamic. Yaku is saying C. Joshni is saying A. Joshni, just think again. Just think again. Just think again. If you are comparing, you know, the intermolecular forces, if you are seeing the size also or the intermolecular forces also, just observe very carefully. In the cases of size of all of these, it's very simple, very easy. You can easily tell which of the following size will be more. Obviously, CO2 will have more size. Then you will have the size of O2. Okay, right? Right? Yes, Shivanshu, you are exactly right. Shivanshu, you are exactly right. Option is going to be option number C. Ma'am, it's hard to go even understand this question. See, it is very simple question they have given you. They have given you two sets. They are saying in set 1, you have to see B. That means you have to see size order. In this, you have to see A. That means here you have to see intermolecular forces order. So here you have to write the size order. Here you have to write the intermolecular force order. That's it. That's it. Clear? Okay. Now, I guess this question everybody has clarified. Everybody has written this, right? Now, coming to chapter thermodynamics, this is your question number first. Coming to chapter thermodynamics, this is your question number first. That means question number 74 with respect to our session. What of the following are not the state functions? Which of the following would have come over here? Okay. Which of the followings are not state functions? First Q plus W, second Q, third W, fourth H minus TS. Options are first, second and third. Option B is second and third. Option C is first and fourth. Option D is second, third and fourth. Option C is second, third and fourth. Be fast, students. Now see students, if I talk about heat, it is a path function. If I talk about work done, it is a path function. And Q plus W is equivalent to delta E or delta U, you can say. It is a state function. And H minus TS is delta G, which is also a state function. So they are asking which are not state functions. That means second and third are not a state functions. So option number B, students, is going to be your correct answer for this particular question. Yes, Kesha is saying Q plus W is internal energy delta E and fourth one is Gibbs free energy. So option number B, yes, option number B. Joshni Lakshmi Shivansh is saying C. Joshmi Lakshmi B. Yeah. Clear? Option number B is the right answer. Let us see question number 75. Okay, this is the direct question. This is the direct question. You can write its answer. Question 75 is a homework. Direct question. Very easy question. Which of the following is the correct equation? Very, very easy question for you people. Correct equation you have to tell based on the law of thermodynamics. Everybody will do this. Shall I move on to the next question? Question number 76. Shall I move on to the next question? Shall we move on to the next question, everybody? So students, I guess this is done. Done in the homework section. Simple question. Okay. Let us move on with question number 76. Question 76 is, which one among the following is the correct option for the right relationship between Cp and Cv for 1 mole of an ideal gas? For 1 mole of an ideal gas. A is Cv is equals to RCp, B is Cp plus Cv is equals to R, C is Cp minus Cv is equals to R, while D is Cp is equals to RCv. Very easy question. Again, this is a formula based question. Yes, Cp minus Cv is equals to R. That's great. This is option number C. This is option number C. Shall we move on to question number 77, students, if it is done? Question number 77 is in front of you. Let us read question 77. An ideal gas expands isothermally from 10 raised to the power minus 3 meter cube to 10 raised to the power minus 2 meter cube at 300 Kelvin against a constant pressure of 10 raised to the power 5 Newton per meter square. The work done on the gas is A option plus 270 kilojoule, B option minus 900 joule, C option plus 900 kilojoule, D option minus 900 kilojoule. Okay, one of the students saying I have already missed so many questions. Where I'll get the PDF? Whensoever it will get uploaded, when the session will get over, you'll get the PDF. No need to worry, we have just covered 3 chapters. This is the 4th chapter that we have started, so you can continue from here and afterwards you can see the previous one, right? Right. Tell me fast, students, what you are going to do in this particular question. Simple, work done is equals to minus P delta V, that is V2 minus V1, right? Now what is minus P? What is constant pressure? Pressure is 10 raised to the power 5. Now we have V2. What is V2 over here? Volume 2 extends from this to this. That means 10 raised to the power minus 2 minus 10 raised to the power minus 3. W is equals to minus PV, P delta V. Directly you have to do. So work done, you'll calculate. Calculate its answer fast, students. Very simple question. See over here. Now what I can do is 10 raised to the power 5. Now I can take 10 raised to the power minus 3 as common. What I will get? 10 minus 1. What it will be? Minus 10 raised to the power 5 into 10 raised to the power minus 3 into 9. So this is basically going to be minus 9 into 10 raised to the power 2. That is minus 900. This comes out to be minus 900. Minus 900. It is Newton meter, that means 1 joule. That means 1 joule. It is Newton meter, that means 1 joule. So the answer is minus 900 joule. Minus why Kevishri positive? Minus will come, no? Negative sign will come, no? So option number B is your right answer. Option number B is your right answer. Clear? Clear with question number 77. Shall we move on to question number 78? Shall we move on to question number 78, everybody? Kevishri, it is clear to you? Negative sign will come, not the positive one. Negative will come, not the positive one. Clear? No. Okay, shall we do the next one? Question number 78. Question 78 is, a gas is allowed to expand in a well insulated container against a constant external pressure of 2.5 atm from an initial volume of 2.50 liters to a final volume of 4.50 liter. The change in internal energy delta U of the gas in joules will be what? Now, very simple question yet again. Very simple question yet again. They are asking you the change in internal energy of gas in joules. Okay, students. Okay, do it fast. First of all, calculate the work done. What is work done? Work done is again minus P delta V. What is P over here? Ma'am, pressure over here is 2.5. What is delta V? Final is 4.50 minus initial is 2.50. So this is minus 2.5 into 2. That means minus 5. Now this is work done. This is your work done. Right, everyone? This is your work done. Right, everyone? Now, but the pressure was in ATM. Students, the pressure was in ATM. Now the answer is in liter ATM because the volume was liters and ATM was the pressure. So you need to convert it to joules. In order to convert into joules, you will multiply it with 101.3. In order to convert into liter ATM into joules, you will multiply it 101.3. You will get what? Minus 506.5 joules. Minus 506.5 joules. Yes, everyone. Now, what is the relationship between internal energy and work done? What is the relationship between internal energy and work done, ma'am? Delta U is equals to Q plus W. Now, over here, the gas is allowed to expand. That means Q over here is 0. What is W? Minus 506.5. So the answer is minus 506.5. That means minus 505 joules. Option number B, students, will be your correct answer. Take a screenshot of this question. Yes, everybody. Spy Thunder, Vishnu, Keshavri, Keshav, Sunidhi, everybody is right. Shall we move on to question number 79 if it is done? Shall we move on to question number 79 if it is done? Question 79 is when 1 mole of a gas is heated at constant volume, temperature is raised from 298 to 308. Heat supplied of the gas is 500. Which statement is correct? Which statement is correct? Think about it, students. Think about it, students. Yet Rams, yes, Rams, Q is equal to 0 for that case, for the previous one. Delta H is equals to delta E plus P delta V. Delta H, heat supplied to the system, is 500 joules. Okay. And when 1 mole of a gas is heated at a constant volume, temperature is raised from this much. Then which statement is correct? Just see. Here volume is constant. If volume is constant, delta V is constant. Delta V is constant. This complete will be constant. That means delta E comes out to be 500. Delta E comes out to be 500. Delta E is not 0. Delta E is not 0. Delta E is not 0. Delta E is 500. Delta E comes out to be 500. Option number B is the right answer. Direct answer. Option number B is your correct answer. Clear, everyone? Very good, Joshni, Spy Thunder, Ashok, Shivansh. Now let us see question number 80th. Question number 80th. For the reaction C2H5OH plus 3O2 gives 2CO2 plus 3H2O. For this particular reaction, which one is true? You have to tell which one is true for the reaction. Which of the following is going to be the true statement for this reaction? Delta H is equals to delta E plus delta NgRT. What is Ng over here? Delta Ng is number of moles of product minus number of moles of reactant. Why we are using a G sign over here for gaseous? Right, everyone? So now let us do this question. See, what is delta Ng? For product is 2 gaseous. Now see, this is in liquid, so we won't take it. 2 minus 3. This is in liquid, we won't take it. So delta Ng will be product is 2 minus 3, that is minus 1. So what we will write? Delta H is equals to delta E minus RT. Right? Minus RT. Ma'am, that means option number A is going to be our correct answer. Option number A is going to be our correct answer. Shivanshu has said right. Jayashri, you have done wrong. Kesha has done right. God with the ID has written right. Lakshmi, you have written wrong. A is going to be your right answer. A will come out to be your right answer. Clear, everybody? Question 81. In an endothermic reaction, the value of delta H is A negative, B positive, C 0 या D constant. What do you feel, students? See, basically energy of reactant is going to be less than that of product. So delta H value will be a positive one. Simple question. Simple question. Yes, Keshav, B. Clear? Okay, let us see question number 82. Question 82 is, during isothermal expansion of an ideal gas, its internal energy increases, enthalpy decreases, enthalpy remain unaffected, enthalpy reduces to 0. What do you feel? Which of the following is going to be the correct answer? What do you feel which is going to be the correct answer? During isothermal, isothermal is when temperature is constant. See, delta T is 0. What will happen? If delta T is 0, delta E will also be 0. That means internal energy is 0. Enthalpy will also be 0. Delta H will also be 0. If delta H will also be 0, that means enthalpy will remain unaffected. Sorry. Once again, what I've told you, if delta T is 0, if it is an isothermal, that means constant temperature. If constant temperature, that what we can say is if it is 0, delta E becomes 0 because it is dependent upon the temperature. If it is 0, then it becomes 0. Now, and I'm saying if delta E is 0, delta H will become 0. Now, delta H will not become 0, it will remain affected. There will be no change in delta H. It will remain unaffected. Enthalpy will remain same. Enthalpy will remain same. So, D will not be the correct one. They're saying it reduces to 0. No, it will remain unaffected. It will remain as it is. Delta H is basically the change in enthalpy, not enthalpy. Enthalpy is H, but delta H is basically change in enthalpy. So, change in enthalpy will remain same. Remain unaffected. Option number C is going to be your right answer. Let us see the next question. Let us move on to the next question. Clear, everyone? Okay, now comes your next question. Question number 83. Question 83 is for the reaction N2 plus 3H2 gives 2NH3. Delta H is what? Now only we have done this formula that delta H is equals to delta E plus delta NgRT. What is delta Ng over here? Now this is also gaseous, this is also gaseous, this is also gaseous. So this is delta Ng is 2 minus 3 plus 1, that is 4. So that comes out to be minus 2. That means delta H is equivalent to delta E minus 2 RT. Delta E minus 2 RT. Option number B is going to be your right answer. Option number B is going to be your right answer. Sunidhi saying, please question 44 समझा दो, फिर से समझ नहीं आया. Okay, after the video I am going to tell you because it is in between. We are at question number 83. So after the video I will take your doubt again and I will answer it. Clear? Shall we move on to the next question, everyone? Okay, now comes the next question, 84th. Question 84 is, if delta H is the change in enthalpy and delta E is the change in internal energy accompanying a gaseous reaction, then A option, delta E is always greater than delta E is always greater than delta E. Sorry, let me check. Is there a printing mistake? Please give me a minute. Let me open the PDF for you people. Students, here delta H will come. Here delta H will come. Kindly correct the question. Here delta H will come. Now see, if delta H is change in enthalpy and delta E is change in internal energy accompanying a gaseous reaction, then delta H is always greater than delta E. First option. B is delta H is less than delta E only if the number of moles of the product is greater than the number of moles of reactant. C, delta H is always less than delta E, while D, delta H is less than delta E only if the number of moles of product is less than the number of moles of the reactant. Now see students, we basically know that delta H is equivalent to delta E plus delta NgRT, right? See, if number of moles of product is more than number of moles of reactant, we know that delta Ng is number of moles of product minus number of moles of reactant. That means delta Ng will be a positive value. If number of moles of product is more than this, then if it is a positive value, that means delta H will be more than delta E in this case, right? And if we say number of moles of reactant are more than number of moles of product, that means delta Ng is negative value. That means delta E is more than delta H for this case. Now see, when delta E is more than delta H, when number of moles of reactant is more than number of moles of product. Number of moles of product is greater? No. Number of moles of reactant is less than that of reactant, right? So option number D is going to be the right one. Option number D is going to be the right one for this particular question. Done, everybody? Clear, everyone? Shall we move on to the next question if it is done? Shall we move on to the next question, everybody? Now comes your question number 85. Question 85 is, three thermochemical equations are given below. You have been provided with three thermochemical equations. Based on the above equation, find out the relationship given below is correct or not. Okay? Okay. Now, three thermochemical equations they have already provided you. It is based on Hess law. It is based on which law, ma'am? It is based on Hess law, right? So let us write the equation. See, based on the above equation, find out the relationship. Now see, for if I see the first and the second equation, I require CO in the reactant side, okay, and rest it is same. So what I can do is I can subtract first and second, and can I get third? In order to get third, what can I do is I can subtract, you know, second from first. So let us subtract first of all. First equation is carbon graphite plus O2 minus carbon graphite plus half O2. Now this also we are subtracting. So minus half O2 gives CO2 minus CO. So basically this will get cancelled. We'll get half O2 and CO will come over here. We'll get CO2. Is this the third equation? Yes, ma'am. It is the third equation. That means you have to subtract second from the first. You'll get the third one. So third equation is Z. Z is equivalent to what is first one? First one is Y. First one is X minus second one is Y. So this is your answer. Z is equals to X minus Y. So what I can say is, what will be X? X will be Y plus Z. That means option number B is going to be my correct answer. Option number B is going to be my correct answer for this particular question. Clear, everybody? Yes, Kiveshri, Depatha, Shivanshu. Yes, clear, everyone? Clear, everyone? Shall we move on to the next question of ours if it is done? Shall we move on to the next question of ours? Now let us do one more question on Hess law, 86th question. The standard enthalpy of vaporization for water at 100 degrees Celsius is 40.66 kilojoule per mole. The internal energy of vaporization of water is what? They are asking you delta U, they have given you delta H. They are asking you delta U, they have given, ma'am, please explain again. Okay, I'll explain again. Till then, the ones that are those who have not done can write it down. Those who have done can write this question, solve this question, then I'm going to explain it all over again. First of all, let us solve this. See, delta H is equals to delta E plus delta NGRT. This is what is our reaction. Vishnu, explain again, ma'am, please. Okay, after this question, we are going to explain it. This is the formula that you used to do with regard to enthalpy and delta E. Delta is internal energy change, students. Delta E is basically your internal energy change. Now, if I talk about in this particular question, see, water from the liquid form is converted into water into the gaseous one, right? So basically delta Ng will be number of moles of product minus number of moles of reactant. What is the product? 1, reactant is 0. So delta Ng is 1. What you will get? Delta H is equals to delta E, right, plus RT. This is what you will get over here. Now see, what is delta H for water? It is 40.66 kilojoule. It is equivalent to delta E. Plus now you have been given the value of R and T. The temperature over here is 100 degrees Celsius. Convert it into Kelvin. So it is 100 plus 273, that is 373. So you will take at 0.08 into 373, everybody, into 373. So when you are going to cross multiply, students, one more thing. Here we are talking in joule, in kilojoule. So you have to take R value as 8.314. Into it will be 373. Into it will be 373. So when you are going to cross multiply, your answer will come out to be 37.56 kilojoule per mole. Clear? Now I am going to explain the previous question. Till then, please take a screenshot of this one. Now I am going to take a, talk about the previous question. Till then, please take a screenshot of this one. Done, everybody? Okay. Now question number, the previous question is this one. See what we did, we have to prepare this reaction. How I prepare this reaction, I've seen the options. Option was in terms of Z. So here delta H for Z is, delta H is Z for this one. So what I did is, I have to obtain this reaction. How can I obtain this reaction? I don't want carbon, but I want CO on the reactant side as per the third equation and CO2 in the product. That means first equation I will take as it is, but I want CO in the reactant side. So I will subtract so that it can move on the another side. Right? It can move on to the another side. Right? So what I did is, I subtracted second from the first, I got the third one. Got it? Easy one. Easy. Okay, now comes your question number 87th. See question 87. Consider the following process. You have been given the following process. The delta H will be for this particular reaction. Now see, you want B in the reactant side. Okay. You want D in the reactant side. That, okay. And you want E in the product side. So reverse this reaction. Reverse this reaction. What you'll get? 2D gives E plus A. What will be the value for this? It will be minus 350. Why? Because I want E in the product side. That's why. Moreover, you want 2C in the reaction side, which is already given. That means you will take the second equation. You will take this new equation as your third equation. And see, basically you require this B in the reactant side. So reverse this equation. So just reverse this equation and multiply it by 2. When you will reverse and multiply this equation by 2, it will become 2B gives A. 2B gives A. Okay, you have reversed this equation. When you reverse it, becomes 1 minus 150 and you multiply it by 2, so it becomes minus 300. Got it? The delta H value becomes this. Now you have to obtain this reaction. B plus C. Now you have to just add the reaction. See, what you have to do is, basically you will require second equation and then you will require add third equation in it, and then you will add your first equation. So see, second equation is basically 3B plus third equation is 2D plus first equation is 2B. No, you will subtract first equation because you have to get rid of the this B, right? Now we'll give what? Second equation is 2C plus D. Third equation is basically your E plus A minus your first equation is A. So A gets cancelled. What else will get cancelled? Let us see. 3B minus B is B. Now plus 2D minus this D will come over here. It gives 2C plus E. So this is B plus D gives 2C plus E. Clear everyone? Now see. Now over here second equation was what? Second equation was minus 125 plus third equation was minus 350. Minus, what was first one? First one was minus 300. So minus 125 minus 350 plus 300. It is going to be minus 475 plus 300. It's going to be minus 175. Answer comes out to be minus 175. That means option number B is going to be your right answer. Option number B. Yes, everybody. Option number B is going to be your right answer for this particular question. Clear everyone? Clear everyone? Clear everyone? Kindly write it down. After now few questions, we shall end this chapter also. Kindly write it out. These are the same type of questions, so I am not taking them. Done with question number 87, everybody. Now comes question number 88. Question number 88 is, consider the following liquid vapor equilibrium. Consider the following liquid vapor equilibrium. Which of the following relations is correct? You have to tell me which of the following relations is correct. You have been given 2 minutes time. Think about it. Which equation is this? Which equation is this? Anybody, which equation is this? Ma'am, please check answer of 96. Sorry. Yeah, it's right. 86 you are saying. 86 it's right. Do it again, Shivanshu. If you feel like, then we'll do it again. Okay, this is Clashes-Clapeyron equation. So option number B, according to that, is going to be the right answer. Not D1, B. Yes, Dipta, B is the right one. Okay, let us see the next question of this now. Question number 89th. Okay, which of the following statements is correct for the spontaneous adsorption of a gas? For the spontaneous adsorption of a gas, A, delta S is negative, therefore delta H should be highly positive. B, delta S is negative, therefore delta H should be highly negative. C, delta S is positive, there should be delta H should be negative. D, delta S is positive, delta H should be highly positive. Now tell it fast. It's very easy question. When we are talking about a spontaneous reaction, see, you are talking about adsorption. What do you refer to as adsorption? For example, this is your adsorbent, and adsorbate molecule comes and it is they do interaction with the surface molecules. The adsorbent molecules interact with the adsorbate. Adsorbent surface molecules react with them. It is a surface phenomena. Now during adsorption, when the molecules do interactions, the entropy will decrease. Delta S will be less than 0. If delta S is less than 0, that means delta S is negative, negative. And we know that delta G is equals to delta H minus T delta S. If it is negative, negative into negative will become positive. Negative into negative will become positive. And delta H for a spontaneous reaction should be negative. If it is positive, it is negative. Then in order to make it negative, delta H should be negative. So both should be negative. Therefore, it should be highly negative. That means option number B, students, will be your correct answer. Yes. Dipta Spy Thunder, yes. Option number B will be your correct answer. Clear, everybody? Clear, everyone? Clear, 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 everyone? Okay. Now let us see one more question and we shall end this session over here. Okay. Question number 90th. For the gas phase reaction, which of the following conditions are correct? For the gas phase reaction, which of the following conditions are correct? Okay. Now for this particular reaction, what is happening? See, basically entropy is increasing or decreasing. First of all, tell me, entropy is increasing or decreasing for this particular reaction? Delta Ng is being increasing or decreasing. See, you know that delta H is equals to delta E plus delta NgRT. Here if you see two gaseous molecules and initially it was 1. So 2 minus 1 is 1. That means this is a positive value. If this is a positive value, delta H is a positive value. That means delta H is more than 0. Delta H is more than 0. This is incorrect. Incorrect. Delta S is more than 0. Now talking about delta S. What will happen to delta S, students? Delta S will become a positive value because number of ions are being increased. Yes, increase. Yes, Praveena, increase. Delta S will also increase. Delta S, if it is increases, it is more than 0. That means option number B is your right answer. Option number B is your right answer. Clear, everyone? Kindly write it down. Now students, we are going to start with our next chapter. Let us start with our next chapter, everybody. Kindly take a screenshot. We will start with our equilibrium chapter from now. We are going to start with our equilibrium chapter. Everybody, are you ready? Everybody, are you ready? Shall we start with equilibrium? Question number 91. Now we are starting with the chapter equilibrium. Question 91. Shall we start? Sorry students, kindly correct over here. It is option number D. Delta S is more than 0, not less than. Delta S is positive. Okay. Okay. Now, shall we start with equilibrium? Yes, everybody. Now, the question for equilibrium is in front of you. 3O2 gives 2O3. For the above reaction at 298 Kelvin, Kc is found to be 3 into 10 raised to the power minus 59. If the concentration of O2 at equilibrium is 0.040 molar, then the concentration of O3 in molar will be what? Now, the reaction is given to you. I am giving you 2 minutes in order to think about it. Just think about it and then we are going to start it. After equilibrium, we will only be left with redox reaction chapter for class 11th. We will be completing class 11th, then we will be proceeding to class 12th. Okay, but what I feel is we will, before doing redox reaction, we shall do some questions of class 12th solid state. So it will be a change for you people also, right? So first of all, solve this equilibrium one. Now, our reaction is 3O2 gaseous gives 2O3 gaseous. This is the reaction? Yes, ma'am. Now see, for the above reaction, Kc is found to be, now this is the, the value of the constant that they have given you. If the concentration of O2 at equilibrium is this much, now let us say, consider it is 1 initially, it is 0, okay. Now we will say it will be 1 minus x moles dissociated at equilibrium. Now there is 3 written, so we will write 1 minus 3x, and here will be x moles formed, here is 2 written, so we will write 2 over here. This is by what we solve these kinds of questions. This is how we solve these questions. This is how we solve these questions, everybody. Now, what will be Kc? Kc will be what? Product is O3 raised to the power this 2 divided by O2 raised to the power 3. What is the value of Kc? Ma'am, the value of Kc is basically 3 into 10 raised to the power minus 59. Now, what else they have given you? They have given you the concentration of O2 at equilibrium. O2 concentration they have already given you. So, Kc is basically O3 raised to the power square divided by what is concentration of O2? 0.040 whole cube is equivalent to 3 into 10 raised to the power minus 59. Now, see, O3 square is equivalent to 3 into 10 raised to the power minus 59. Now you will multiply it thrice, 0.040 into 0.040 into 0.040. Yes, everyone? Yeah, it is last year question. 3 into 10 raised to the power minus 59. What I can say is, I can say it's 1 by 1000 whole cube, and this is 4 whole cube. Yes, it is 40 whole cube, you can say. Or if you are taking 0.04 only, so you will write 4 whole cube divided by 100 whole cube. You can also write it like this, right? Now see, 4 into 4 into 4 is 64, 64 into 3. Now we are going to get the, approx answer. 64 into 3 divided by 100 raised to the power 3. So this is 12, 1 carry, 192. Now it is square written, so it will be square root 8 root 3. 8 root 3. Now root 3 is 1.7. 8 into 1.7. Approximate answers you have to calculate. So it is coming to be approximate by, if you are getting the approximate answer over here, O3 value, O3 raised to the power 2 will come out to be 1.92 something. That is 192. See, it is 192 by 100 raised to the power 3. This is the value of O3 square. This is the value of O3 square. Just leave it, okay, just focus over here. This is the value of O3 square, which came out to be 192 by 100 whole cube. Now when you will calculate O3, it will come out to be 4.38 into 10 raised to the power minus 32. Answer will be approximately A option. Kindly students, it is a humble request. Your exams are approaching. It is your future that lies in your hand. If you want to waste your time, then you can. It's up to you. But don't do that. You will regret it afterwards. So please study over here. Please focus over here. Yes? Okay. Now, let us see the next question of ours. Question number 92. Question number 92. The equilibrium constant of the following are, here they have provided you with the equilibrium constant. N2 plus 3H2 gives 2NH3. K1 is the equilibrium constant. For the next reaction is K2. For the third is K3. For this you have to tell. For this reaction you have to tell. Okay. Now see. For this particular reaction, what you basically require? You require 2NH3. Okay. Now you require 2NH3 here in this side. That means you are going to reverse this reaction. In the reactant side you want it. So it will become 1 by K1. Because you have reversed it. What else do you require? What else do you require? You require 2NO in the product. It is already in the product. You require 3H2O in the product side. But here it is only 1H2O. That means you are multiplied by 3. Then only 3 will come over here. So it will become K3 raised to the power 3. New equilibrium. Whenever you are multiplying by a number, it will become 3. Okay. Now see, first reaction comes out to be 1 by K1 because you have reversed it. Into second will remain as it is. Into third is you multiplied by a number 3. So it will become power 3. So what it will be? It will be K2 into K3 raised to the power 3 by K1. That means which of the following is going to be the correct answer? Option number A is going to be the correct answer. Option number A is going to be the correct answer for this particular question. Clear everyone? Clear everyone? Shall we see the next question of ours for now? Okay. Now comes question number 93. Question 93 is, if the equilibrium constant for this reaction is K, the equilibrium constant for this reaction will be what? Now if you compare both of the reactions, you have multiplied this by 1 by 2. Then only you will get that reaction. That means if you are multiplying with 1 by 2, the equilibrium will get power as 1 by 2. The new equilibrium will be K raised to the power 1 by 2. Because if you are multiplying by 2, power will become 2. If you are multiplying with 3, power will become 3. If you are multiplying with 1 by 2, power will become 1 by 2. So answer will be option number D, that is K raised to the power 1 by 2. Clear? Kindly write it down, students. Kindly take a minute and write it down. Shall we move on to the next question of ours now? Question number 94. Shall we move on to the next question? Question number 94. So here is question 94. Given the reaction between two gases represented by A2 and B2 to give the compound AB, at equilibrium the concentration of A2 and B2 and AB are given to you. You have to calculate the value of Kc. See, for this reaction A2 plus B2 gives 2AB. Am I right? You have to calculate the value of Kc. What will be Kc? Ma'am, Kc will be AB whole square, because 2 is written, divided by concentration of A2 into concentration of B2. What is AB concentration at equilibrium? Ma'am, 2.8 into 10 raised to the power minus 3 whole square, divided by, what is the concentration of A2? It is 3 into 10 raised to the power minus 3 into what is concentration of B2? 4.2 into 10 raised to the power minus 3. Am I right? Samrat and Spy Thunder, please, it's a humble request. Kindly do the questions. You both were performing so well. You both were, answering so well. Please don't do this now. Right? Now we have over here this. Now let us solve it out. What it will be? 2.8 into 2.8 into 10 raised to the power minus 6 divided by 3 into 10 raised to the power minus 3 into 4.2 into 10 raised to the power minus 3. Right? Now 28 by 10 into 28 by 10 into 3, and here we have 10 raised to the power minus 6, and down we have 10 raised to the power minus 3 into this also minus 6. So this will get cancelled, because when something is in multiplication it will get add on, and this is 42 by 10. So this 10 gets cancelled. Now on the table of 2, if I go 21, it goes on the table of 2, 14. What you will get? 28 into 14 by 3 into 21. On the table of 7, If it goes, it will go 2 and it will go as 3, right? So what you will get over here? You will get over here 9. You will get 16, 1 carry, 56 by 9. You will get 56 by 9. That means you will go on the table of 4.5. Answer is going to be option number D. Answer comes out to be option number D. Clear everyone? Clear everyone? Sorry, wait for a second please. There we have missed this 10 over here. This 10 is still left. This 10 is still left. So here will be 110 also. That means it is 90. Now solve this question. Now this is 56 by 90. Right? This is 56 by 90. So when you are going to solve this, let us check again. If any 10 is left, it is 28 into 14 by 21 into 3 into 10. Yeah. So this 3, this goes on the table of 3, on the table of 2. This is 56. Then we have 3 into 3, that's 9. 9 into 10, 90. Clear everyone? Clear everyone? Yes ma'am, yes ma'am, yes ma'am. So this comes out to be 0.62 something. 9 6 are 54, yeah, 0.62 something. Clear? Clear everyone? So option number C is the right answer. Let us see your next question. Question number 95. For the reaction N2 plus O2 gives 2 NO, the equilibrium constant is K1. The equilibrium constant is K2 for this reaction, and what will be for this one? Now see. If we see both of these reactions over here, we want NO2 in the reactant side. We want this on the reactant side. Also, we want only, basically, we want only one NO2. That means we are going to, reverse it. First of all, when we are going to reverse it, it will become 1 by K2. Moreover, we will multiply it with half. Then only we'll get NO2. When we'll multiply it with half, it whole will become half. Power will become half. Power will become half. Yes, ma'am. Okay. Now, over here in this reaction, we want N2 and O2 in the product side. Over here, we want them in the product side. When we are taking them on the product side, we are multiplying it with half again. Take in the product side, opposite it, reverse it, it will become 1 by K1. Again, we are multiplying it with half, so power will become half. What it will be? It will be 1 by K1 into K2, and the power is going to be half. That means option number C is going to be your correct answer. Option number C is going to be your correct answer. Clear? Clear? Clear everyone? Kindly write it down. Kindly write it down so that we can move on to the next question now. Shall we? Yes, C is the right one. Now comes your question number 96. Question number 96. The value of equilibrium constant for the reaction, for this reaction is 8. The equilibrium constant for this reaction will be what? Now see, if you compare both of this reaction, first of all, reverse this reaction. Compare this reaction. First of all, reverse this reaction. If you reverse it, it will become 1 by 8. Now, here when you are reversing it, you require 2 HI, but here it is 1 HI. That means you are multiplying with 2. Then only you multiplied by 2, that means power will become 2. That means 1 by 64 is the correct answer. So 1 by 64 is the correct answer. Clear everybody? Clear everybody? So option number D is the correct answer. Answer is going to be option number D. Shall we move on to the next question if it is done, everyone? Shall we? Now comes question number 97th. Okay students, now this is half of the equilibrium that is covered. Half of the equilibrium we will cover afterwards. Half of the equilibrium is covered. Only half. Still we are left with some questions of equilibrium chapter that we will cover after few questions of class 12th. Now I am going to take some class 12th questions in order to change the flow that we are going through. I want curiosity to generate while solving some questions of class 12th as well. So now some questions of equilibrium are left and redox reaction is left, that we will do after this chapter of class 12th, right? So now question number 97th. So you can write it as this we have done. This is equilibrium, your part 1. Part 2 we will continue after this chapter. Now comes your chapter solid state. Now comes your chapter solid state, right? Now this is your basically your question number 97. Now we are doing question number 97 as our solid state. Yes? Oh my god, answers are already, I am getting answers, right? Glass is A option liquid, B option solid, C option supercooled liquid, D option transparent organic polymer. Okay, Praveena has already answered. Praveena has already answered. Anyone else? Anyone else, students? What is a glass? Glass is a supercooled liquid. Okay, let me explain you it, okay? We can now discuss some questions. This is a theoretical base, that's why I have taken this, okay? See, if I talk about glass, glass is a supercooled liquid. Why? Because glass has a tendency to flow like liquids. It has a tendency to flow like liquids. Now, basically, it is your, I would say, pseudo-solidants, which appears to be solid, but actually exhibits some property of liquid as well, which has a tendency to flow. So, option C is going to be the correct answer for this particular question. Option number C is the correct answer for this particular question. Now, let us see question number 98. Question number 98 is in front of you. 98 is, most crystals show good cleavage because their atoms, ions or molecules are A option weakly bonded together, B option strongly bonded together, C option spherical, symmetrical, D option arranged in planes. What do you feel, students? What do you feel is going to be the right answer for this? Why they show good cleavage? Because the atoms are arranged in planes, that's why. Because they are arranged in planes, that's why they can show a good cleavage. Hence, option number D, students, is going to be your correct answer for this particular question. Let us see the next question now. Question 99 is in front of you. Question is, the ability of a substance to assume two or more crystalline structures is called. The ability of a substance to assume two or more crystalline structures is called A option isomerism, B option polymorphism, C option isomorphism, D option amorphism. Now see, ability of substance to assume two or more crystalline structures. For example, one can make more than one forms. So poly refers to as many and morphism is forms. So many forms. A substance with more than one forms. That means option number B is going to be your correct answer. Option number B is going to be your correct answer. Now see, these questions won't take much time, students. I want answer in few seconds only. I want its answers very fast like this, okay? Now comes your question number 100. This is your 100 question. Let us see the question. The correct option for the number of body-centered unit cell in all 14 types of Bravett lattice unit cell is. Now, when you study the 14 types, under they are classified into 7 basic units. And in that, body-centered ones are how many? How many? And which of them exhibits them? Answer is 3. It is seen in orthorhombic, tetragonal, and monoclinic. Clear, everyone? In these 3, you shall, orthorhombic, tetragonal, cubic. Cubic is the one that we used to study in our chapter also, not monoclinic, cubic. Now, after this question, I will be making a table for you so that it will be easy for you to learn also, okay? Orthorhombic, tetragonal and cubic. Clear, everyone? Clear, everyone? So, 3 basically is the right answer. Sargi, 7. Why are you writing 7? 7 is the Bravett lattice that you are talking about. Here they are talking about number of body-centered unit cell present in them. So, 3 will hold that. Right, Praveena? Exactly. I am not asking about 7 Bravett lattice. No. I am talking about the ones that makes body-centered. So, 3 will do that. These 3 will have body-centered in them. Now, question 101. For orthorhombic system, axial ratios are A not equal to B not equal to C and the axial angles are. Now see, let me tell you, there is a very simple trick in order to learn this, okay? That is cute, our mother. If you don't know, I am telling you a trick, you can learn from this trick. Cute our mothers. See, our mothers are really very cute. They are the precious gifts of God. I would say the another name for God is our mother, right? So each and every one of you can agree on this topic of mine, that your mothers are, you know, a God's creature. That itself is a God, right? Because we have not seen God, but we know our mother and father both are God for us. So similarly, I have created a trick that is cute our mother. Now how you have to learn this? See, basically here cute. This cute stands for, CU over here stands for cubic. TE over here stands for tetragonal. If I talk about R over here stands for orthorhombic. And if I talk about mother, MOTHER, then over here MO stands for monoclinic. Okay, T stands for triclinic. HE stands for hexagonal. And R stands for rhombohedral. So by this way you can learn these sevens. By this way you can learn these sevens. Clear? Clear everyone? Cute our mother. CU stands for cubic. T stands for tetragonal. R stands for orthorhombic. MO stands for monoclinic. T stands for triclinic. HE stands for hexagonal. And R stands for rhombohedral. Now let me tell you one simplest thing over here, that see, all the cute are in these three, alpha is equals to beta is equals to gamma is equals to 90 degree. Always remember, in cubic, tetragonal and orthorhombic. In cute R, it is always alpha is equals to beta is equals to gamma is equals to 90 degree. So they are talking about when A is not equal to B is not equal to C. Now there is a trick to remember that. Let me tell you the trick also. See, kindly write their name over here. It is cubic, cute, tetragonal, R orthorhombic, mother monoclinic, triclinic, hexagonal, and rhombohedral. Right? Right? Now see how to learn it. Right here, unequal parameters. There is a trick to remember them. Unequal parameters. Go for like this: 0, 1, 2. Write 0, 1, 2. And here write 2. Just write this value. 0, 1, 2. From base 0, 1, 2. Then write 2. Now write axial lengths. Now see. Here if it is written 0. First write A equal to B equal to C. Then write A equal to B equal to C. Then write A equal to B equal to C. Then write A equal to B equal to C. Write A equal to B equal to C. A equal to B equal to C. A equal to B equal to C. Now see students, what you have to do. Here 0 is written, that means everything is equal. Here 1 is written, then from right hand side make it unequal. Here 2 is written, then from right hand side 1 and 2 make it unequal. From right hand side make 2 unequal. Make 2 unequal. Here 1 is unequal, here 0 is unequal. So this is the values. These are the values that you can learn. You can learn now easily. Everybody can learn it easily. Yes. Yes, now coming back, A not equal to B not equal to C in the case of orthorhombic and in the case of monoclinic and triclinic. But there they are saying in this case the axial angles in orthorhombic just we have done in orthorhombic, alpha is equals to beta is equals to gamma is equals to 90 degree, ma'am. So option number B is the right answer, ma'am. Clear everyone? Kindly write this and then write this, giving you 2 minutes in order to write it down. Giving you 2 minutes in order to write it down. Done everyone? Written everyone? Shall we move on to the next question? This was your question number 101. Now let us see question number 102. Question 102 is number of carbon atom per unit cell of diamond unit cell is. Tell me fast now. It is like a ZNS structure, so the atoms are going to be 8. It is like ZNS structure, so the total number of atoms is 8. Clear? 103 question, let us see now. In a face-centered cubic lattice, a unit cell is shared equally by how many unit cells? Now see, here they are talking about simple face-centered cubic lattice. So face-centered will be shared by, 2 only. 2 only. It will be shared by 2 only. No. Here when you are writing with respect to, a unit cell. But here you have to answer it like this. For example, this is your face-centered. It is touching how many? If it is faces, it is touching 1, 2, 3, 4, 5, 6. 6 faces. It is touching 6 faces. So the answer is going to be 6. Here you don't have to answer with respect to face-centered cubic unit cell. Here they are talking about face-centered cubic lattice. But here they are talking a unit cell is equally shared by how much? So 6 will come as your right answer. Let us see the next one. Next one is question number 104. You are calculating the one that has written the value as 6, Shivani, 6. Okay, now comes 104. When Zn converts from melted state to its solid state, it has HCP structure. Then find the number of nearest atom. A6, B8, C12, D4. HCP structure, hexagonal closed packing. HCP is what, ma'am? Hexagonal closed packing. So if it is hexagonal closed packing, you should know the coordination number is what? Coordination number is 12. Coordination number is what? Coordination number is 12. So if we have to find the number of nearest atom, that means how many atoms it is touching, that means coordination number. So coordination number is 12 over here. Clear? Yes. Shall we move on to the next question? Sorry. Now comes question 105. Question 105 is, the FCC crystal contains how many atoms in each unit cell? The FCC crystal contains how many atoms in each unit cell? A6, B8, C4, D5. What do you feel, students? How many atoms in each unit cell? That means you have to calculate Z. How you will calculate Z? Z is basically total atoms into contribution of one atom in a unit cell. Now see, if I talk about FCC, in case of FCC, atoms will be present at face center as well as at the corners. So first of all, Z, total atoms at the faces are 6, contribution is 1 by 2. Total atoms at the corners are 8, contribution is 1 by 8. So this comes out to be how much? 4. This comes out to be how much? 4. So option number C is going to be right answer for this particular question. Option number C is going to be right answer for this particular question. Clear, everyone? Clear, everyone? Shall we move on to the next question? Shall we move on to the next question? Now comes question number 106. Question 106 is, the number of atoms contained in a FCC unit cell of a monoatomic substance is? The number of atoms contained in a FCC unit cell of a monoatomic substance is the same question that we have done right now. It is going to be 4. In a single unit cell, how many atoms are present? 4 are present at face corners as well as at the corners. Right, everybody? Clear? Let us see question number 107. Question number 107. Question 107 is, a compound is formed by cation C and anion A. The anion forms hexagonal closed packed lattice and the cations occupy 75% of the octahedral voids. The formula of the compound is? So think about it once, then we are going to solve it out. Now see, in HCP, how many atoms are there? Anions form HCP. And in HCP, how many atoms are there? Z is 6 in the case of HCP. So number of atoms basically is how much? It is 6. Number of atoms basically is how much? 6. Now see, if number of atoms is 6, octahedral voids will be how much? 6. Because it is equivalent to number of atoms. Now, how much cations are there? Cations occupy 75% of octahedral voids. If it is 6, it occupies 75% of that. Now, on the table of 2, on the table of 5, we'll get 45 by 10. We'll get 45 by 10. On the table of 2, on the table of 5, you can divide it 9 by 2. Now see, anions basically, cations basically is 9 by 2. Anions basically is 6. So multiplied by 2 first of all, it will be 9 by 2 into 2 and anion 6 into 2. So this 2 gets cancelled. We will get C9A12. Now divide on the table of 3, it will be C3H4. Sorry, C3A4. 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 Option number D, students, will be your right answer. Option number D will be your right answer, right? Clear, everyone? It is clear to everyone. Shall we move on to the next question? Now comes your question number 108. Question 108. In calcium fluoride having the fluoride structure, the coordination number for calcium ion and fluoride ions are 4 and 2, 6 and 6, 8 and 4 and 4 and 8. What do you think, students? See, the coordination number of calcium basically plus 2 is going to be 8, and for fluoride coordination number is going to be what? 4. Right? Right, everybody? Because each Ca plus 2 is connected with 4 F negative. So Ca plus 2 will have a coordination number of 8 and F negative will have a coordination number of 4. So option number C is going to be the right answer for this particular question. Now let us do question 109. Question 109 is, a solid compound XY has NaCl structure. If the radius of the cation is 100 picometer, the radius of the anion will be A option 275.1 picometer, B option 332.5 picometer, C option 241.5 picometer, while D option 165.7 picometer. So students, tell me fast. You have been given a solid compound NaCl structure. If the radius of the cation is 100 picometer, what will be the radius of anion? A direct formula for this particular question. Ma'am, radius of cation by radius of anion is equivalent to 0.414. Now, radius of cation is 100 picometer. Radius of anion we need to calculate for 0.414. This is for NaCl structure, right? Now, when I'm going to cross multiply, radius of anion is going to be 100 by 0.414. How much? 100 by 0.414. Clear, everyone? Clear? When you're going to solve this out, no, you will get your answer as 241.5 picometer. That means option number C is going to be your right answer for this particular question. Kindly write it down, everybody. Kindly write it down so that we can move on to the next part. Kindly write it down so that we can move on to the next question of ours. Now, students, comes your next question. That is your question number 110. Let us read the question. A compound formed by element X and Y crystallizes in a cubic structure in which the X atoms are at the corners of the cube and Y atoms are at the face center. The formula of the compound is A option XY3, B option X3Y, C option XY, D option XY2. Now see, students, over here they are saying that X atoms are present at the corners and Y atoms are present at the face center. So if I am going to draw the structure for this, what it is going to be. X atoms are at the corners, so these are the corners. So blue atoms are represented as corners 1, and this face center are represented by this face centers. Top, bottom, left, right, front, back, right. Now you have to calculate the value of the formula. You have to invent the formula. Now see, if effective number for X is equivalent to total atoms into contribution of one atom in a unit cell. Now total atoms in the corners case is 8, total 8 corners, contribution is 1 by 8. So X comes out to be 1. Now for the Y, total atoms for the faces are 6, contribution is 1 by 2, this comes out to be 3. X comes out to be 1, Y comes out to be 3. XY3 is our formula. XY3 is our formula. Option number A is going to be the correct one. Option number A is going to be the correct one. Yes, everybody? Yes, everyone? Clear? Shall we see the next question? Kindly write it down once, then we can proceed to the next question. Done. Okay, now comes question number 111. The second order Bragg's diffraction of X-ray with lambda is equivalent to 1 Armstrong form a set of parallel planes in a metal occurs at an angle 60 degree. The distance between the scattering planes in the crystal is A 2 Armstrong, B 1 Armstrong, C 0.575 Armstrong, D 1.15 Armstrong. Students, Bragg's equation here you have to apply. N lambda is equivalent to 2d sine theta. Right, everybody? Now what is N? N is second order, so 2 will come. What we have to calculate? We have to calculate the distance between the scattering lights, right? So lambda value is 1 Armstrong into what is 2 into D. We have to calculate sine theta. Theta is 60 degree. Sine theta. Theta is 60 degree. Okay, what is sine 60? Ma'am, it is root 3 by 2. What it is? It is root 3 by 2, right? So 2 and 2 will get cancelled. 1 is equivalent to D into root 3 by 2. So D comes out to be 2 by root 3. D comes out to be what? 2 by root 3. Everyone, your answer and my answer are matching or not? This comes out to be 1.15. 1.15 Armstrong. Answer comes out to be option number D, 1.15 Armstrong. Clear, everyone? Was it a simple question? Isn't it a simple question? Let us proceed to the next question if it is done. Let us proceed to the next question if it is done. Now comes the next question, question number 112. Question is, the intermetallic compound LiAg crystallizes in a cubic lattice in which both lithium and silver had coordination number of 8. The crystal class is A, face center cube, B, simple cube, C, body centered cube, D, none of these. So think about it, students. The coordination number for both is going to be 8, right? Now let me tell you, in the case of body centered cubic unit cell, the atoms are present at the corners as well as at the body center. So at the body center it is 1, but at the corners it is 8. So the structure is going to be BCC. Exactly. Body centered cube is going to be our correct answer for this particular question. Let us see question number 113th. Question 113 is, AB crystallizes in a body-centered cubic lattice with edge length A equal to 387 picometer. The distance between two oppositely charged ions in the lattice is? The distance between two oppositely charged ions in the lattice is going to be what? Now A option is 335 picometer, B option is 250 picometer, C option is 200 picometer, D option is 300 picometer. So students, kindly put the formula and calculate its answer. It is in BCC, body centered cubic lattice. So basically, you very well know that twice into cation's radius plus anion's radius is equivalent to root 3a. That is the diagonal's radius, right? So basically, twice into See, distance we have to calculate root positive plus r negative, that is the anion's radius, into root 3 into a is 387. What is this? This comes out to be root 3 into 387 by 2. Root 3 value you can put directly and you can solve this particular question. So students, your answer will come out to be 335 picometer. 335 picometer. Answer will come out to approximately 335 picometer. Hence option number A is going to be your correct answer for this particular question. Clear everyone? Kindly take a screenshot of this question so that we can start with the next question of ours. Shall we start? Yes. Question number 114. See, question is, lithium metal crystallizes in a body-centered cubic crystal. If the length of the side of a unit cell of lithium is 351 picometer, the atomic radius of lithium will be. Now, it is given body-centered cubic, this, right? So, we basically know that, 4r by root 3 is equivalent to A. This was the relationship that we have already established. This is the relationship. 4r by root 3 is equivalent to A, right? So here atomic radius of this will be 4 into r value. If the length of the side, A value they have given you, r you have to calculate, by root 3 is equivalent to how much? 351. So r comes out to be 351 into root 3 by 4. Yes everyone, is it clear? So this will come out to be 151.8. This will come out to be 151.8 picometer. 151.8 picometer. Option number A will be your correct answer for this particular question. Shall we proceed to the next question? Shall we start with the next question, everybody? Okay, now comes question number 115th. Question is, if A stands for the edge length of a cubic system, simple cubic, body-centered cubic and face-centered cubic, then the ratio of the radius of the spheres in their system will be respectively what? Now see, for the simple case SCC, I can say A is equal to 2R. Okay, so R will be what? A by 2. For FCC, I can say A is equal to 4R by root 2. So what will be R? R will be root 2A by 4. Or you can even say A by 2 root 2. Okay. Now for BCC, I would say A is equal to 4R by root 3. So R will be root 3A by 4. Now let us see. First of all, for SCC, it is A by 2. A by 2, A by 2, A by 2. Now you have to write for BCC. It is root 3A by 4. Root 3A by 4. And last is 1 by 2 root 2A. That means option number C, students, is your correct answer. Option number C is your correct answer. Clear everyone? Is it clear to everybody? Shall we move on to the next question if it is done? Yes, students. Done, done. Okay, now comes question number 116. Question number 116. Now see. The stoichiometric density of sodium chloride crystal is 2.165 into 10 raised to the power 3 kg per meter cube, while its X-ray density is this much. The fraction of unoccupied sites in the sodium chloride crystal is what? Right. So tell it fast, students. What will be the mass first of all? See, you know density is equivalent to mass by volume. See, density they have given us as 2.165 into 10 raised to the power 3. Right? Can you calculate density? Can you calculate mass over here from this formula? Yes, everybody. Okay, let us consider mass as M. Let us consider mass as M. What will be volume? Volume will be M by 2.165 into 10 raised to the power 3. This is the value. You have calculated. Shivansh has written A option as the correct answer. Okay, we will check. We will check, Shivansh. Now, let us calculate for the another one also. For the X-ray density also, what will be? Density is equivalent to mass by volume. What is density for that? 2.178 into 10 raised to the power 3 is equivalent to mass, let us say as m, right? Because we are talking about, okay, that sodium chloride crystal only, so mass let us consider as m common for both. What is volume? Now volume as V. What is volume come out to be? M by 2.178 into 10 raised to the power 3. Yes, yes. Now they are saying the fraction of unoccupied sites. So what we are going to do? We are going to subtract both of them. Volume, we are going to subtract both of them. Now when we are going to subtract both of them, molecular mass by 10 raised to the power 3 will come common, and it will be 1 by, you know, now you have to minus it. See, this is the psychometric density and that is the X-ray density. That means you are going to divide by 1 by 1.65 minus 1 by 2.178. So what we will get over here? This is the fraction of volume. This is the fraction of volume. They are asking the fraction of unoccupied sites in the crystal will be what? This is the fraction of volume, right? Now how to calculate fraction? How to calculate the fraction of unoccupied? This is divided by the initial one. This divided by the initial one. This divided by the initial one. So when you are going to solve it, the answer over here will come out to be your option number D. Clear? Question number 117th. The edge length of a face-centered unit cell is 508 picometer. If the radius of the cation is this much, the radius of the anion will be what? You have been provided with the 4 questions. You have been provided for the 4 options, sorry, not questions, 4 options. Yes, everyone. The edge length will be equivalent to 2r plus r, or radius of cation plus radius of anion. What is the edge length value? It is 508 divided by 2, that is radius of cation plus radius of anion, you can say. If the radius of this will come out to be 254 is equivalent to, the radius of the cation is 110, but the radius of anion we don't know. So radius of anion will be 254 minus 110, that means 441. So this comes out to be 144 picometer. Answer will come out to be option number A, that is 144 picometer. Clear everybody? Clear everyone? Yes, is this question clear to everyone? Okay, now we will be doing, okay, one question on the density. One question on the density. It is question number 118. Question 118. CSBr crystallizes in a body-centered cubic lattice. The unit cell length is 436.6 picometer. Give that the atomic mass of CS is 133 and that of Br is 80, and the Avogadro number being this much. The density of the CSBr is. So what is density? Density is Z into molecular mass by Avogadro's number into edge length whole cube. This is the formula for density, right? So what is Z over here? Body centered. For body centered, Z is going to be 2. What is molecular mass? You can calculate for CSBr. For CS it is given as 133 and for Br it is 80. So this comes out to be 213. Divided by Na value is 6.02 into 10 raised to the power 23 into A cube. What is A given over here? Ma'am, it is 436.6 picometer whole cube, right? So when you are going to solve it out, students, you are going to get your answer for density. 4.25. One more thing, you have to convert this picometer, right? So you'll multiply it by 10 raised to the power minus 10. You'll convert it into, centimeter. So your answer after calculating will be 4.25 gram per centimeter cube. Clear? Clear, clear, clear. Clear everybody? Kindly write it down so that we can move on to the next question. Let us see the next question now. Next question is, Question 119. Now this is an assertion reason question that they have given you. Samrat, no need to worry. You can focus from this question and then you can see afterwards. Assertion is, in a particular point defect, an ionic solid is electrical neutral even if few of its cations are missing from its unit cell. Reason is, in an ionic solid, Frenkel defect arises due to dislocation of cation from its lattice site to interstitial site, maintaining overall electrical neutrality. So you have to tell that both are correct and reason is correctly explaining the assertion. Secondly, both are correct but it is not explaining the assertion. Third, assertion is right but reason is wrong. Fourth, assertion is wrong but reason is right. Now students, see, in a particular point defect, an ionic solid is electrical neutral even if its few of its ion are missing from its unit cell. See, here when they are saying, when they are missing, they might be in their interstitial sites, right? One of the students is saying C. Anyone else? Anyone else? What do you feel? Anyone else? What do you feel? Which is the right answer? Only Spy Thunder has written the answer. Anybody else? See, both are right, but reason is not explaining our assertion. Reason is not the correct explanation for assertion, right? So option number B is the right answer for this particular question. Let us move on to the next one. Next one is, the correct statement regarding the defects in crystalline solid is A. Frenkel defect decreases the density of crystalline solid. B. Frenkel defect is a dislocation defect. C. Frenkel defect is found in the halides of alkaline metals. Or D. Schottky defect has no effect on the density of the crystalline one. So what do you feel, students? Which is the right answer? It decreases the density? No ma'am. Why? Because see, it is a dislocation defect. Only the smaller ions will dislocate and move into the interstitial site. So it is a dislocation defect. This is the right one. It is found in the halides of alkaline metals. No, this is also wrong statement. Schottky defect has no effect on the density. It has an effect. In Schottky defect, equal cations and anions are missing. Right? So option number B is the right answer. Now this was your question number 120. Let us see your next question, question 121. Question 121 is, the appearance of colors in the solid alkaline metal halides is generally due to A. Interstitial positions, B. F centers, C. Schottky defect, D. Frenkel defect. So students, you have completed equilibrium concept. Equilibrium part 1 is completed, part 2 is still left. So no need to worry. Now again, F center, students, is responsible for imparting colors. So option number B is the right answer. Yes Joshni, yes Spy Thunder. Let us move on to the next one. That is, sorry. Now comes question number 122. Schottky defect in crystals is observed when A. Density of the crystal is increased. B. Unequal number of cations and anions are missing from the lattice. C. An ion leaves its normal side and occupies an interstitial site. D. Equal number of ions and cations are missing. So now only I have told you in the previous question only, equal number of cations and anions are missing from the lattice side. Hence option number D is going to be the right answer for this particular question. Let us see your next question, question 123. Which is the incorrect statement? You have to tell the incorrect statement. A option, density decreases in the case of crystals with Schottky defect. B option, NaCl is insulator, silicon is semiconductor, silver is conductor, quartz is a piezoelectric crystal. C. Frenkel defect is favored in those ionic compounds in which size of cations and anions are almost equal. D. This is a non-stoichiometric metal deficiency defect. So students, tell which is an incorrect statement among the following. Now see, this is incorrect one. Why? Because cation size is smaller in case of Frenkel defect and they will dislocate from its lattice point. Moreover, this is also incorrect because the range is till 0.96, not 0.98. So this is also incorrect. So C and D both are here incorrect statements. Now one question as a homework for you all. Question 124 is your homework from this particular chapter, and one more question for your homework. Kindly write this question first of all as your homework. Question 124 is your homework from this particular chapter. Homework from this particular chapter. Clear? This is your homework from this particular chapter. Now one more question as a homework from this particular chapter is 125 question. If we mix a pentavalent impurity in a crystal lattice of germanium, what type of semiconductor will be formed? This is also your homework from this particular chapter. Clear, everyone? So now students, we have completed our solid state chapter over here. We have completed our solid state chapter over here. Now we shall start with the chapter solution. We will be starting with the chapter solution. From question number 126. From question number 126. So do let me know in the comment section, do you want to have your lunch now or after this chapter? Do you want to have your lunch now or after this chapter? Yes, students. Kindly let me know so that we'll take break accordingly. Shall I start solution chapter, or you want to have your lunch first and then after this we are going to continue? Yes, students. Okay, now, okay, 1, 2, 3, 4 are saying now. Okay, so now it's almost 3, so we shall start again back. Now this is a 20 minutes break. After this, the break will be of shorter period, only for 5 minutes or more, or 10 minutes. There will be no, a bigger break. So basically, 20 minutes break, go and have your lunch, students. Now we have been left only with redox reaction chapter from class 11th and some part of equilibrium from class 11th, and class 12th we have completed your solution chapter, and we will move further, right? So basically this is 20 minutes break, and time I'm writing, it's almost 3, so at 3:20 we are going to start. At 3:20 we are going to start, okay? We are going to start with our further topic. Clear, everyone? Right, everybody? Okay, at 3:20 we are going to continue. So go and have your lunch. Your time starts now. So hello my shimmering stars. Students, kindly come back so that we can start with our question now. Yes, everybody, join fast so that we can start with our question now. If my voice is audible to everybody and I'm clearly visible, do let me know in the comment section. I guess everyone has done with their lunch, right? Students, please let me know in the comment section. So shall we start, everyone? Okay, students. So yes. Now we are going to start with the chapter solution. With which chapter, ma'am? Solution. Yes, good afternoon everyone. Good afternoon. I hope so. Your preparation is really going very well. Yes. So now to boost up your preparation, we are going to start with the chapter solution. So what you all have to do is, you will be given 2 minutes. Again, I am repeating the instructions if anybody is new. I will be providing you 2 to 3 minutes in order to solve this question, and then I shall be answering you. And you have to match your answers with me. So till now, students, we have covered almost your class 11th syllabus with regard to physical chemistry. Only and only redox reaction and some part of equilibrium is left. Rest is completed. And class 12th, we have done with the chapter solid state. Now we are proceeding with the chapter solution, right? So instructions are same, 2 to 3 minutes will be provided to you and you have to answer, right? Good afternoon, everyone. Good afternoon. Okay, shall we start? Shall we do this now? Okay. So question in front of you is, how many grams of concentrated nitric acid solution should be used to prepare 250 ml of 2 molar HNO3? The concentrated acid is 70% HNO3. I am giving you 2 to 3 minutes in order to think about it, solve it, and then we are going to match it. Right? Anjan Behra has already answered the question, that is C part. She has already answered the question, that is C part. Okay, students. Think about it, how we have to solve this question. It is again a previous year question. Recently asked previous year question. So kindly focus on the question as well. Yes, shall we? Yes, students, shall we do? Okay. See, how many grams of concentrated nitric acid should be used to prepare 250 ml of 2 molar HNO3? Now understand this concept. We know that, students, molarity is equivalent to number of moles of solute divided by volume of solution. When it is given in ml, then you need to divide it by 1000. Then you need to divide it by 1000, right? So molarity as per the question, ma'am, is given as 2 molar is equivalent to what is number of moles. What do you refer to as number of moles, ma'am? Given mass upon molecular mass. What is number of moles? Given mass by molecular mass. Into what is volume provided to you? 250 ml. If it is in ml, that means we are going to divide it by 1000, right? So this comes out to be 4. Let us do this. What is number of moles? Number of moles shall be 2 by 4. That means 1 by 2. That means how much, ma'am? 1 by 2. So step by step, I am solving this question for you people. Now, what is the molecular mass for HNO3? Let us calculate over here. 1 into hydrogen mass plus 1 into nitrogen mass plus 3 into oxygen mass. Hydrogen mass is how much, ma'am? 1. Nitrogen mass is 14 and 3 into oxygen mass is 16. So we'll get 1 plus 14 plus 48. How much it is? 15 plus 48, that is 63 grams. How much? 63. So given mass of HNO3 by 63. What will come out to be as given mass of HNO3? Ma'am, given mass will come out to be 63 by 2. That is 31.5. 31.5 grams. Yes, everybody, that is how much? 31.5 grams. Is the answer same or not? Yes, students. Now they are saying the concentrated acid is this much percent HNO3. So the mass of acid is 70%. How much it came out to be? It came out to be 63 by 2. So the mass will come out to be what? 63 by 2 into 100 by 70. 0, 0 gets cancelled. 7 9s are 63. On the 5, we will get 45 grams as our correct answer. Option number C will be our correct answer. Option number C will be our correct answer. Yes, students? Yes, students, option number C is going to be our correct answer for this particular question. I would request each and everybody to rather not to chat with each other and solve the question over here. This is for your benefit, my dear students, right? Clear? This question is clear to everybody. Kindly take a screenshot of this question so that we can now move on to our next question. Yes, students? Now I will be bringing you question number 128. Okay, now comes question number 128. Question 120, yes, it is 128 now. Sorry, 127. Question 127. Question 127 is, which of the following compounds can be used as antifreeze in automobile radiators? A. Methyl alcohol, B. Glycol, C. Nitrophenol, and D. Ethyl alcohol. Yes, everybody. Yes, everyone. Now let me tell you, students, if I am talking about antifreeze, ethylene glycol is used as an antifreeze. 35% of it is used in antifreeze. 35% volume by volume. So option number B, my dear students, is going to be your correct answer for this particular question. Clear, everybody? Clear? Okay, now comes your question number 128. Your question 128 is, concentrated aqueous sulfuric acid is 98% H2SO4 by mass and has a density of 1.80 gram per ml. The volume of acid required to make 1 liter of 0.1 molar H2SO4 solution is. Option is 16.65 ml, B option is 22.20 ml, option C is 5.55 ml, while option D is 11.10 ml. Yes, everybody? Yes, Torque Biker 350. Yes, you told correct. Anjan told correct. Spy Thunder told correct. Great. Okay. Now, let me know its answer, students. Try to solve this question on your own by first. Done, everyone? See how we have to do this. They have told us that concentrated aqueous sulfuric acid is 98%. What do you refer to as 98% by mass? That means 98 grams of H2SO4 in 100 grams of solution. Now the density of the solution they have already given you. The mass of solution you have got from here. You know that density is equivalent to mass by volume. What is the density they have given you? 1.80. What is the mass? Mass, ma'am, is 100 grams. And what is the volume? We will calculate. Volume will be 100 by 1.80. Now the volume is in ml. Okay. Now we know that, ma'am, molarity is equivalent to number of moles of solute divided by volume of solution. Now if it is in a ml, then that means you need to divide it by 1000. You need to divide it by 1000, right? Now see over here, number of moles of solute is given mass, that is 98 grams. But let us calculate the molecular mass for H2SO4. Let us calculate over here. The molecular mass for H2SO4. How many hydrogen? 2. So 2 into hydrogen mass. How many sulfur? 1. 1 into sulfur mass. Plus how many oxygen? 4. 4 into oxygen mass. 2 into 1 plus 1 into 32 plus 4 into 16. Right? So this is 2 plus 32 plus 64. That means 34 plus 64, which comes out to be 98 grams. How much? 98 grams. How much? 98 grams. Into what is volume? Volume basically is we have calculated 100 into divided by 1.80. Now we have to take it in ml, so divided by 1000. Two zeros will get cancelled. This will get cancelled. You will get your, it is 180 by 100 into 10. So this comes out to be 18. Molarity over here comes out to be 18. Is there any doubt in this? Anybody? Anybody, is there any doubt? 18 molar is the molarity. 18 molar is the molarity. Yes, everyone. Now see. Now we know that M1V1 is equal to M2V2. What is M1? M1 is, ma'am, 18. What is V1? What is V1? If M1 is 18 over here, if M1 is 18 over here, what is V1, everyone? We will calculate V1. Now we have to calculate what is M2. M2 is now, ma'am, 0.1. What is V2? V2 is 1 liter. That means in ml, if we have to take it, we are going to take it 1000 over here. So V1 will come out to be what? 0.1 can be written as 1 by 10 into 1000 divided by 18. So this 0 gets cancelled. Now on the table of 2, it is going to be 50. It is going to be 9. That is 50 by 9. That means 45. So, sorry, 1 second. 45. So it is 5.5 something. 5.55 ml, students. Answer will come out to be option number C. Clear, everyone? Answer will come out to be option number C. Clear, everyone? Yes. Shall we move on to the next question? Kindly take a screenshot of this question over here. Kindly take a screenshot of this particular question over here, students, so that we can move on to the next question of ours. Done, 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 done. Okay. Now comes your next question, that is question 129. That is question number 129. The mole fraction of the solute in 1 molar aqueous solution is. The mole fraction of the solute in 1 molar aqueous solution is. Molality, they have given you 1 molar. What is 1 molar? What do you refer to as 1 molar? What is 1 molar, ma'am? Now see. How you are going to define molality? What is molality, ma'am? Molality is basically number of moles of solute divided by mass of solvent in kg. Mass of solvent in kg. Yes, everyone. This is what is molality. This is how we define molality. So 1 molar basically referred to as what? 1 molar refers to as 1 mole of solute. 1 mole of solute present in 1 kg of solvent. Now if it is aqueous medium, that means we are talking about water. That means what we are talking about over here is we are talking about water. Now we have to calculate mole fraction. So calculate mole fraction for solute will be number of moles of solute divided by total moles. That is the moles of solute plus moles of solvent. Right? Now what is number of moles of solute? Now what is number of moles of solute, students? If I talk over here, it is your given mass upon molecular mass. It will be what? Number of moles of solute is 1 molar. So we are going to write it as 1 directly and divided by, for solute again, 1 directly. Now for solvent over here is what? Solvent over here is our water. Now for the case of water, given mass is going to be what? 1 kg. That means I am going to put 1000. Divided by molecular mass is what? It is going to be 18. Divided by what is going to be our molecular mass, that is 18. So what I am going to get over here? What I am going to get over here as my answer? Yes, anybody in the comment section? What I am going to get my correct answer over here when I am going to solve it? My answer will come out to be 0.018. Option number B is going to be our correct answer. Yes? Yes, everybody? Yes, everybody? Clear? Shall we proceed to the next question if it is done? Okay, that's great. That's great. Now we are moving on to question number 130, 130th. Shall we? Okay. So question number 130th is the concentration unit independent of temperature would be. The concentration unit independent of temperature would be A option normality, B option weight volume percent, C option molality, while D option is going to be molarity. Students, kindly focus on your questions. Again and again I am repeating you one or the same things. You all are chatting and this is really very bad. Really very bad. This is your marathon series and you should be very serious with regard to your questions over here. These all questions are previous year and you should practice how you will become this doctor, what are your aim, how your aim will be fulfilled if you are not focusing on the lectures. Please focus on your lectures. Okay, now coming back to the question, the concentration units independent of temperature will be what? Now understand, there are two kinds of concentration units, or I would say there are two kinds of concentration terms. One of them are the ones that are, mass dependent. That are what? Mass dependent. And another ones are those that are volume dependent. Now let me tell you, the volume dependent concentration terms are basically those that will depend upon temperature, and mass dependent will be the one that won't depend on temperature. Okay, so I will say this is temperature dependent and mass dependent are temperature independent terms. Temperature independent terms, right? Right, now see over here, if I talk about normality, normality is number of moles of solute by volume of solution. Now if I am talking about volume of solution, that means this is a temperature dependent term. Now weight volume percent, it will convert, it will have weight with it and volume also with it, that means it is also volume dependent, that means temperature dependent. If I talk about molality, molality is number of moles divided by mass of solvent, both are mass terms, that means it is temperature independent. It is temperature independent. So option number C is going to be your correct answer for this particular question. Clear, my dear students? Is it clear to everybody? Clear, everyone? Okay. Shall we proceed to the next question if it is done? Everybody, shall we proceed to the next question if it is done? Okay. Now the one that are asking their number in the comment section, I am going to, get you rid of this comment section over here. I will put a timer for you if you stop this. Please kindly stop this. Please focus on your questions. Now comes your question number 131. How many grams of CH3OH should be added to water to prepare 150 ml solution of 2 molar CH3OH? Okay, you have options over here. A is 9.6 into 10 raised to the power 3. B is 2.4 into 10 raised to the power 3. Okay, C is 9.6 and D is 2.4. Okay students, so over here they have told you that how many grams of this is required. That means they are asking you the given mass value. What they are asking you? Given mass. See over here. Now we know that molarity basically is number of moles of solute divided by volume of solution. Divided by volume of solution. If it is taken in ml, students, that means you have to divide it by what? You have to divide it by 1000. Yes, everybody? So what is molarity over here? Molarity is 2 molar. Now what is number of moles? Number of moles is given mass upon molecular mass. Yes, everybody? So given mass we have to calculate for our solute. What is the molecular mass, ma'am? Molecular mass can we calculate for CH3OH? Yes. For CH3OH, how many carbon? 1. So 1 into carbon mass. How many hydrogen? Total 4. 4 into hydrogen mass. How many oxygen? 1. 1 into oxygen mass. So carbon mass is going to be what? 12. Hydrogen mass is 1 and oxygen mass is how much? 16. So it is 12 plus 4 plus 16 over here. That is going to be 16 plus 16, that is 32. Clear everybody? That is going to be your 32. Clear everyone? Clear everyone? Yes? Okay. Now volume over here is given to you as 150 in ml. So you will divide it. Now cross multiply it. 2 into 32 into 15 by 100. Now on the table of 5, on the table of 2, 250 is 100. On the table of 5, 96 by 10, that means 9.6. 9.6. That means option number, ma'am, C is going to be our correct answer. Option number, ma'am, C is going to be our correct answer. Clear everyone? Is it clear to everyone? Yes, everybody. Kindly take a screenshot of this question so that now we can proceed to the next question of ours. Kindly take a screenshot of this so that we can proceed to the next question now. Okay. Okay, now comes your question number 132. Question number 132. Question is, P and PB are the vapor pressures of pure liquid components A and B respectively, okay, of an ideal binary solution. If XA represents the mole fraction of component A, okay, the total pressure of the solution will be what? The total pressure will be what? Now see students, over here, we know that total pressure, students, is equivalent to the sum of pressure of A and pressure of B. Now pressure of A and pressure of B, this is, you know, PA, PB are not the pure pressure, this is the general formula. What actually is the formula? It is P naught A into XA plus P naught B into XB. Here P naught A and P naught B are referred to as the pure vapor pressure. According to the question, now let us talk about according to the question. The pure vapor pressure are represented by P and PB. So we have to replace it by P and PB. As per the question, they have written that P naught A is equal to P and P naught B is equal to PB. As per the question, this is how they have represented. Now what do you know that? Do you know that mole fraction of A plus mole fraction of B is equivalent to 1? What will be mole fraction of B? It will be 1 minus mole fraction of A. Now let us equate it over here. What we will get? We will get, ma'am, PA into mole fraction of A plus PB into, now we can write 1 minus mole fraction of A. What we will get? We will get PA mole fraction of A plus PB minus PB mole fraction of A. So what you can write is PB plus, let us take mole fraction of A as common, PA minus PB. Clear? This is going to be our total pressure formula, right? Okay, Shivanshu has answered D. Yes, exactly, Shivanshu. Answer is going to be option number D. Answer is going to be your option number D. Exactly. Answer will come out to be option number D. Clear? So shall we move on to the next question? Take a screenshot of this question, students. Shall we start now? Okay, now comes your next question. Question number 133. Question is, a solution has a 1:4 mole ratio of pentane to hexane. The vapor pressure of the pure hydrocarbons at 20 degrees Celsius and 440 mmHg for pentane and 120 mmHg for hexane. The mole fraction of pentane in the vapor phase would be what? Students, giving you 2 minutes in order to think about it, and then we are going to do this. So shall we do? See, the molecular formula for hydrocarbon for alkane is CnH2n plus 2. If it is pentane, 5 carbon, that means C5H12. Okay, and if it is hexane, then it is C6H14. Right? Right? Now they have given you a ratio of pentane, that is C5H12 by C6H14 as how much? As 1:4. That means if I talk about how this ratio would have come, the total value is 1 plus 4 is 5. That means if I talk about the fraction of C5H12 is 1 by 5 basically. And if I talk about C6H14, its ratio will be 4 by 5. Right? Its ratio will be how much? 4 by 5, because the total is 5. The total is 5. 1 by 1 plus 4. The total is 5. Clear everyone? Yes everyone. So now we will calculate. Now we will calculate the total pressure. The total pressure is equivalent to what? Mole fraction of C5H12 into the pure pressure of C5H12 plus mole fraction of C6H14 into the pure pressure of C6H14. Now what is mole fraction of this? Mole fraction of this is 1 by 4 into pure pressure for pentane. In the pure pressure is 440 plus this is 4 by 5 into what's the pure pressure? 120. So this will be 110. This goes on the table of 5, that is 24. Now this is 110 plus 96. This is 206. So the total pressure came out to be how much, ma'am? 206. Total pressure came out to be how much, ma'am? 206. Let us cross check once. Yes, 440 mm pressure, 1 by 4 into 440. Sorry, here I have by chance written 1 by 4. Here 1 by 5 will come. Here it is 1 by 5, no? So this will go on the table of 5. That is 88. That is how much? 88. So this will come out as 88 plus 96. That is 184. Clear everyone? Clear everyone? Already, wow, already you all have answered the question, but yes, I will explain you one by one, step by step. Yes, everybody. Now what we have to calculate over here? Now we will calculate the mole fraction of pentane in its vapor phase. So in its vapor phase, what is going to be the what is going to be the pressure of C5H12? Now it is going to be 88. So 88 is equivalent to mole fraction is 1 by 5. Sorry, 88 is equivalent to total pressure is 184 into mole fraction for C5H12 we have to calculate. So mole fraction for C5H12 will be what? 88 divided by 184. This will come out to be how much? 44 by 92, 22 by 46, 11 by 23. It will come out to be how much? 11 by 23. It will come by how much, ma'am? 11 by 23. That means when you're going to solve it, your answer will be approximately 0.478. Option number D. Clear everyone? With the help of this, you calculated the total pressure and then you calculated the mole fraction. Clear everybody? Take a screenshot of this, students, so that we can now move on to the next question. Take a screenshot of this so that we can move on to the next question if it is done. Kindly take a screenshot of this. Yes, students. Okay, now comes your question number 134. Question number 134 basically is, for an ideal solution, the correct option is. For an ideal solution, the correct option is A option, delta G mixing is equals to 0 at constant temperature and pressure. B option is delta S mixing is equals to 0 at constant temperature and pressure. C option is delta V mixing is not equal to 0 at constant temperature and pressure. While D option is delta H mixing is equals to 0 at constant temperature and pressure. So students, what do you think? What happens in the case of ideal solution? Which is the correct option over here? Ma'am, the correct option is that delta H mixing is equal to 0 at constant temperature and pressure. Yes, everybody. Yes, everybody. Ma'am, you are looking similar as like Rashmika or our South actress. Thank you. Okay, clear everybody? Ram Ramji, madam. Ram Ramji. So students over here, the answer will come out to be option number D. Answer will come out to be option number D. Delta G is not equal to 0 first of all. Delta S is more than 0. Delta V is 0 but it is written not 0. So option number D is going to be your correct answer. Clear everybody? Clear? Shall we move on to the next question? Shall we move on to our next question? Come on students. Okay, now comes your question number 135. Question is basically the mixture that forms maximum boiling azeotrope is. The mixture that forms maximum boiling azeotrope is A. Heptane plus octane, B. Water plus nitric acid, C. Ethanol plus water, while D is acetone plus carbon disulfide. Tell me fast students, what do you feel which is the right answer? Let me tell you, the maximum boiling azeotrope is shown by the one that shows a negative deviation and minimum will be shown by the one that shows positive deviation. So this will be shown by the one that shows negative deviation. Now as per the options over here, the most famous common example for the negative deviation is water plus nitric acid. Is which one? Water plus nitric acid. Yes everyone? So over here option B is going to be our correct answer. Clear everyone? Clear everyone? Is it clear? Shall we move on to the next question students? Please show me some energy. What happened? It's a NEET examination. Finally your the hard work of complete year will come to an end after attempting this exam. So show me the spirit that yes ma'am, we have done a lot of hard work and we are going to do our best. Don't worry. But you are so dull, you are not responding at all. What happened to you? See, the students that are continuously, writing the answers, I would say very, very good. I'm so proud of you. For example, Rams is writing, Spy Thunder is writing, Sneha is writing, Pooja went in between, I don't know where, but she was also writing. So many students were there who were continuously writing. So I would say very, very good that you are continuously doing that. Keep it up. Yes, but show me your spirit that yes, ma'am. Why are you so dull? I just spoke in the, some few hours back also that you all are my shimmering stars and stars always shine. So I want to see your shyness. I don't want to see your dullness, okay? I don't want to see your dullness. Yes, that's great. Okay. Shall we see the next question now, ma'am? Next question is 136th question. This is your question number 136. Which is the question? Let us read it. Which of the following statements is correct regarding a solution of two components A and B exhibiting positive deviation from ideal behavior? Right? A option is intermolecular attractive forces between AA, BB are stronger than those between AB. B option over here is delta H mixing is equals to 0 at constant temperature and pressure. C option is delta V mixing is equals to 0 at constant temperature and pressure, while D is intermolecular attractive forces between AA and BB are equal to those between AB. Ma'am, I don't understand Hindi language. No need to worry. I'm not speaking Hindi at all. I'm speaking continuously English. No need to worry. Okay. Answer me fast students. What do you feel? Which of the following is going to be our correct answer for this particular question? So see over here, we have to tell about positive deviation, right? If I talk that intermolecular attractive forces are equal, that means that is an ideal behavior. But a positive deviation and a negative deviation refers to as a non-ideal behavior. So yes, option number D is incorrect. And these are also incorrect because all of these basically are for ideal one. Only the one, option number A is going to be the correct one for the case of positive deviation. That means intermolecular attractive forces between AA and BB are stronger than that of between AB. Clear? Rest B, C and D option represents for your non-ideal behavior for your positive deviation. Oh, sorry. Rest all other represents for ideal and this represents for your non-ideal behavior, that is positive deviation. Clear? Okay. Great. Now let us see the next question. Now comes question number 137th. Which condition is not satisfied by an ideal solution? Which condition is not satisfied by an ideal solution? A. Delta V mixing is equals to 0. B. Delta S mixing is equals to 0. C. Obeying to Raoult's law, while D. Delta H mixing is equals to 0. So what do you feel, students? Which of the condition is not satisfied by ideal solution, ma'am? See, in ideal solution basically we say that delta H mixing is equal to 0. Delta V mixing is equal to 0. This is what is about an ideal solution, right? So delta V mixing is equal to 0. This is satisfied. Delta S is equal to 0. This is not satisfied. Delta S basically is more than 0. Obeying to Raoult's law, this is satisfied. This is satisfied. But option number B, students, is going to be your incorrect one. Answer is going to be option number B. Yes, clear everyone? Clear everyone? Shall I proceed to the next question if it is done, everybody? Shall I proceed to the next question if it is done? Okay. Now comes question number 138. Question is, a solution containing components A and B follows Raoult's law. A and B follows Raoult's law. A, AB attractive forces is greater than AA and BB. B option is AB attractive forces is less than AA and BB. C is AB attraction forces remain same as AA and BB, while D is volume of solution is different from sum of volume of solute and solvent. So students, what do you feel? Which of the following is the correct one? We have to tell that which follows Raoult's law. Now the one that follows Raoult's law is the one that is basically an ideal solution. Now in the case of ideal solution, students, what happens? The interactive forces between AA, BB and AB are equal. So AB attraction is greater? No. It is less? No. It remains the same. This is what happens in the case of ideal solution. That means option number C is going to be your correct answer. Option number C is going to be your correct answer. Clear? Let us see your question number 139 now. Question number 139 is, all form ideal solution except. All form ideal solution except. Janvi Atri saying, ma'am, volatile का मतलब क्या होता है? Volatile refers to as something that will exert pressure. Non-volatile is something that won't exert any kind of pressure. Volatile means to exert pressure. Got it? Got it? Clear everyone? So now just let me tell, all form ideal solution except. All form ideal solution except. You have been provided with 4 options over here which will form ideal solution except. Very good, Rajat Verma and Shivanshu. Yes, Shivanshu name was, okay, I got missed Shivanshu name. Shivanshu is also the one that is, answering from the very starting. Very good, very good. Rajat Verma, D. Janvi Atri, okay ma'am, okay. Ram again has said D. Yes, D is going to be the one that is not going to be forming an ideal solution. Why? Because they are dissimilar liquids. They are the dissimilar liquids. So option number D, students, is going to be your correct answer for this particular question. Now comes your next question, students. That is your question number 140. Your question number 140. An ideal solution is formed when its components. Number first, an ideal solution is formed when its components A. have no volume change on mixing. B. have no enthalpy change on mixing. C. have both the above characteristics. D. have high solubility. Have high solubility. So what do you feel? Now this question we have done again and again. I don't feel anyone would say that this is wrong. Sergi, yeah, Sergi was also the one that was, answering right from the starting. So yes, as I was saying, there are few students that were answering from the very start and are still here. I'm so proud of you people, and I wish you all the very best for your exams. Right? Okay, see over here, they will have both the above characteristics, because here delta V mixing is also 0 and delta H mixing is also 0. In which case, ma'am? In the case of ideal solution. In which case, ma'am? In the case of ideal solution. So option number C, my dear students, is going to be your correct answer for this particular question. Yes, everyone? Clear, everyone? Okay, shall we move on to the next question of ours if it is done? Now here comes your question number 141. Now your question 141 comes. The following solutions were prepared by dissolving 10 grams of glucose. Okay, now this is very simple question. So this is a homework. You have to try by your own. I'll read the question. I'll give you a hint in this question. Okay. Question is, the question for your homework from this chapter is question 141. Question is, the following solutions were prepared by dissolving 10 grams of glucose into 50 ml of water, 10 gram of urea into 50 ml of water, and 10 gram of sucrose into 50 ml of water. The right option for the decreasing order of osmotic pressure of these will be. Now, Rajat Verma, NEET previous year question. Yes, it is a NEET previous year question. Though we are doing previous year questions only, and we are also practicing some main important questions. So you can take a screenshot of this particular question. Shall we start with the next question of ours? Spy Thunder has already answered the question. Okay. So now let us move on to the next question, that is question number 142. Let us see question number 142. Question is, the freezing point depression constant, that is Kf, of benzene is 5.12 Kelvin kg per mole. The freezing point depression for the solution of molality 0.078 molal containing a non-electrolyte solute in benzene is what? You have to round off up to 2 decimal places. Your answer, you have to round up to 2 decimal places. Now I am giving you 2 minutes in order to think. Very simple, direct formula based question based upon the colligative properties. What were the colligative properties? There are 4 colligative properties: relative lowering in vapor pressure, elevation in boiling point, depression of freezing point, and osmotic pressure. Do cover these 4 topics. They are very important with regard to the chapter solution. With regard to the chapter solution, they are very important, right? Okay. So shall we do this? See now, the value for Kf they have given you. Kf value is 5.12. What else, ma'am, they have given you? Molality they have given you. Molality is 0.078, and they are asking you the freezing point depression for the solution. That means they are asking you delta Tf. It is equivalent to Kf into molality. What is Kf? Kf is 5.12 into what is molality? 0.078. So let us multiply this. What we will get? We will 512 into 78. Thus we got as our answer as 39936 divided by 1250 zeros. That is 0.39936. That I can say is 0.4. We have to calculate up to 2 decimal places. So that means the answer is going to be 0.40. Answer is going to be 0.40 Kelvin. Option number C is going to be your correct answer. Yes, Pooja, Spy Thunder, HMG, Rajat Verma saying number of solute पर depend करती है ना? Yes, exactly. Colligative property depends upon number of solute particles. Clear? Shall we move on to the next question? Kindly write it down once so that we can now move on to the next question of ours. Now comes your next question, question number 143. Question 143 is molality of, if molality of the dilute solution is doubled, if molality of the dilute Spy Thunder, okay, K should be capital, Spy Thunder K should be capital, okay. Now, if molality of the dilute solution is doubled, the value of molar depression constant will be, the value of molar depression constant will be what? Now see, let me tell you, See, molar depression constant is always constant. It won't depend on anything. It is already constant. So it will remain unchanged. It will remain unchanged. Answer will be option number C. It is a constant. How it can change? It is a constant. So option C is going to be the correct part. Option C is going to be your correct one. Clear everybody? Clear everyone? Shall we move on to the next question if it is done? Shall we move on to the next question if it is done, everybody? Now comes your question number 144. Question is, at 100 degrees Celsius, the vapor pressure of a solution of 6.5 grams of a solute in 100 gram water is 732 mm. If Kb is 0.52, the boiling point of the solution will be what? It will be what? Students, giving you 2 minutes in order to solve this question out. Now see, here we don't know about solute and they're asking boiling point, and for that we need to calculate number of moles. So first of all, what we will do, we know that P naught minus PS divided by P naught is equivalent to the mole fraction of solute. Yes, we know this formula, that is relative lowering of vapor pressure. That is relative lowering of vapor pressure, right everybody? Now see, P naught is for the pure one, that we know is 760 mm, minus what do we have, 732 given, divided by P naught initially is 760. Now number of, what is mole fraction? This is mole fraction of solute, so it is going to be number of moles of solute by total moles. Number of moles of solute divided by total moles, that is of A plus B. That is of A plus B. Agreed. Now A value is very less than B value, so what we can directly write it as number of moles of B by number of moles of A. Yes everyone, number of moles of B by number of moles of A. Now what is number of moles of A? We can write the number of moles of B, we have given mass 6.5, molecular mass we don't know, divided by number of moles of A, given mass is 100, molecular mass for water is 18. So what we will get over here, 760 minus 732 by 760 is equal to 6.5 by molecular mass into 100 into 18. So this we are going to solve 8, 28 divided by 760 is equivalent to 65 by 10 into 100 into molecular mass into 18, right? Now on the table of 5, if I divide, it will go on 2, it will go on 13, it will go as 9. So what we will get over here? What is going to be molecular mass? Molecular mass will be 13 into 9 by 100 into 28 into 760. 0, 0 will get cancelled. On the table of 2, it will go as 14 and it will go as 38. Again on the table of 2, it will go as 7, it will go as 19. So now we are going to multiply 13 into 9 into 19 divided by 7. Yes everybody, divided by 7. Yes everyone. Yes everyone. When you are going to calculate it, students, one more thing you can do is calculate number of moles. Why? Because again we are going to write molecular mass. Why? Because again you are going to write molecular mass. See, what you can do is, from here no need to write the value of molecular the given mass also. Just calculate number of moles. You can write N divided by 100 into 18. Now what is number of moles of solute? It is 28 by 760 into 100 by 18. 0, 0 gets cancelled. Now if I divide on the table of 2, it is 38 and this is 14. Now again 7, it is going to be 19. Now this 9 and this is going to be 5. So this is 7 into 5 by 9 into 19. Clear? When you are going to solve it, when you are going to calculate that, let me tell you the answer after calculating. Students, it will come out to be 0.2046. How much? 0.2046. This is the value of number of moles. Now let us come back to the question of the boiling point. See, we know that delta TB is equivalent to Kb into molality. Now Kb, what is Kb over here? Ma'am, Kb over here as per the question is 0.52. What is molarity? Number of moles. What is number of moles? It is 0.2046 divided by mass of solvent. Now mass of solvent, what is solvent over here? What is mass of, yes, atmospheric pressure. Yes, I have taken 760 as atmospheric pressure. Clear? I have taken 760 as the atmospheric pressure, 1 atm. Clear? Right? By what you are going to take? By you are going to take mass of solvent. Now mass of solvent is 100 grams. What is mass of solvent, ma'am? Mass of solvent is 100 grams. If you are taking in kg, then you will use 1000 over here. Now basically students, understand, this is your delta. This is your delta TB. You have to calculate the boiling point of the solution. What is the formula of delta TB? Anybody? What is the formula, ma'am? TB minus TB naught. And TB naught value is given to you as 100. TB naught value is given to you as 100 as per the question. See over there. Yes? Yes, everybody? So when you're going to calculate it, it will come out to be 1.06 and this is TB minus 100. So TB will come out to be 100 plus 1.06 and that means 101.06 is going to be the answer. That means option number C is going to be our correct answer for this particular question. Clear? Clear, everybody? Great. Take a screenshot of this question so that we can start with the next question of ours. Done, everyone? Okay, let us do the next question now. Okay, next question is question 145. 200 ml of an aqueous solution of a protein contains its 1.26 grams. The osmotic pressure of the solution at 300 Kelvin is found to be 2.57 into 10 raised to the power minus 3 bar. The molar mass of protein will be. Now osmotic pressure formula you all know. Pi V is equivalent to nRT, right? Such as PV is equals to nRT. So pi V is equal to what is N, given mass upon molecular mass, into R into T, right? Now if I see the value of osmotic pressure, the value of osmotic pressure is found to be 2.57 into 10 raised to the power minus 3 into what is volume given to in question, 200 ml. Is equivalent to what? Is equivalent to what else they have given you? Given mass by molecular mass. Given mass is, it contains 1.26. Molecular mass you need to calculate. What is the value of R? It is 0.083. And what is the value of temperature? That is 300 Kelvin. That is what? That is 300 Kelvin. Direct formula based question. Direct formula based question it is. Yes, students, it is direct formula based. Clear? It is direct formula based. One more thing, students, over here it is given you 200 ml. So you have to take it in liters. So you have to divide it by 1000 also. Clear, everyone? So you have to divide it by 1000 also. Now students, when you are going to cross multiply, what you will get your answer over here as? You will get your answer as 61038. 61038. Clear? After solving, you will get option number D as your correct answer. After solving, you will get option number D as your correct answer. Clear, everyone? Is it clear to everybody? Is it clear to everyone? Is it clear to everyone? Okay, kindly take a screenshot of this question as well so that we can move on to the next question of ours. Okay, now comes the next question, question 146. Question is, a solution of sucrose whose molar mass is 342 gram per mole has been prepared by dissolving 68.5 gram of sucrose in 1000 gram of water. The freezing point of the solution obtained will be what? Now you have to calculate the freezing point of the solution. The freezing point of the solution, that means the value of TF. So I am giving you, formula over here. Let us calculate it. Ma'am, we know that delta TF is equivalent to KF into molality. First of all, calculate delta TF. What is KF in the question, ma'am? KF in the question is 1.86. What is molality? Given mass upon molecular mass, that is number of moles of solute by mass of solvent in kg. What is given mass, ma'am? Given mass is given as 68.5. By molecular mass is 342. Into what is the mass of the given substance in kg? It is 1000 grams. How much, ma'am? 1000. So, you'll divide it by 1000 again. In kg, you need to calculate it, right? So, now this is what? This is your answer that came out to be for delta TF. This came out for delta TF. But they are asking you what? They are asking you for the solution. Now, TF is equivalent to what? When you will calculate it, it will come out to be 0.372. 0.372. 0.372. They are asking you the freezing point of the solution. What they are asking you? The freezing point of the solution. That means the value of TF. So, the value of TF will be what? It will be 0 minus delta TF, because T naught F is 0 degree. So, it is 0 minus 0.372. That means it is minus 0.372. Answer come out to be negative of minus 0.372. Clear everybody? Clear everybody? Ma'am, for this some question type of question, we can take 760 mm. Yes, if the pressure is taken as 750, you have to see the units, 760 mm or 180 mm. It depends upon the units that you are taking. Clear? Kindly take a screenshot. Now we can move on to the question number 147. Question 147 is in front of you. During osmosis, flow of water through a semi-permeable membrane is. During osmosis, flow of water through a semi-permeable membrane is A. From solution having lower concentration only. B. From solution having higher concentration only. C. From both the sides of semi-permeable membrane with equal flow rates. While D. From both the sides of semi-permeable membrane with unequal flow rates. So students, tell me about osmosis over here in this theoretical question. Flow of water. Flow of water will occur from where? Now, water is a solvent. Water is a solvent. Solvent will move from low concentration to high concentration. So, it will move from a solution having lower concentration only. Solvent particles will move from that. That means option number A over here is your right answer. Clear everyone? Clear everyone? We are talking about solvent. Yes, Vaibhav, A is right one. It's okay, it's okay. Clear? Let us see your next question, question 148. Let us see question 148. Question 148 is, if 0.15 gram of solute, now this is your homework question for this chapter. Everybody write down a homework question for this chapter. If 0.15 grams of a solute dissolved in 15 grams of solvent is boiled at a temperature higher by 0.216 degrees Celsius than that of pure solvent, the molecular weight of the substance, that means its molar elevation constant is given to you, will be what? A is 10.1, B is 100, C is 1.01 and D is 1000. Take a screenshot of this homework question. Done everyone? Now let us see question number 149. Question 149 is, a 5% solution of cane sugar is isotonic with a 5% solution of cane sugar is isotonic with 1% solution of substance X. The molecular weight of X is going to be what? The molecular weight of X is going to be what? Now tell me fast, students. See, if I am saying isotonic, that means they are going to have same osmotic pressure. That means it is going to have same osmotic pressure. What it is going to have, ma'am? Same osmotic pressure. So when I am talking in terms of same osmotic pressure, that means pi 1 is equivalent to pi 2. Yes, my dear students, and what is pi? We know that pi v is equals to nRT. And pi is equals to n by v RT. What is n by v? Concentration. and R and T are constant, that means pi is equals to C. So I will say C1 is equivalent to C2, right? That means number of moles of 1 by volume of 1 is equivalent to number of moles of 2 by volume of 2. Now when we are saying we are talking about a solution which is isotonic, the volume will be same. So number of moles of 1 is equivalent to number of moles of second. Now what is given mass for first? 5%. What do you refer to as 5%? 5% is 5 grams by molecular mass is 342 is equivalent to given mass 1%, that means 1 gram by molecular mass you have to calculate it. So what is molecular mass? Molecular mass will be 342 by 5. That means 630 and then 4, 42, 8. 68.4. 68.4 is going to be our correct answer. 68.4 is going to be our correct answer for this particular question. Clear everybody? Clear everyone? Now comes your question number 150. Question 150 is, which one is a colligative property? Question 150 is, which one is a colligative property? A, boiling point, B, vapor pressure, C, osmotic pressure, D, freezing point. Which one is a colligative property? Boiling point, vapor pressure, osmotic pressure, freezing point. Anybody? Okay, Vaibhav is saying and Harsh Vardini is saying C. Zainab is saying C. Exactly. C is the correct answer. Yaku, it is not. See, elevation in boiling point is a colligative, not boiling point. Relative lowering of vapor pressure is a boiling property, not vapor pressure. Osmotic pressure is a colligative property, not this. And depression in freezing point is a colligative property, not freezing point. So option number C, my dear students, is going to be your correct answer for this particular question. Clear everybody? Clear? So now students, we will end our this chapter question over here only, and we shall start with our next chapter's question. We end our this chapter's question over here only, and now we are going to start with the next chapter question. Now we are going to start with next chapter question. We have completed your solution chapter questions also over here. Okay, now students, comes your equilibrium part 2. Now we are going to do equilibrium part 2. Clear? Now we are going to do equilibrium part 2. Shall we start? Okay, everybody, are you ready? Shall we start with equilibrium part 2? Yes. Everybody? Please let me know in the comment section. Yes, students. Okay, now let us start with your question. Now this is your question number. This is your question number 151. Question is, if K1 and K2 are the respective equilibrium constant for the two reactions, if K1 and K2 are the respective equilibrium constant for two reactions, XeF6 plus H2 gives XeOF4 plus 2HF, and this reaction, the equilibrium constant for this reaction is going to be what? The equilibrium constant for this reaction is going to be what? Now see students. See, we want XeO4. We want XeO4. Where is XeO4 in the particular reaction? We want XeO4 and we want HF, and Xe3OF2 is being formed. See, we are going to use this reaction. We want this reaction over here with us. Let me check your reactions first. Please give me a minute. I'm going to dictate. Everybody, please kindly match it. Here XC, okay, kindly correct it. Here X, this is wrong. Let me tell you, the question is printed wrong. Please give me a minute. Okay, please give me a minute. The question is written wrong, so I'll correct it. XeF6 plus water gives XeOF4 plus 2HF. Then XeO4 will come here. XeO4 will come, okay, plus XeF6 give XeOF4 plus XeO3 F2. Then XeO4 plus, okay, now it's correct. Now it's correct. Now solve the question. Kindly correct it. There is a mistake over here. Vaibhav is saying, I haven't studied this yet. No issue, Vaibhav. I'm going to tell you how to solve this question. Just look over here. See. See over here. See, we want XeF4 in the reactant site. It is given in the reactant site. Yes? Yes. What else do we require over here? We don't want XeF6 over here. But here we have XeF6. So what we are going to do with these two equations over here, we are going to, let us say this is your first equation, let us say this is your second equation. So subtract your, first and second equation. How you are going to calculate, or just add these equations. See what you are going to get over here. When you are going to subtract both of these equations, you are going to get your answers over here. Okay. So what you can do is, see, you have to take this situation as it is. The equilibrium constant for this is K2. You have to take this as it is. The equilibrium constant is going to be K2. Okay. Now next thing what you require is, see, if you are going to reverse this reaction, let us reverse this reaction. Why? Because we want HF in the reactant side. Here HF is in the reactant side. So when we are reversing this equation, its value will become 1 by K1 and it is K2. So K2 into 1 by K1. K2 into 1 by K1, this comes out to be K2 by K1. That means option number D is the right answer. K2 by K1. Clear everyone? K2 by K1. Option will be, answer will be option number D. Clear everybody? Answer will be option number D. Clear everyone? Shall we move on? Yes, yes, Ram. Answer is going to be D. Let us see the next question. Question 152. Question 152. The equilibrium constant for the reaction N2 plus 3H2 gives 2NH3 is K. Then the equilibrium constant for the equilibrium 2NH3 gives N2 plus 3H2 will be what? Now see, if you see both of these reactions, Harshvardhan, now see over here, Harshvardhani, sorry, see over here, this reaction and this reaction, what is the difference between both of them? You have to just reverse the reaction. When you have to reverse the reaction, why we are reversing? Because here it is 2NH3 in the product, but here it is in the reactant. So when you will reverse this, reaction will become same. When you will reverse it, okay? When you are going to reverse it, K will become 1 by K. Whenever you reverse any of the reaction, it will become 1 upon something. So 1 by K is going to be the right answer. Answer is going to be option number C. Clear everybody? Clear everyone? Yes, Young, 1 by K. Yes, Ram, 1 by K. Yes, STB, 1 by K. Clear? Okay, let us see 153rd question, 153. K1 and K2 are the equilibrium constant for the reaction 1 and 2 respectively. You have to find a relationship between both of them. See, if I see the very first and the second reaction, initially I have reversed it. So that means it will become 1 by K1. Next, I have multiplied it with 1 by 2. When I will multiply with 1 by 2, the power will become 1 by 2. So K2 will be equivalent to 1 by K1 power 1 by 2. Yes? Yes. Now in terms of K1, what it will be? It will be K2 whole square is equivalent to 1 by K1. What will be K1? K1 will be 1 by K2 whole square. That means option number first is the right answer. Option number A is the right answer. Clear everyone? Ma'am, what about the reactant side? Which side? When you will get converted it will convert into NO. You want NO, so you will multiply it by 1 by 2. So 2 will get cancelled. Clear? Clear, Sergi? So option number A is the right answer for this question. How come B and D? How come B and D? How come B and D? Ma'am, ek motivation please. Mohammed Sharik. Okay, I'll sing a song for you people, but first of all complete this. First of all complete this. Then I'll sing a song for you all, okay? Shall we move on to our next question, everyone? Shall we move on to the next question? Now comes question number 154. Question number 154. Okay, question number 154. So your question is, the reaction 2A plus B gives 3C plus D. 2A plus B gives 3C plus D. Yes. Now what we have is, begin with the concentration of A and B both at the initial value of 1 molar. When equilibrium is reached, the concentration of D is measured and found to be 0.25 molar. The value for the equilibrium constant for the reaction is given by the expression, right? Tell fast. Tell fast. See, basically our reaction is 2A plus B gives 3C plus D, right? They are saying is, begin with the concentration of A and B both at 1 molar. Now when equilibrium is reached, the D is measured and found to be 0.25. So if it is 1 this is 0 it will be 1 minus 2x, it will be 1 minus x, it will be 3x, and it will be x, right? So if x is 0.25, what will be C? C is 3x, that means 3 into 0.25, that means 0.75. It will be 1 minus x, that means 1 minus 0.25, that means 0.75. It is 1 minus 2x, that means 1 minus 2 into 0.25, that means 1 minus 5, that means 1 minus 0.50, that means 0.50. Clear? Clear. Now see what we have to write. We have to write the value for the equilibrium constant. The equilibrium constant. Equilibrium constant over here will be C whole cube into D concentration divided by A square into B. Here 3 is written, so power will be 3. Here 2 is written, so power will be 2. So what is C square? What is C? C is 0.75. 0.75 cube. 0.75 cube, 0.75 cube, 75 cube into D. What is D? D is 0.25. D is 0.25, 25, 25, 25. Now here divide will come, students. This is divide. This is divide. Divided by A square. What is A? A is 0.50. 0.50, 0.50 into what is B? B is 0.75. B is 0.75. So option number B, students, is going to be your right answer. Option number B is going to be your right answer. Clear? Clear? Mohammed is saying बहुत tricky लग रहा है. कुछ tricky नहीं है. Basically, students, in this particular question, you have to just write the formula. You don't have to solve it. What is Kc? The concentration of a product by a reactant. So product is C, power will be this 3 into product is D divided by A. Concentration power will be 2, B concentration. Rest you just have to write the values, that's it. Kindly write it down, students. Till you feel like if you are not able to solve this question, you can tell me, we'll do it again. Yes, students. Clear, everyone? Shall we move on to the next one? Shall we move on to the next question? Great. Now comes your question number 155. Question 155. In which of the following equilibrium Kc and Kp are not equal? Kc and Kp are not equal. In which of the following Kc and Kp are not equal? Yes, everyone. See, Kp is equivalent to Kc into RT power delta Ng. This is what is the formula. This is what is the formula, everybody. Okay. Now see. Here what is delta Ng for the reactions we are going to calculate. Now see. Here delta Ng is number of moles of product minus number of moles of reactant. Here this is product, this is product. Gaseous. G stands for only gaseous. G stands for only gaseous. So 2 plus 1 is 3 minus 2 is 1. Delta Ng is 1. If delta Ng is 1, Kp is equal to what? Kp will be equivalent to Kc into RT. So in this case, it is not equal, so option number A is the right answer. We have got our answer as option number A. We have got as answer as option number A only. Direct answer option number A. Yes, students, answer is going to be option number A. Okay, now comes your question 156. Question is, if the concentration of OH negative ion in the reaction is decreased by 1/4 times. If it is decreased by 1/4 times, then equilibrium concentration of Fe plus 3 will increase by, now see students, the reaction is, this is aqueous. Now see, basically we know that Kc students is equivalent to Fe plus 3 and OH negative ion raised to the power 3. This is solid form, so this won't be taken. We'll only take product, right? 3 will become its power. Now they are saying, if the concentration of OH negative is decreased by 1/4 time, new Kc dash will be what? Fe plus 3 decreased by 1/4, 1/4 OH negative raised to the power 3. Now 1/4 into 1/4 into 1/4 is 1/64 into Fe plus 3 into OH negative raised to the power 3. This whole is Kc. So what is Kc dash? Kc dash is 1/64 of Kc. Right? That means the equilibrium constant of Fe plus 3 will increase by, if you want to make it equal, you will increase it by 64. You will increase it by 64 times. So option number A is going to be your right answer. Option number A will be your right answer. Clear everyone? Clear everyone? Yes, everybody. Is it clear to everyone? Shall we move on to the next question, students? Shall we move on to the next question? Okay, now comes your question 157. Question 157. Question is, equilibrium constant Kp for the following reaction is. Equilibrium constant Kp for the following reaction will be. Now Kp is in the terms of pressure. Will be what? Now see. For solid you will not be writing, not for solid. So Kp will be equivalent to the pressure of product CO2, because it is gaseous. Solid you won't write. Divide by, for reactant is solid, you won't write. So Kp is equal to pressure of CO2. That means option number A is the right answer. That means option number A is the right answer. Direct question. Easiest question. Option number A is the right answer. Clear everybody? Okay, now comes the next question, question 158. Question 158 is, which of the following statement is correct for a reversible process in a state of equilibrium? Which of the following is the correct one for reversible process in the state of equilibrium? You have been given 4 options over here. First option is delta G naught is equals to minus 2.30 RT log K. B option is delta G naught is equals to 2.30 RT log K. C option is minus 2.30 RT log K, while D is delta G is equals to 2.30 RT log K. So what do you feel, students? Which of the following is going to be the correct answer for this particular question? What do you feel, students? Which of the following is going to be the correct answer for this particular question? Anybody? Harshvardhani saying A. Yes, exactly. Minus 2.303 RT log K is going to be the correct answer for this particular question. Yes, everybody. Shall we move on to the next part? I guess. Yeah. Delta G naught is equals to minus 2.303 log K is going to be the correct answer. Minus 2.303 RT log K is the right answer. Shall we move on to the next question if it is done, everybody? Okay, now comes question 159. Now comes your question number 159, students. Now comes your question 159. So basically, which one of the following conditions will forward maximum formation of the product in the reaction? A, low temperature and high pressure. B, low temperature and low pressure. C, high temperature and high pressure. D, high temperature and low pressure. So students, answer fast. We are going to complete our chemical equilibrium over here, and then we are going to start with ionic equilibrium. Yes, Harshvardhani, exactly right. Low temperature and high pressure. Low temperature and high pressure. So option number A is going to be your right answer. Now students, we are going to end with one more question for this particular chapter, that is 160th question. This is 160th question. Now this is for your homework. And now we are going to start with the next chapter of ours. You can take the screenshot of this. This is your homework question. 2 questions as a homework from this chapter. Question 160, everybody please take a screenshot. This is your homework question from your chemical equilibrium. From your chemical equilibrium. Now one more question as a homework. This is your question number 161. From your chemical equilibrium, this is one more homework question. For the following reaction, which of the following is not true? Clear? Now we are going to start with ionic equilibrium, everybody. We are going to start with ionic equilibrium, everybody, of your class 11th only. Okay, now comes your question number 162. That is your ionic equilibrium. That is your ionic equilibrium. We have covered with chemical equilibrium 2 parts, part 1 and part 2. Now we are starting with ionic equilibrium. Shall we start? Okay, so 162 question is aqueous solution of acidic acid contains. Aqueous solution of acidic acid contains A option CH3CO negative and H positive, B option CH3CO negative, H3O positive and CH3COH, C option CH3COO negative, H3O positive and H positive, while D is CH3COH, CH3CO negative and H positive. So yes students, which of the following do you feel is going to be the right answer for this particular question? A, B, D, creation is saying A, Safwan is saying C. Anyone else? Anyone else? Jia Agarwal is saying A. Okay. Now see students, let me tell you, when it is an aqueous solution of acidic acid, that means we are talking about CH3COOH. Okay, when you're talking in aqueous solution, that means in water, it will dissociate into CH3COO negative and H3O positive. Now see, it is not completely dissociated. Hence, you will be left with CH3CO negative, H3O positive and CH3COH. All of these three, because it is a weak electrolyte, not a strong one that it will get completely dissociated. So it will contain CH3COH, H3O positive and CH3CO negative. That means option number B over here is going to be your correct answer for this particular question. Option number B over here is going to be your correct answer for this particular question. Clear everybody? Kindly take a screenshot of this question. Now we shall move on to the 163 question. Let us see the 163 question. Now moving on to 163 question. We have conjugate base for Bronsted acid H2O and HFr. Conjugate base for Bronsted acid H2O and HFr. See, what are Bronsted acid? The one that is going to donate its H positive ion. So they are going to donate its H positive. What we will left with? OH negative, and here will be F negative. So basically the conjugate base for them will be OH negative and F negative respectively. That means, ma'am, option number D over here is going to be your correct answer for this particular question. Option number D will be your correct answer for this particular question. Clear, everybody? Yes, everyone. Is it clear to everyone? Shall we see the next question of ours if it is done? Great. Now comes your question number 164. Question is, which of these is least likely to act as a Lewis base? Which of these is least likely to act as Lewis base? A option is BF3, B is PF3, C is CO, and D is F negative. D is F negative. Yes, students, be fast. Anybody? Saurabh Paul is saying A, Harshvardhan is saying D, Kaveen is saying A, Ram is saying A. Students, A is going to be the correct answer. Why? Because it is a Lewis acid. It is a Lewis acid. That means it is electron acceptor. It is going to accept electron rather than donating. While other all can donate electrons. That means BF3 is a Lewis acid. Hence, we can say it is least likely to act as a Lewis base. So, option number A is going to be your correct answer for this particular question over here. Kindly write down the question so that, write down the answer so that we can move on to the next question of ours. Okay, shall we move on to the next question, everyone? Shall we move on? Okay. Now comes question number 165. Yeah. Question is, which of the strongest acid in the following? Which of them is the strongest acid among the following? A option is HClO4, B, I'm really sorry. Okay, A option is HClO4, B is H2SO3, C is H2SO4, while D is HClO3. D is HClO3. So what do you feel, students? Which of the following is the strongest acid? Let us calculate the oxidation state of chlorine in this one. Hydrogen is +1. Let us write the oxidation state for chlorine as X. For oxygen, it is -2 into 4 is equivalent to 0. 1 plus X minus 8 is equivalent to 0. X came out to be +7. So if I see in other options over here, and if I want to calculate, I am going to see chlorine has the highest oxidation number and is a conjugate base. Its conjugate base is resonance stabilized. That's why it is going to be the strongest acid. That's why it is going to be the strongest acid. So option number A is the right answer for this particular question. Clear? Let us see the next question if it is done. Take a screenshot of this, students. Question number 166. Question is, which of the following molecules act as Lewis acid? Which of the following molecules act as Lewis acid? A, CH3 twice O, B, CH3 thrice phosphorus, then nitrogen, then boron. Very simple. Boron, students, is electron deficient. It requires electron. It is electron acceptor basically. So basically, which of the following will act as Lewis acid? This will act as Lewis acid because it requires electrons. Hence, answer is going to be your option number D. Answer is going to be, yes, Kaveen, answer is going to be option number D for this particular question. Clear, everyone? Yaku, why B? Phosphorus to has a lone pair of electrons, so it can donate, no? It can donate. Shall we move on to the next one? Question number 167. Now, which one of the following statements is not true? Which one of the following statements is not true? A option. Among halides ion, iodide is the most powerful reducing agent. B option. Fluorine is the only halogen that does not show a variable oxidation state. C. HOCl is a stronger acid than HOBr, while D. HF is the strongest acid than HCl. Now let me tell you students, by looking at the question you can directly say that among halide ions, iodine is the most powerful. Yes, it is right. Fluorine is the only halogen that does not show variable oxidation state. Great. HOCl is stronger acid. Yes, it is also right. But HF is a stronger acid. This is wrong. HF basically shows hydrogen bonding, right? Due to which it won't let its hydrogen to go off. So if it is not letting its hydrogen to go off, it is a weaker acid than HCl. Okay. Now moving on to the next question. Question 168. The strongest conjugate base is? The strongest conjugate base is the one that will make its weak acid. The one that will make its weak acid. Strongest conjugate base is the one that will make its weak acid. Now you have to add hydrogen in them. It will make what? It will make you H2SO4. It will make HCl. It will make HNO3. And it will make CH3COOH. So among them weak acid is this one. That means option number D is the right answer. Option number D is the right answer. Right? The weak acid will form strong conjugate base. Okay, let us see the next question. Question 169. It is, which of the following is not a Lewis acid? Which of the following is not a Lewis acid? SiF4, C2H4, BF3, FeCl3. Which of the following is not a Lewis acid? Which of the following is not a Lewis acid? Students, C2H4 is not a Lewis acid. If you see other options over here, in BF3 it is empty, it is electron deficient species. Okay, if you see in SiF4 and if you see in FeCl3, one of them is electron deficient. Okay, empty vacant orbitals, it contains vacant orbitals in them. Central metal has empty d orbital in this case. It basically requires electrons, right? So C2H4 is not a Lewis acid. Option number B is going to be your correct answer for this particular question. Now comes your question number 170. Question number 170. Repeated use of which one of the following fertilizers would increase the acidity of the soil? A. Ammonium sulfate. B. Superphosphate of lime. C. Urea. D. Potassium nitrate. So what do you feel, students? Which of the following is going to be right one? Students, A is going to be the right one because it is made from strong acid and weak base. So answer is going to be option number A. It is a theoretical one, but yes, you should know it is made from strong acid and weak base. Strong acid such as H2SO4 and weak base such as NH4OH. So answer is going to be option number A. Clear? Now let us see question number 171. Let us see question number 171. Following solutions were prepared by mixing different volumes of NaOH and HCl in different concentration. Which one of them will be equal to 1? Which one of them will be equivalent to 1? I am giving you 2 minutes in order to think about it, students. Which one of them will be equivalent to 1, students? Yes, students, what do you feel? How you have to solve this question? See, first of all, understand in NaOH and in HCl, what is going to be the N factor? Ma'am, the N factor is going to be 1 in both of the cases. N factor is going to be 1. That means normality and molarity is equal in both of them. So now when you are seeing the different volumes, you are preparing a solution. So what you have to do is, see, basically you have to take M1V1 minus M2V2 divided by total volume is equivalent to M3V3. By this way, you have to make all the 4 equations that they have given you, right? And when you are going to calculate for all of them, Harshvardhani is saying 1. Ram is saying D. Exactly. Exactly. See over here which of the following they are saying. pH of which of the following will be equal to 1? pH of which of the following will be equal to 1? pH of which of the following will be equivalent to 1? Answer is going to be option number D for the case of C. For this case, the pH is going to be 1. How you have to calculate? Again, I am repeating. The volume into its molarity 1 by 5 minus volume into molarity divided by total volume. Okay, this is the formula that we used to do. What was the molarity of mixture? We have started, no? So option, yes, C is the right answer, but it is given as option number D as C, right? In this case, HCl and NaOH both will have the N factor as 1, because here it is liberating 1 H positive, it is liberating OH negative as 1. N factor for both of the cases 1, so their molarity and normality are same. Yes, everyone. Deshraj Paul is saying C, Harshvardhani is saying C. Good, 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 good. C, but answer is going to be option number D, C, right? Question number 172. What is the pH of the resulting solution when equal volumes of 0.1 molar NaOH and 0.1 molar HCl are mixed? 1 molar HCl are mixed. Yes, students, giving you 2 minutes to think about it. See, 1 mole of NaOH will be completely neutralized by 1 mole of HCl. So, I can say that 0.1 molar NaOH will be completely neutralized by 0.1 mole for HCl. Because see, 0.1 molar referred to as 0.1 moles present in 100 ml of solution. That means if 1 mole NaOH can neutralize 1 mole HCl, that means 0.1 can neutralize how much? 0.1 of HCl. Are you getting my point? If it can neutralize this much, the NaOH left unneutralized will be how much? NaCl left neutralized will be how much? You all are very, very fast, but your answer is wrong. C is not the correct answer for this particular question. They are asking what is the pH of resulting solution when equal volumes are mixed. When equal volumes are mixed, students. See, as equal volumes are mixed, so we will see NaOH left will be how much? See, let me tell you, see, if I say that 1 mole of NaOH neutralizes 1 mole of HCl. Let us say that 0.01 mole of NaOH neutralized will be how much HCl neutralized? It will neutralize 0.01 mole. Right, now as per the question, 0.1 molar NaOH and 0.1 HCl are mixed together. So we can say NaOH unneutralized will be how much? It will be 0.1 minus 0.01. That means 0.09 is the unneutralized moles of NaOH. It is 0.09 is the unneutralized moles of NaOH. Now if two equal volume solution is mixed, what will be the concentration for OH negative? It will be 0.09 by 2. That means it is 0.045. This is the concentration of OH negative and this is the concentration for H positive. For both it is same. Now what will be POH? POH is minus log of OH negative ion. That is minus log of 0.045. Right, everyone? Right, everyone? So when you are going to calculate the value of POH, it will come out to be 1.35. How much? 1.35. Now we know that pH plus POH is equivalent to 14. What will be pH? pH will be 14 minus 1.35. It comes out to be 12.65. It comes out to be 12.65. Clear? Kindly take a screenshot of this so that we can move on to the next question of ours. Kindly take a screenshot so that we can move on to the next question of ours. Okay. Now this was your question number. Now let's do some question on ionic product. 1 second, students. Now comes your 173 question. The ionic product of water at 25 degrees Celsius is 10 raised to the power minus 14. Its ionic product at 90 degrees Celsius will be how much? Try to solve this question based upon the ionic product of water, students. Yes, students, the ionic product of water it's given at a particular temperature. You have to calculate at another temperature. It is very simple. Direct, you can tell the answer. It is very simple. Very simple. Yes, students, tell fast. What is going to be its answer, everybody? Now see, if you will see the ionic product at water 25 degrees Celsius is this much. Now you are increasing the temperature by 90 degrees Celsius. Let me tell you, if you are increasing its value will also increase. Now if you will see the number scale, it is basically like this: 0, 1, 2, 3, and here it is minus 1, minus 2. If you move in this direction, the value will increase. Now that means 10 raised to the power minus 14 is written over here, minus 12 is written over here, 10 raised to the power minus 16 here, and this. That means from 10 raised to the power minus 14, if you're moving in lesser amount, the value will increase. That means 10 raised to the power minus 16 in this side, value will decrease. Minus 20, value will decrease. Minus 14, value same. Minus 12, value is increasing. So if you are increasing the temperature, the value of ionic product of water will increase if you will increase the temperature. Got my point? So option number D is your right answer. Clear, everyone? Option number D will be your right answer for this particular question. Clear? Now let us go for the next question. Question 174. Let us see this question now. If alpha is the dissociation constant, then the total number of moles for the reaction will be what? If alpha is the dissociation constant, then the total number of moles for the reaction 2HI gives H2 plus I2 will be what? What is given to you? Question is 2HI gives H2 plus I2. Okay, let us consider it is 1 initially, it is 0, 0. It will be 1 minus 2 alpha. It will be alpha produced, right? So what is I? I will be total moles after dissociation by total moles before dissociation. It will be 1 minus 2 alpha plus alpha by 1. So this will get cancelled. What we will get answer over here? I comes out to be 1. I comes out to be 1. Clear, everybody? Kindly take a screenshot of this one. But as per the question, this is the value of I. They are asking us a different thing. See, this is the value of I. They are asking us total number of moles for the reaction. Total number of moles. That means this is the total number of moles. That means this is the total moles. Yes, everyone. That means this is the total moles. Yes, everyone. One more thing, kindly correct. Here it will be 2 minus 2 alpha. Here will be 2. Because it is 2 written over here. So it is 2 minus 2 alpha. How much will be formed? Alpha will be formed and alpha will be formed. Right? Now, if I ask you the total moles formed, alpha will be, if we take 100% dissociation, alpha will be 1. What it will be? This will be 2 minus 2, this will get cancelled. 1 plus 1, 2. Total moles will come out to be 2. Total moles will come out to be 2. If alpha is 1, that means 100% dissociation. So, alpha here is 1. So, 2 minus 2 is 0. Plus 1 plus 1, that means 2. So, total moles dissociated is 2. And if they ask you the value of I, you can calculate the value of I also. You can even calculate the value of I, that is 2. Clear? Because here we have to write 2. 2 minus 2 alpha. 2 minus 2 alpha. Clear? Let us see the next question. Kindly write it down. Let us see the next question if it is done. Now let us do this question number 175. Question is, the pH of a solution containing 50 ml each of 0.10 molar sodium acetate and 0.01 molar acetic acid is what? pKa value they have already given you, students. Now you have to directly write the answer, directly write the formula over here. pH is equals to pKa value plus log salt by acid. Simple. Now what is the value of pKa? 4.57 plus what is the log salt over here? Ma'am, salt over here is 0.10 divided by what's of acid? 0.01. So what it will be? 4.57 plus log 0.10 can be written as 10 by 100 and 0.01 can be written as 1 by 100. So 100 will get cancelled. Log 10 is 1. So this comes out to be what? pH comes out to be what? 4.57 plus 1. That means 5.57. pH comes out to be 5.57. Clear everyone? Clear everyone? Clear everyone? pH comes out to be what? 5.57. This is the direct formula for pH. For acids, this is the direct formula. For acids, this is the direct formula. Ma'am, please explain again once. Yes, Neetu, why not? See, the pH of a solution containing 50 ml each of 0.10 molar sodium acetate. Now, this molar basically represents the concentration, right? And 0.01 molar acetic acid. That means another one concentration for acetic acid is also given to you. Now they have given you concentration for salt also and for acid also. For both of them, they have given you the concentration, right? So what is the formula of pH? pH is equivalent for acids. You are going to use pKa plus log for the concentration of salt by the concentration of acid. Yes. Now pKa value is 4.57 plus log. What is salt over here? Salt concentration is 0.10 molar and for acid concentration is 0.01. Now you have to just cut off the decimal points. When you are cutting, it comes out to be log 10. And what is the value of log 10? Log 10 value is 1. Log 10 value is 1. So 1 plus 4.57 comes out to be 5.57. Clear everyone? Clear everyone? When is break, ma'am? What happened, Sargi? You were to answering all the questions. What happened? Okay. What happened? Okay. So now let us move on to the next question. Done everyone? Now one question for your homework from this chapter, right? Okay, no problem. Okay, now comes your question 176 as your homework from this particular chapter. Solution of 0.1 normal NH4OH and 0.1 normal NH4Cl has a pH of 9.25. Akash Keshari, why not please listen over here? I'm explaining the question. Please listen over here. Yes, okay. So solution of 0.1 normal NH4OH and 0.1 normal NH4Cl has a pH of 9.25. Then find out pKb of NH4OH. Okay. So this question, student, is your homework from this chapter and we are wrapping up our ionic equilibrium over here. Now we are going to start our redox reaction chapter from here now. Everyone, are you excited for the redox reaction chapter? Everyone, are you excited for the redox reaction chapter? Please give me a minute to open the questions. Question 177 we are going to start. Okay. Question number 177. We are going to start with our chapter redox reaction. Shall we start, students, with the chapter redox reaction? Everyone, are you excited for this chapter now? Ma'am, please please talk 2 minutes with us. Yes, yes. You can ask your any doubt. If you have any doubt, you can ask. Anybody, if you have any doubt, you can ask. So we'll start with the chapter redox reaction, and after redox reaction our 11th is completely done, and then we'll be left with 12th, only 3 chapters because solution and solid state is already done. Right, everyone? Okay. Yes, students? Yes, anybody, any doubt, or shall we start with the redox reaction? I want your full energy to be there in the comment section. Yes, students, please let me know in the comment section. Be fast. Pravina is saying ionic equilibrium is quite confusing. Pravina, what you can do is create a formula sheet. Okay. What you can do is you can create a formula sheet separately for this chapter, and while applying the questions, go topic to topic. For example, pick a certain topic, okay, for example, go for buffer solution, pick up the buffer solution, write its formulas on a single sheet of paper, and then apply 10 questions based upon that. Similarly, pick one question on the solubility product topic and try to attempt questions on that, right? Clear? So shall we start, students, rather than, discussing all of these things that is going in the comment section? If you have a proper doubt, then you can go and ask. If you don't have, then I can go ahead. Please let me know. Shall I start? Okay. So now we are going to start with the redox reaction chapter, students. Now we are going to start with the redox reaction chapter. Yes, everybody. So the question is in front of you. What is the change in oxidation number of carbon in the following reaction? What is the change in the oxidation number of carbon in the following reaction? You have been provided with this particular reaction over here, and you have to tell about the change in oxidation number. Very good, Pravina. She has already answered. Very good, very good. Ma'am, start with the smile. I'm always smiling. Why not? Yes, okay. So now, okay, now let us talk about our question over here. It is CH4 plus 4Cl2 gives CCl4 plus 4HCl. Am I right? Now, see, in this particular question, we have to find the oxidation state. So if I talk about CH4 over here, let us consider it as X. And then we can say for hydrogen, we know it is plus 1 into 4 is equivalent to 0. So X comes out to be minus 4 in this state. And over here, again, take it as X. Now for Cl, you all very well know it is a halogen, minus 1 oxidation state into 4 is equal to 0. X will come out to be plus 4. So oxidation state is being changed from minus 4 to plus 4. Yes? Sorry, here it is minus 4. Kindly correct it. So the answer is going to be option number A. Clear? Clear, everyone? Okay, shall we move on to the next question? Now the next question, question number 178 is in front of you. Question 178 is in front of you. Kindly, students, try to solve it out. Try to solve it out, students, so that we can start with the next part. So the next question is, which of the following reactions are disproportionation reaction? Select the correct option from the following. You have to tell the disproportionation reaction. Yes, students, be fast. What do you feel? Which of the following reactions is the correct one? Everybody. Now this is basically in which one element, the same element or the same compound will undergo oxidation and reduction. Same element will undergo oxidation or reduction. Yes, everybody. So basically, see over here, if I see in the very first part, if I see over here, Cu from +1 is moving to +2, that means oxidation number is being increased, and it is moving from +1 to 0, that means oxidation number is being decreased. So a single element is basically doing oxidation as well as reduction, right? Single element is doing oxidation as well as reduction. So this is a disproportionation reaction. Yes, first is there. Okay, now if I talk about the second one over here, see, now we will calculate the oxidation numbers for each one of the following. We will calculate oxidation number for each one of the following. In MnO4 minus 2. MnO4 minus 2. What is the oxidation state on Mn, or what is the charge on Mn? Basically, how you are going to see, X plus oxygen is minus 2. How many oxygen? 4 is equivalent to overall charge minus 2. X minus 8 is equivalent to minus 2. X comes out to be minus 2 plus 8, that is plus 6. Now Mn is in plus 6 oxidation state over here, right everybody? It is being converted into MnO4 negative. Let us calculate for MnO4 negative also. Now in this case, Mn has an oxidation state of X. Let us consider oxygen as minus 2, total 4 oxygen, and overall charge is minus 1. X minus 8 is equivalent to minus 1, X comes out to be plus 7. Mn comes out to be plus 7 oxidation state in this one. Now we have MnO2 with us. Here again Mn has X oxidation state, oxygen we know is minus 2, total 2 oxygen, overall charge is 0. X minus 4 is 0, X comes out to be what? How much, ma'am? Plus 4. Now see, Mn is moving from plus 7 to plus 6 to plus 7, number is being increased. Also it is moving from plus 6 to plus 4, number is being decreased, right? So again there is a disproportionation reaction because a single compound is doing oxidation as well as reduction. So second is also the correct one, second is also the correct one. This is wrong because they don't include second option. Now let us see the third part. In the third part we have KMNO4. What we have? KMNO4. In KMNO4, what is the oxidation state of Mn? Now for potassium it is plus 1. For Mn again as X. For oxygen minus 2 into total 4 oxygen. Overall charge will be what? 0. What we will get? 1 plus X minus 8 equal to 0. X comes out to be plus 7. Here Mn is in plus 7 oxidation state. Yes everybody? Yes everybody? Now we have K2MnO4. What we have over here? K2MnO4. Now for potassium it is plus 1. 2 potassium plus for Mn it is X. For oxygen it is minus 2 into 4 is equal to 0. We have 2 plus X minus 8 is equal to 0. X will come out to be plus 6. Okay, here we will have plus 6 oxidation state. Now MnO2 again, MnO2 we have already calculated, students, it is plus 4. We have already calculated. Now see, now here it is moving from plus 7 to plus 6 and from plus 7 to plus 4. In both of the cases it is being decreased. In both of the cases it is being decreased, right? So here is only what? Reduction is happening, no oxidation. So third equation is the incorrect one. There will be no third. Hence answer is going to be option number B. And answer is going to be option number B. Is it clear to everybody? Is it clear to everybody? Kindly take a screenshot of this question so that we can move on to our next question. Is it clear? Clear everyone? Okay. Now comes your next question. This was which question? Question 178. Now comes your question number 179. Let us see your question number 179, students, in front of you. Question is, the oxidation state of chromium in CrO2 is? Let me check. It is not CrO2. The question is incorrect. Please give me a minute. Sorry, here it is CrO5. Kindly correct the question. It is CrO5. It is CrO5. The oxidation state of Cr in CrO5 is going to be what? Students, be fast. Kindly draw its structure and calculate. You can even draw its structure and calculate. Now see, Cr basically will make 2 double bond oxygen like this, and these oxygens will be connected like this. So basically this is the structure for CrO5. This is the structure for CrO5. Now what is going to be the oxidation state? Now due to these two oxygen will have -2, it will have +2. Due to this, it will have -1, it will have +1, it will have -1, +1. Due to this bond, it will have +1, it will have -1, it will have -1, it will have +1. So chromium will have +2, 3, 4, 5 and 6. +6 oxidation state. Chromium will have +6 oxidation state. Yes, Rams, correct. Your answer is correct. Option number C is going to be the correct statement for this particular question. Clear, everybody? Option number C is going to be correct for this particular question. Shall we move on to the next question of ours, everybody? Question number 180. Question number 180. Question 180 is in front of you. What is given in the question? The correct order of nitrogen compounds in its decreasing order of oxidation state is. In its decreasing order of oxidation state is, everybody. Oxidation state here we need to calculate. So let us do that. HNO3. Hydrogen has +1 oxidation state. Nitrogen we will consider as X. Oxygen we know it is -2. Total 3 oxygen is equivalent to 0. 1 plus X. 1 plus X minus 6 is equivalent to 0. X minus 5 is equivalent to 0. X will come out as 5 oxidation state, everybody. Right, now in the case of NO, let us talk in the case of NO. Consider N as oxidation state X. For oxygen it is -2, overall charge is 0. X comes out to be +2 oxidation state, everybody. X comes out to be +2 oxidation state, everyone. Now we shall talk about in the case of N2. How many nitrogen is bonded to itself? Nitrogen is bonded to nitrogen only. So it will have 0 oxidation state, it will have 0 oxidation state. Now we are left with NH4Cl. Nitrogen we will consider it as X. Hydrogen as +1 into how many hydrogen, ma'am? Into 4. Plus chlorine as -1 is equivalent to 0. X plus 4 minus 1 equal to 0. X will come out to be -3. Here X is in -3. So which of the following has the highest value? HNO3, 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 HNO3. This is wrong. Then which of the following will be right one? NO, NO, NO. Then N2 and at last NH4Cl. Option number A, students, will be your right answer. Option number A will be your right answer. Right, everybody? You right, everybody? Shall we move on to the next question? 181 question. Question 181 in front of you all. For the redox reaction, the correct coefficients of the reactants for the balanced equation are. For the redox reaction, the correct coefficients of the reactant for the balanced equation are. Mohammed Shah ke A आया. Yes, A ही आया इसमें. Over here, A was the correct answer. Yeah. Now coming to this question, we are going to balance this equation. Let us balance this equation. Okay, now see. In this particular equation, first forget that you have H positive, you have water. Forget it. Write it down as MnO4 negative plus C2O4 minus 2 gives Mn plus 2 gives CO2. Now see in which of the following is oxidation and reduction taking place. See in MnO4, Mn oxidation state as X, oxygen as -2, total oxygen 4, overall charge -1. X minus 8 is equal to -1, X will be -1 plus 8, that means +7. Mn is in +7 oxidation state, right? Now from +7 to +2, what is happening? Oxidation number is being, ma'am, decreased. Oxidation number, if it is being decreased, it is reduction occurring. Now in C2O4 negative, here for carbon we will consider as X, 2 carbons, so 2X plus. For oxygen -2, total oxygen are 4, overall charge is -2. 2X minus 8 is equivalent to -2. 2X will be -2 plus 8, that is 6. X will be equal to 3. What will be X, ma'am? X will be equal to 3. Now over here in CO2, X plus, for oxygen -2 into 2 is equal to 0. X minus 4 is equal to 0. X will be +4. Now see, from 3 to 4, it is being increased. So this is oxidation. Now see what is happening over here. Here Mn is 1, Mn is 1. Here carbon is 2, here carbon is to be 2. Here from +3 to +4. Now see your change. From +7 to 2, the change is of 5. Change is a 5 from plus 7 to 2. And from plus 3 to plus 4 change is for 1. But for 2, how much the change will be? For 2, how much the change will be? My simplest question for you all. For 2, what will be the change? For 2, it will be 2, no? Now let us cross multiply. Let us cross multiply. Multiply 5 with these two and multiply 2 with these two. What you will get? You will get 2 MnO4 negative plus 5 C2O4 minus 2 gives 2 Mn plus 2 plus 10 CO2. Clear everybody? Now see. Now we have to check the H positive ions. First check Mn, 2 Mn, 2 Mn. How many carbon? 10 carbon, 10 carbon. Now check oxygen. Now check oxygen over here. 8 oxygen and 20 oxygen. 28 oxygen. Here is only 20 oxygen. 8 oxygen are missing. So 8 water we will add over here. How many water we have added? Ma'am, we have added 8 water molecules. So how many hydrogen over here? 16. Over here there is no hydrogen, so add 16 H positive. Now this is your balanced equation. So now how many MnO4 negative? How many MnO4 negative is there? 2. 2. How many C2O4 negative? 5. How many H positive? 16. So option number B is the right answer. Option number B is going to be your right answer. Clear everybody? Option number B is going to be your right answer. Clear everyone? Clear everyone? Yes students, please let me know in the comment section if your options and answer is same. Clear everyone? So now students, before going on to the next question, we will take a break of 10 minutes. We are going to take a break of 10 minutes. Yes everybody? And then we are going to further continue with our redox reaction and the class 12 chapters. Right everyone? So now we are going to take a break of 10 minutes over here. Everybody has written this. Please let me know in the comment section if everyone has written this. Please let me know in the comment section if everyone has written this. Yes students. Please let me know in the comment section. I don't know why your comments are not being visible to me. Yes, okay. So now we are going to take a break of 10 minutes everybody, right? We will be meeting after 10 minutes and completing this redox reaction in class 11th, and then the 3 chapters that are left of class 12th, we will be doing that. Yes everyone. So now we shall meet. This is your question number 182 and we shall meet after 10 minutes, right? Clear everyone? Okay students, so your timer starts now. We will be meeting at 5:40. Clear? Your timer starts now. Hello students, I welcome you all back after this 10 minutes break. Yes, everybody. Hello everyone. So, I guess each and every one are solving every question which we are doing, right? And you are analyzing yourself that which topic of yours need to be more improvement, or you need to study hard for that topic, right? Okay, yes everybody. So shall we start? Kindly join fast students. We'll start with our question number 182. Now we are going to start with our question number 182. Everybody, are you ready? Everyone, are you ready for this question now? Yes. Please let me know in the comment section. Please let me know in the comment section. Yes, please let me know in the comment section. Yes. Great, great. So now I'm going to read question number 182 for you people. Question basically is, role of hydrogen peroxide in the above reaction is respectively A option, oxidizing in the first and reducing in the second one. B option, reducing in the first and oxidizing in the second one. C option, reducing in the first and second, while D option over here is oxidizing in first and second. So yes, my students, be fast and let me know. What you have to do as per the question? First of all, you have to write the oxidation number or the oxidation state. Yes, everyone? What do you have to write? Oxidation number or the oxidation state. Yes, ma'am? Ready? Okay. Shall we do now? Yes. Now see. Let us now take different colors of pen. I am so getting bored from these colors. Okay, what about this color? Let us take this color and start doing it. Okay. Our first reaction is H2O2 plus O3 gives H2O plus 2O2. Right, everyone? Yes. Now we have to see the role of H2O2 over here. What is the oxidation state of, oxygen over here? What is the oxidation state of oxygen and H2O2, everybody? See, ma'am, hydrogen is in +1 oxidation state. So 2 hydrogen plus 2 oxygen. So 2x is equal to 0. 2 plus 2x is equals to 0. 2x comes out to be -2 and x came out to be -1. So oxygen is in -1 oxidation state over here, and here O2 is in 0. So from -1 to 0, ma'am, when we see oxidation number is being increased, what is happening, ma'am? Oxidation number over here is being increased. That means in the very first reaction, oxidation is taking place. Oxidation is taking place. Yes, everyone? Yes, Sergi, exactly right. Now let us talk about the second reaction over here, students. Which is our second reaction again? H2O2 plus Ag2O gives us what? 2Ag plus H2O plus O2. Now again, students, H2O2 over here, oxygen contains -1 oxidation state. -1 oxidation state. Right? -1 oxidation state. It is being reduced to what, ma'am? To 0 again. It is being, here oxidation is being taking place. Again, students. Yes, students. In both of these reactions, oxidation is occurring. That means H2O2 is acting as your reducing agent. H2O2 is acting as your what, ma'am? Reducing agent. Why? Because there is oxidation taking place. Increase in oxidation number means oxidation. That means it is a reducing agent. That means in both of the cases, it is reducing. In both of the cases, it is reducing. So reducing in first and second. Option number C is going to be your correct answer for this particular question. Yes, everybody? Clear? Shall we move on to our next question? That is question number 183. Yes, everyone? A mixture of potassium chlorate, oxalic acid and sulfuric acid is heated. During the reaction, which element undergo maximum change in the oxidation number? Students, giving you 2 minutes to think about it. A mixture of potassium chlorate, KClO3, oxalic acid and sulfuric acid. KClO3, oxalic acid, sulfuric acid is being heated. It is converting into which of the following products? Yes. How many lesson completed, ma'am? First of all, complete this reaction, I'll tell you. It will split into K2SO4, KCl, CO2 and water. This is your reaction. Now let me know the answer in the comment section. I have written the reaction for you all. How many lessons ma'am completed? For class 11th, we have completed each and every lecture. This is your last lecture for class 11th. For class 12th, we have done solid state and solution. Rest 3 chapters are left for that. Okay? So now you can calculate. Which will undergo maximum change in the oxidation number? Which will undergo maximum change in the oxidation number? Now see. Potassium we know is in +1 oxidation state. Cl we will let as X. For oxygen we know -2 into 3 is equivalent to 0. 1 plus X minus 6 is equal to 0. X minus 5 is equal to 0. X comes out to be +5. How much ma'am? +5. It is in -2. It is in +1. Now see over here. In the case of H2SO4, it is in +1. It is in -2. Sulfur oxidation state will be what? +1 into total 2 hydrogen plus X. Plus for oxygen it is -2 into 4 is equal to 0. 2 plus X minus 8 is equal to 0. X minus 6 is equal to 0. X will be +6. Sulfur is in +6 oxidation state. Yes. Now in this case K2SO4, potassium again in +1, oxygen -2. See, potassium from +1 into 2 potassium plus sulfur as X plus for oxygen as -2 into 4 is equal to 0. 2 plus X minus 8 equal to 0. X will be +6. Now KCl, it is in +1 -1. In CO2 it is +4 -2. Water -2 +1. So which of the following is going to be correct answer, students? Now I have written all the oxidation state over here. They are asking which will undergo maximum change. See, potassium from +1 to +1 only. Cl is moving from +5 to Cl is moving from +5 to -1. So maximum change is being seen in the case of Cl. That means option number C, ma'am, is going to be your correct answer. Clear, everyone? Kindly take a screenshot of this question so that we can move on to the next question of ours. Shall we? Shall we now? Okay. Now comes the next question, question number 184. Question 184 is oxidation number of phosphorus in PO4 3 negative, sulfur in SO4 2 negative and that of chromium in Cr2O7 2 negative are respectively what? A option over here is +3, +6 and +5. B option is +5, +3 and +6. C option is -3, +6 and +6 while D is +5, +6 and +6. So students, let us see this now. In the case of PO4 -3 for phosphorus, let us assume it as X. For oxygen -2, total 4 oxygen, overall charge is -3. So X minus 8 is equivalent to -3. Let us take it on the another side. X will be -3 plus 8, that comes out to be +5. That comes out to be how much, ma'am? +5. Right? Now in the case of SO4 -2, for sulfur, X we will assume. For oxygen we know -2, total 4 oxygen and overall charge is -2. So X minus 8 is equivalent to -2. X will be -2 plus 8, that means 6. That means how much? That means 6. Yes. Now in the case of Cr2O7 -2, how many chromium is there? 2. So 2x plus for oxygen -2. How many oxygen? 7. Overall charge is -2. So 2x minus 14 is equal to -2. 2x is equivalent to minus 2 plus 14, that is 12. X will come out to be 6. So this comes out to be 5, 6 and 6. That means option number D is going to be your right answer for this particular question. Option number D is going to be your right answer for this particular question. Clear, everybody? Shall we move on to the next question? Kindly take a screenshot of this one. Kindly take a screenshot of this one, students. Okay, now comes your next question, students. Your question number 185. Question number 185. Question 185 is, which is the best description of the behavior of bromine in the reaction given below? You have to tell the description of bromine in the reaction given below. Description of bromine, H2O plus Br2 gives HOBr plus HBr. This is our reaction. A is proton acceptor only, B is both oxidized and reduced, C is oxidized only, while D is reduced only. So you have to tell about bromine over here. Shall we write the reaction again? So our reaction basically is H2O plus Br2 gives HOBr plus HBr. Now see, here it is 0, here it is plus 1 minus 1, here plus 1 minus 2 plus x is equivalent to 0, minus 1 plus x is equivalent to 0, x will come out to be plus 1 in this case. Now see, bromine from 0 to plus 1 and from bromine from 0 to minus 1. It is being oxidized also, it is being reduced also. So both oxidized and reduced is going to be our correct answer for this particular question. Yes, everyone. Both oxidized and reduced is going to be correct answer for this particular question. Yes, Malathi, right. Answer is right. Ragul, your answer is wrong. Sergi, your answer is right. Okay, let us see the next question. That is question number 186. Question number 186 is in front of you. The oxidation states of sulfur in the anions follow the order. The oxidation states of sulfur in the following anions follow the order. You have following options in front of you, students. Be fast, solve by your own, then we'll check our answer. Then we'll match our answer. Yes, everybody? Given you 2 minutes in order to solve it out. Yes, everyone? Okay, so let us talk about the very first, that is S2O4 minus 2. Now we have to calculate for the sulfur, right? So let us assume for sulfur the oxidation state is X. How many sulfur? 2. So 2X plus. For oxygen it is minus 2. How many oxygen? 4 is equivalent to the overall charge is minus 2. So 2X minus 8 is equal to minus 2. Let us take this over there. 2X will be minus 2 plus 8, that is 6. X will come out to be how much, ma'am? X will come out to be 3. X will come out to be how much, ma'am? X will come out to be 3. Yes, everyone? Clear? Similarly, let us calculate in other cases. SO3 minus 2. Sulfur, we will assume it as X. For oxygen, it is minus 2. Total 3 oxygen. Overall charge minus 2. X minus 6 is equivalent to minus 2. X will be minus 2 plus 6. That means 4. Oxidation state will come out to be 4 over here. Yes, students? Clear? Now, similarly, let us talk about the next one, that is S2O6 minus 2. How many sulfur, ma'am? 2 sulfur. So, oxidation state we will assume it as 2X. Plus for oxygen it is minus 2. How many oxygen? 6. Overall charge minus 2. 2x minus 12 is equal to minus 2. 2x will be minus 2 plus 12. That means 10. X will come out to be what, ma'am? 5. Now you have to arrange them according to the increasing order. Highest will be for S2O6 minus 2. For these two both. After that it will be for SO3 minus 2. And at last for S2O4 minus 2. That means, ma'am, option number A is going to be your correct answer for this particular question. Yes, everybody. Clear, everyone? Shall we move on to the next question if it is done? Kindly take a screenshot for this question. Okay, now comes your question number 187. Question number 187. The oxidation state of Fe in Fe3O4 is. The oxidation state of Fe in Fe3O4 is. Now see, basically Fe3O4. For Fe we need to calculate, assume it as X. How many Fe3, ma'am? So it is 3X plus. For oxygen what it is? Minus 2 into 4 equal to 0. 3x minus 8 is equal to 0. 3x will be equal to 8. X will come out to be 8 by 3. How much, ma'am? 8 by 3. So option number D over here is going to be your correct answer for this particular question. Yes, ma'am. Clear, everyone? Clear, everyone? Yes, everybody? Kindly take a screenshot of this question so that we can move on to the next question of ours. Now let us go for question number 188. Okay, now comes your question 188. The oxide which cannot act as a reducing agent is A, CO2, B, ClO2, C, NO2, while D is SO2. The oxide which cannot act as a reducing agent. Yes, students. Yes, everybody. Yes, students, what is going to be its answer? You know, the carbon dioxide, in this case, carbon is in its maximum oxidation state +4. That's why it cannot act as a reducing agent. So option number A over here is going to be your correct answer for this particular questions. Now 2 more questions and we are going to complete this chapter as well. Okay, now this is your question number 189 as your homework. Very simple question. 189 as your homework from your redox reaction chapter. From your redox reaction chapter, question 189 is your homework. Homework is, which substance is serving as a reducing agent in the following reaction? Which is serving as a reducing agent in the following reaction? Very simple. By looking at the question, you can itself answer it. Right? Now moving on to question 190 as the last question of the chapter redox reaction. Yes, you have to find the oxidation state of iodine in the given compound. Calculate the oxidation state of iodine in the given compound, students. Very simple. See, for hydrogen we know it is +1. How many hydrogen? 4. For iodine we will let as X. For oxygen we know it is -2. How many oxygen? 6. Overall charge is -1. So +4 plus X minus 12 is equal to -1. X minus 8 is equal to -1. X will be -1 plus 8, that means +7. So oxidation state is going to be what? Oxidation state is going to be +7. So option number C is going to be the correct answer for this particular question. Kindly write it down for one, students. Yes, everyone. Clear with the oxidation state? Clear with the oxidation state of iodine? Yes, everyone. So now with this we end our redox reaction chapter over here. Now we are going to start with our class 12th chapter, that is going to be electrochemistry. We are going to start with your question number 191 as your chapter electrochemistry. Yes, everyone. Yes, everyone. Ready for this chapter? Ready for the chapter electrochemistry? Kindly get ready for your new chapter now, class 12th one, that is electrochemistry. Electrochemistry. So before starting, there are few lines for you all. Before starting this lecture, there are few lines for you all. Believing in yourself is the key to success. Believing in yourself is the key to success. Filled with confidence must be your mental address. Filled with confidence must be your mental address. Right, everyone? So, now shall we start? Ready? So, the very first question is in front of you, people. Kindly read the question and try to solve it. Kindly try to solve it. Okay, ma'am, your name? My name is Shaurya Grover. Welcome to PW English channel, and we are going through with the NEET Mega Marathon series. Okay, now let me read the question for you all. The standard electrode potential values of aluminium +3 to aluminium, Ag positive to Ag, K positive to K, and Cr +3 to Cr are -1.66 volt, 0.80 volt, -2.93 volt and -0.74 volt respectively. The correct decreasing order of reducing power of the metals is? Yes, everybody. Ma'am, how to better score in NEET? By practicing more and more questions, right? By practicing more and more questions, you can better your score in your NEET examination. It's very simple. Okay, Ram has already answered. It's B. Okay. Iftikhar has answered B. Sorry if I have pronounced your name wrong. Okay. Okay, everybody, be fast. Think about it. They are asking you the order for the reducing power. The order for the reducing power. See, higher the value of reduction potential, stronger is the oxidizing agent. Higher the value of reduction potential, stronger is the oxidizing agent. Yes, everybody? Higher the value of reduction potential, stronger is oxidizing agent. Now, I guess each and everyone has got a hint. Everybody has got a hint over here. See the values of, these are the values of reduction potential. Whose value is higher, that is stronger oxidizing agent. So, if you'll see over here, value is high for the case of this one. That means for K positive and K, that means it will have the lowest reducing power. It will have the lowest one. It will have the lowest one or the highest one. Yes, students. Decreasing order of reducing power is going to be what? Sorry. This is not the highest value. This is the lowest value. It is in negative. Sorry. Highest value is 0.80 volt. Highest value is 0.80 volt. That is of Ag positive to Ag. Right? Highest value of reduction potential, that is the stronger the oxidizing agent. If it is stronger the oxidizing agent, that means it will have the least reducing power. That means here argon, here which of the following will have the least one? Ag positive to Ag will have. Then if we'll talk about the next one is going to be -0.74. The next one is going to be -0.74. It is of whom? Ma'am, it is of Cr +3 to Cr. It is of Cr +3 to Cr. Here Ag will come. Kindly correct it. Okay. It is of Cr +3 to Cr. Now Cr +3 to Cr has a higher value. Then that means it is stronger oxidizing agent. That means lower the reducing power. So after Ag we will have Cr. Now next value will be of -1.66 volt. It is, you know, it is more than this one. So it is again the least reducing one. See, the order is opposite. Either write this order or write that order. If I have to write this order, higher value is of Ag, then it is of Cr, then it is of aluminium, and at last it is of potassium. This is the order of oxidizing one. Its opposite order will be of reducing one. So what is the opposite order? Ag, then Cr, then aluminium, then potassium. So which of the following matches? Option number B matches. Got my answer? Got my answer? Clear? Shall we go on to the next question? Question number 192. Now comes question number 192. We are soon to reach 200 questions. Question number 192. Now, question is standard reduction potential of the half cell reactions are given below. The strongest oxidizing and reducing agents respectively are, again the same question, higher the reduction potential, stronger the oxidizing power. Higher the reduction potential, stronger the oxidizing power. Just right now I have told you the same thing. Higher the reduction potential. Which of them has higher? This is higher. That means this is stronger oxidizing one. So stronger oxidizing is F2. Now, and lower the value will be the strongest reducing one. Lower value, which has the lower value, this has the lower value. That means I2 is the reducing one. I negative is the reducing one. So option number A is the right answer. Again, if you want to write in the options, you can write it down. Higher the value of reduction potential, stronger is the oxidizing agent. Lower the value of reduction potential, stronger is the reducing agent. Got my point? Got my point? Clear? Shall we move on to question number 193 if it is done? Kindly take a screenshot of this one. Kindly take a screenshot of this one. Okay, now comes question number 193. 193. Question 193 is standard electrode potentials of three metals X, Y and Z are minus 1.2 volt, positive of 0.5 volt and minus 3 volt, okay, respectively. The reducing power of these metals will be, now only I have told you, more the value of reduction potential, more it is the oxidizing power. More value, highest value of this. So this is oxidizing one. That means Y is the oxidizing one. Then which will, this is I am writing for oxidizing. Then which is the more value? Then X, then Z. Now they are asking about reducing power, so order will be opposite. Z, then X, then Y. Sorry. Z will have more, then X, then Y. Z will have more, then X, then Y. Option number C will be your right answer. Option number C will be your right answer. Clear everyone? Clear everyone? Shall we move on to the next question? Shall we move on to the next question? Great, great, great. Now let us see question number 194. Question number 194. Question number 194 is consider the following relationships for EMF of an electrochemical cell. Consider the following relationships for EMF of an electrochemical cell. First, EMF of a cell is equal to oxidation potential of anode minus reduction potential of cathode. Second, EMF of cell is equal to oxidation potential of anode plus reduction potential of cathode. Third, EMF of cell is equal to reduction potential of anode plus reduction potential of cathode. While fourth is EMF of cell is equals to oxidation potential of anode minus oxidation potential of cathode. Minus of that of cathode. So tell me fast students, which of the above relations are going to be the correct one? Which of the above relations are going to be the correct one? Yes students, it's a very simple formula. EMF of a cell students is equivalent to oxidation potential of anode plus reduction potential of cathode. Now let me tell you, if oxidation potential of anode you are writing, you have to write reduction potential, it will be negative of that. That means in terms of reduction, what you will write in terms of reduction, your formula will be reduction potential of cathode minus reduction potential of anode. Okay. Now, if you want to write in terms of oxidation potential, what it will be? EMF is equal to oxidation potential of anode minus oxidation potential of cathode. Right? Right? So now over here, EMF of cell is equals to oxidation potential of anode minus reduction potential of cathode. No, we have to add it. This is wrong. Next, oxidation potential of anode plus reduction potential of cathode. Yes, ma'am, this is right. Okay, see, the reduction potential of anode plus reduction potential of cathode. No. Reduction potential of cathode minus reduction potential of anode. Next, oxidation potential of anode minus oxidation potential of cathode. Oxidation potential of anode minus, yes. So second and fourth are correct. So in these, all these, D option is going to be the right answer. Option number D, students, is going to be your right answer. Kindly write it down, students, so that we can move on to the next question of ours. Done, students. Shall we move on to the next question? Now comes your question number 195. Question number 195. Question 195 is basically E naught of Fe plus 2 to Fe is minus 0.441 volt, right? And E naught for Fe plus 3 to Fe plus 2 is 0.771 volt. The standard EMF of the reaction for this will be what? You have been given a reaction, you have to calculate the EMF for this one. Vishnu, Mohit, Ujma, Roser, good. Spy Thunder, very good. Riya, good. Okay, so kindly let me know what is going to be answer for this particular question. First of all, write the reduction potential values and then we are going to solve it out. Now see, from Fe plus 2 to Fe, we are going to balance it out. 2 electrons will come over here. Now the reduction potential value, E naught value, is minus 0.441 volt. Now for the next reaction, Fe plus 3 being converted into Fe plus 2. Again we have to balance it out. The reduction potential value is positive 0.771. The standard EMF of this cell is going to be, what is the main reaction? Fe plus 2 Fe plus 3 is giving 3 Fe plus 2. Right, everyone? So you have to calculate for this particular cell reaction. See, you have to calculate for the third reaction. So how you are going to do? See, what I can do is, if I observe over here, I want 2 Fe plus 3. That means I have to multiply this equation by 2. If I multiply this equation by 2 and if I subtract this equation, the first equation, I will get my this one. See, if I multiply this equation, second equation, what it will be? 2 electrons plus 2 Fe plus 3. Now I subtract the first equation, minus 2 electrons minus Fe plus 2 gives, you have multiplied this by 2 Fe plus 2 minus Fe. What you will get? See, 2 electrons will get cancelled. You will be left with 2 Fe plus 3. This negative will go on that side. It will become 3 Fe plus 2. And this Fe will come over here. Is this the same reaction? Yes, ma'am. Is this the same reaction? Yes, ma'am. That means what we have done over here, ma'am? We have multiplied second equation with 2 and subtracted the first equation. We got our third equation. This is what we have done over here. This is what we have done over here, everyone. Yes, everyone. So now what we have done in this particular situation, see, you have to multiplied it and you have then subtracted it. You have got your answer. Which of the following is the correct answer? Now I have given you hint. Let me know the answer in the comment section. I have given you the hint. Now let me know the answer in the comment section. What is going to be the answer? Yes, Ram. Answer is going to be option number D. Answer is going to be option number D, exactly. Answer will come out to be option number D. Now this is by way which we have done. But always remember, after this we are going to calculate in terms of delta G. What is delta G? Delta G is minus NFE naught. So you will calculate in terms of that. Delta G for the third reaction is equivalent to delta G for the second reaction minus delta G for the first reaction. Twice into delta G for the first one. By this way you have to solve. Yes, Aisha. Answer is going to be option number D. Clear, everyone? Kindly write it down for once. I guess this is clear. Now the calculation portion was just left over. Clear, everyone? Now let us see the next question of ours. Question 196. Question 196 is find the EMF of the cell in which of the following reaction takes place at 298 Kelvin. Okay, over here it is nickel. Nickel plus 2 Ag positive gives nickel plus 2 Ag. E naught value they have given you and this complete value they have provided you. The complete value they have provided. Try to solve this question and then we are going to match our answers. Yes, this is the formula. Everybody, do you remember this is the formula? This is the formula. Yes, everyone. What is the value of E naught cell? The value of E naught cell is being provided to you. Yes, there is a correction in this question. Give me a minute. There is a correction. The value of E naught is not this. The value of E naught is 1.05. Kindly correct it. Okay. The value of E naught cell, kindly correct it. By what is N? N is number of electrons participating, that is 2 into log. What is concentration of nickel plus 2? Nickel plus 2 concentration is 0.001 molar divided by what is of Ag? It is 0.001 whole square. Right? So this 1 and 1 will get cancelled. What we will get over here? 1.05 minus 0.059 by 2 into log. It will be 1000 over here, right? So what I can write it as, it comes out to be 1.05 minus 0.059 by 2 log 10 raised to the power 3. Now this 3 will come in front. 1.05 minus 0.059 by 2 into 3 log 10 is 1, right? So now you are going to solve it. 1.05 minus by 2. This is 1.05 minus 177 by 1000 and we have 2 over here. 1.05 minus 8.5 by 1000. It is 0.088. Can I take it as 0.08? 0.97. 0.97. Yes, students, here E naught comes out to be 0.97. 0.961 something. E naught will come out to be 0.9 something. Let me check once its options. Yes. So that is 0.97. So this is 0.9615 approximately. Clear, everyone? This was easy question. Easy question. See, this formula will be used again and again. This formula will be used again and again, and it is really very important. Don't get confused in the value of N. N basically is the electrons. Yes, option number C is the correct answer. Kindly take its screenshot so that we can move on to the next question of ours. Kindly take its screenshot so that we can move on to the next question of ours. Let us see the next question now. Question number 197. What is question 197? For the cell reaction, 2Fe plus 3 plus 2I negative gives 2Fe plus 2 plus I2. Okay. E naught cell is 0.24 volt at 298 Kelvin. The standard Gibbs free energy of the cell reaction given that the Faraday constant F value is being provided to you. Very simple, ma'am. Ma'am, delta G is equivalent to minus NFE, right? If you are calculating delta G naught, it will be E naught over here. Right, everybody? It will be E naught over here. So what is minus N over here? N over here is number of electrons that are participating in a reaction. What is the value of N over here? Ma'am, value of N over here will be taken as 2. Why? Because see, iodine from minus 1 to 0, that means for 2 it will be 2, right? Similarly, Fe from plus 3 to plus 2, 1. For 2 change, it will be 2. So, N is 2. What is F value? 96500. What is the value of E naught? The value of E naught is 0.24. What it is? 0.24. So, when you are going to calculate it, you will get your answer as, it is minus 0.48 into 96500. That means 48 by 100 into 96500. Two zeros will get cancelled. It is 965 into 48. Four six three two zero. 46320. Negative sign is also there in front of this. Now you have to calculate answer in kilojoules. If it is in joules, then you have to divide it by 1000. The answer will be minus 46.320 kilojoule per mole. So the answer is going to be option number B. Answer comes out to be option number B. Clear? Ma'am, once more, how 2 came? See, very simple. Either see from Fe plus 3 to Fe plus 2, how much change? 1 change. For 2, how much it will be? 1 into 2, 2 change. If you don't want to see in this case, see in this case. From minus 1 to 0, how much change? 1 change. For 2, how much it will be? 2 into 1, that is 2. Clear? Clear? Answer is going to be option number B. Answer is going to be option number B. Clear? Okay. Now let us see question number 198. Let us see question number 198. Okay, let us see this question. In the electrochemical cell Zn to ZnSO4, CuSO4 to Cu, the EMF of this Daniell cell is E1. When the concentration of ZnSO4 is changed to 1 molar and that of CuSO4 is changed to 0.01 molar, the EMF changes to E2. From the following, which one in the relationship between E1 and E2? Between E1 and E2. So you have to calculate it, students. Let us calculate for E1 and E2 both. First of all, see. This is the reaction that is being given to us. So what we are going to write exactly? We are going to write E is equals to E naught cell minus 0.059 divided by N. Now log. Now we are going to write the concentration of the product. The concentration of the product over here divided by the concentration of the reactant. What is the product? Zn is being converted into Zn plus 2 ion. Zn is being converted into Zn plus 2. So, first of all, write the reaction. Zn will convert into Zn plus 2 and Cu plus 2 will convert into Cu. So, this is solid, this is solid. So, product over here is Zn plus 2 divided by concentration of Cu plus 2. That is reactant will come over here. Now, we shall write for E1. For E1, it will be E naught cell minus 0.0591 divided by what is the value of N? The value of N over here is 2 now, because 2 electrons are participating log. Now what is the concentration of Zn plus 2? See, it is saying that when we are talking about E1, the concentration of ZnSO4 is changed to 1 molar and that of CuSO4 is changed to this much. ZnSO4 is changed to 1 molar and that of CuSO4 is changed to 0.01. Okay, now the EMF changes to 2. 1 second, students. Initial, let us write the initial. Initial was Zns plus 2 is 0.01 by this is 1. That means this comes out to be E1 is equivalent to E naught cell minus 0.0591 divided by 2 into log. Can I write it as 1 by 100? Or can I write it as E1 is equivalent to E naught cell minus 0.059 by 2 log 10 raised to the power minus 2. This minus 2 will come in front. What you will get? E1 is equivalent to E naught cell minus 0.0591 by 2 into minus 2. Log 10 is 2. So 2 will get cancelled. Negative negative will become positive. E1 will be E naught cell plus 0.0591. This is your first equation that you have got. Now let us calculate for the second equation E2. Let us calculate for the second equation E2. Now see, E2 will be what? E naught cell minus 0.0591, again N is 2 log. Now what is the concentration of Zn plus 2? Zn plus 2 is changed to 1 and this is changed into 0.01. This will be 1 by 100. What it will be? E naught cell minus 0.0591 by 2. Now can I write it as log 100? Log 100 will be 10 raised to the power 2. 2 will come in front. What we will get? E cell is minus 0. E naught cell minus 0.0591 by 2 into 2. 2 will get cancelled. This is the value of E2. This is the value of what, ma'am? E2. Now you have got two equations, E1 and E2, everybody. E1 and E2, 2, 1. If you compare both one, in E1, E1 is addition of this and E2 is subtraction of this. That means, ma'am, E1 is more than E2. That means E1 is more than E2. So option number B is going to be your right answer. Option number B is going to be your right answer. Clear, everyone? Clear, everyone? Kindly take a screenshot of it. Kindly take a screenshot of it so that we can move on to our next question. Kindly take a screenshot of this question, students, so that we can see our next question. Shall we start with the next question, students? Okay. This is your question number. These are the similar questions. Okay. Now comes your question number 199. Sorry. Now comes your question number 199. Question is, given are the values for electrode potential. Electrode potential for the main cell will be what? Electrode potential for the main cell will be what? They have given you certain values for Cu over here. Now see, this is the electrode potential for the first one. For the second one, you have to calculate for this one. Now see, if you are going to subtract your this from this, you are going to get your answer C. If you are going to subtract first from second, you are going to get this third equation. For example, Cu plus 2 plus 2 electrons minus Cu plus 2 plus electron gives Cu minus Cu positive. See what will happen. Cu plus 2 will get cancelled. 1 electron. This Cu will come over here. Cu positive will give Cu. Is this the same reaction? Yes. That means what we are going to do, the delta G naught for third reaction is equivalent to delta G naught for first reaction minus delta G naught for the second reaction. We are going to apply this formula over here. Yes. We are going to apply this formula over here. So what we are going to get, we basically know that delta G, ma'am, is equal to minus NFE, right? So we are going to write in that way only. It is minus N3FE naught 3 is equivalent to minus N1FE naught 1 minus N. Now this is also in negative because delta G is negative. So this is N2FE naught 2. Write the value for the third reaction. How many electrons are participating? 1. So minus 1 into FF will cancelled in all of these cases. What is E naught 3? We need to calculate. Minus for the first reaction, how many electrons? 2 electrons. Into what is E1 value? E1 value is given to you over here as 0.337. Minus inside is negative. Now how many electrons participating over here? 1 electron. Into what is the value of this one? E2. E2 is 0.153. So what you will get, minus E naught 3 is equal to minus, now let us solve it. (0.674). Now we are going to add the 0.153 over here. What you will get, minus E naught 3 is going to be negative of 0.521. So E naught 3 comes out to be 0.52. Negative will get cancelled. What is E naught 3 value? Option number D. Option number D is going to be the value for E naught. Yes, everyone. Option number D is going to be the value for E naught. Clear? Now we are going to do question number 200. Now we are going to do question number 200. Kindly write it down once. Kindly write it down for once. Shall we move on to the next question? Now comes your question number 200. Question number 200. So what is the question I'm reading in front of you? The equilibrium constant for the reaction. Here we have been provided with a certain reaction, that is Cu plus 2Ag positive gives Cu positive plus 2Ag. E naught is 0.46 volt at 298 Kelvin is going to be what? Now this is your last question for this, and then we are going to proceed with the next chapter of ours. No, but one questions are still left. Okay, conductance questions are still left. No, this is not the last question, sorry. Kindly solve this question. See, equilibrium constant they are asking you. See, you should know that E naught cell for a particular reaction is 0.059 by N log Kc. This is going to be your equilibrium constant formula in equilibrium. Yes, now E naught cell value is given to you as 0.46 is equivalent to 0.059. What is the value of N over here? N value is 2 over here. Log Kc. What is log Kc? Ma'am, log Kc will come out to be 2 into 0.46 divided by 0.059, or you can take approximately 0.06. That means you can do approximate answer over here. Kc will come out to be 4 into 10 raised to the power 15. Kc will come out to be 4 into 10 raised to the power 15. Clear? C option is going to be your right answer for this particular question. Answer is going to be your option number C. Now we are going to do some more questions based upon the electrochemistry, and then we will end this chapter. Shall we move on to the next question of ours? Now comes your question number 201. Now comes your question number 201. I am reading the question for you. The question on the conductance itself has came. Now see, the molar conductance of NaCl, HCl and CH3CONa at infinite dilution are 126.45, 426.16 and 91 Simon centimeter square per mole respectively. The molar conductance of CH3COOH at infinite dilution is. Choose the right option for your answer. Students, you have to tell the right option for this particular question. Right, so molar conductance at infinite dilutions are given to you. You have to calculate for CH3COH. Now see, molar conductance at infinite dilution for CH3COH will be equivalent to the molar conductance of CH3COO negative and molar conductance at infinite dilution for H positive. You have to calculate the value of these two. How you are going to calculate? See, what you have been given. You have been given the molar conductance for NaCl. What it will be, ma'am? It will be molar conductance at infinite dilution for Na positive plus molar conductance at infinite dilution for Cl negative. Right? And this value they have already provided you as 540.48 something. Okay? Now, what else they have given you? They have given you the molar conductance at infinite dilution for HCl. It is going to be molar conductance at infinite dilution for H positive plus molar conductance at infinite dilution for Cl negative. The value for this HCl also they have given you. It is basically how much? Sorry, I have written an option over here. Here the value is 126.45 and here for HCl it is 426.16. Now for CH3COONa. Molar conductance for CH3COONa at infinite dilution will be equivalent to the molar conductance for CH3COO negative plus the molar conductance of Na positive. Yes, everybody. So now when I am going to add and mix them together, I want this answer. What I am going to do over here, let me write its value also. It is 91. See what I am going to do over here in this particular question. I want CH3CO negative and I want H positive. So that means I'm going, if I'm saying this 1, this 2 and this 3, I'm going to add third and second, I'm going to subtract first. What I'm going to do, I'm adding third plus second, I'm going to subtract first. Let us see. Third equation is basically what? Molar conductance of CH3COO negative plus molar conductance at infinite dilution of Na positive. Now you're going to add with the second one. The second one is molar conductance of H positive plus molar conductance of Cl negative. Now you're going to subtract with the first one. First one is molar conductance of Na positive minus molar conductance of Cl negative. See what will get cancelled? Cl, Cl, Na, Na, and you will get your answer, right? So what you have to do is 3 plus 2 minus 1. What is 3? 3 is 91 plus 2. What is 2? Ma'am, 2 is 426.16 minus 1 is 126.45. What you are going to get over here? It is 0.167, 11 1 carry, 517.16 minus 126.45. What you'll get? 7 0 8 3. Sorry, 390 will come. 390.71. Option number C, students, will be your right answer. Option number C, students, will be your right answer. Clear, everyone? Clear, everyone? Kindly write this question so that we can move on to the next part now. Kindly write this question so that we can move on to the next question now. Shall we start with the next question? Now question is question number 202. Now what is question 202? The molar conductivity of a 0.007 molar acetic acid is 20 Simon centimeter square per mole. Okay. What is the dissociation constant of acetic acid? Choose the correct option. You have to calculate the value of dissociation constant. In order to calculate dissociation constant, first of all calculate the value of alpha. And for alpha, calculate molar conductance. See, molar conductance, ma'am, for CH3COOH is equivalent to the molar conductance of its ions, that is for CH3COO negative, and the molar conductance at infinite dilution for H positive. It is equivalent to both of them, yes. So basically what do we have over here? For CH3CO negative is 50 plus for H positive it is 350. This comes out to be 400. Now this is at infinite dilution. What is alpha? Alpha dissociation, degree of dissociation, it is equivalent to the molar conductance at finite dilution divided by molar conductance at infinite dilution. What is the molar conductance at finite dilution? The molar conductivity is 20 divided by, at infinite it is 400. So this is 1 by 20. Alpha is 1 by 20. Now you should know what is dissociation constant. Dissociation constant is C alpha square. What is dissociation constant, ma'am? Dissociation constant is C alpha square. So now this is for weak electrolytes. What is C? C is concentration. How much is concentration? 0.007. What is alpha? Alpha is 1 by 20 square. So 1 by 20 into 1 by 20. Yes, everyone? Yes, everyone? So now when you're going to solve it out, what is going to be your answer? Your answer will come out to be 1.75 into 10 raised to the power minus 5. Option number D will be your right answer. Answer will be option number D. Answer will be option number D. Clear, everybody? Kindly write this out. Clear? Kindly write this out. Now let us do the next question of ours. Now comes question 203. Question 203 is following limiting molar conductivities are given below. Following limiting molar conductivities are given below. You have to calculate the limiting molar conductivity for CH3COH. You have to calculate the limiting molar conductivity for CH3COH. Yes, everybody, where are you gone? Everybody, I want your answer in the comment section. Yes, everyone. Rehan, yes. Okay. Now see, the molar conductivity for H2SO4 is equal to what? It is equal to the molar conductivity of 2H positive and the molar conductivity of SO4 minus 2. Yes, everyone? Yes or not? Yes, everyone? Okay. The value is X given to us. Now the next one is molar conductivity for K2SO4 is being given to us. That is twice of molar conductivity of K positive plus molar conductivity of SO4 minus 2. The value is Y. And the last is molar conductivity for CH3COOK is equivalent to the molar conductivity of CH3COO negative and the molar conductivity of K positive. The value is Z given to you. So now what you have to calculate for CH3COH, that means you want molar conductivity for CH3COO negative and you want molar conductivity for H positive. So CH3CO negative you require and you require H positive, but here is 2H positive, that means you will divide it by 2. You will divide this complete equation by 2. Also you will divide this complete equation by 2 because here it is 2K positive. So you have to, what you have to do, you want first equation, you want this is your first, second, this is your third. What you have to do is you want third equation plus first equation by 2 minus second equation by 2. This is how you have to do. So for third equation is Z plus X by 2 minus Y by 2. This is the molar conductivity. This is the molar conductivity. So Z plus 2 common X minus Y. Can I write it like this? So option number D, students, is going to be your correct answer. Option number D, students, is going to be your correct answer. Clear, everyone? Option number D over here is going to be your correct answer. Shall we move on to the next question if it is done? Shall we move on to the next question if it is done? Now comes question number 204. Question number 204. Question is, at 25 degrees Celsius, molar conductance of 0.1 molar aqueous solution of ammonium hydroxide is 9.54 per ohm centimeter square per mole, and at infinite dilution, its molar conductance is 238 per ohm centimeter square per mole. The degree of ionization of ammonium hydroxide at the same concentration and temperature is going to be, it's very simple, alpha is going to be molar concentration at finite dilution divided by molar concentration at infinite dilution. Now at finite dilution they have already given you the value, that is 9.54, and at infinite they have given you 238. They have already provided you with the values of finite as well as at the infinite dilution. So this comes out to be 0.04. This comes out to be 0.04, students, but it is alpha. You have to calculate alpha percent, so you will multiply 0.04 into 100. That comes out to be how much? That comes out to be 4% approximately. That means option number A is going to be your right answer. Option number A is going to be your right answer. Clear, everyone? Clear, everyone? Yes. So now shall we proceed to the next question, 205? Shall we proceed to the next question, that is 205, everybody? Okay, now let us move on to the question number 205. Now your question number 205 is in front of you. What is question 205? The specific conductance of a 0.1 normal KCl solution at 23 degrees Celsius is 0.012 per ohm per centimeter. The resistance of cell containing the solution at the same temperature was found to be 55 ohm. The cell constant will be what? Now see, the specific conductance they have given you, the value of kappa they have given you 0.012. What else they have given you? They have given you normality 0.1 normal. What else they have given you, students? The resistance of the cell was found to be 55 ohm. Resistance they have given you. They are asking you cell constant. What is cell constant? L by A. You should know that kappa, students, kappa is equivalent to conductance into L by, and what, and conductance is basically 1 by R. 1 by resistance, into L by A. So what is kappa? It is 0.012. What is 1 by R? R is 55. Into L by A we have to calculate. What will be L by A? L by A will be 0.012 into 55. This is going to be your L by A. That means how much? 0.012 can be written as 12 by 1000 into 55 on the table of 2. On the table of 5, we will get 66 by 100. That means 0.66. That means 0.66 per centimeter is going to be your correct answer. Option number B, students, is going to be your correct answer. Clear, everyone? Option number B is going to be your correct answer. Shall we proceed to the next question now? Shall we proceed to the next question, everybody? Okay, now comes your next question, 206. What is 206? A device that converts energy of combustion of fuels like hydrogen and methane directly into electrical energy is known as. The one that converts directly into electrical energy is known as. Now, very simple question and it is important also. A, dynamo. B, nickel cadmium cell. C, fuel cell. D, electrolytic cell. Students, which of the following is going to be the correct answer for this particular question? Ma'am, fuel cell is going to be the correct answer for this particular question. Option number C is going to be the right answer for this particular question. Yes, everybody? Clear, everyone? Clear, everyone, with this question? Okay, now comes your next question. That is question number 207. Next is your question number 207. The efficiency of a fuel cell is given by. The efficiency of a fuel cell is given by A option, delta G by delta S. B option, delta G by delta H. C option over here is going to be delta S by delta G, while D is delta H by delta G. So very simple, delta G by delta H is going to be the correct answer. Option number B is the correct answer for this particular question. Mohammed, only 2 chapters are left. One of them is very small, surface chemistry. Another one is chemical kinetics. Rest is done. Rest is done. We are going to end this chapter over here only. Okay. Clear, everyone? Delta G by delta H. Delta G by delta H. Now, 2 questions for your homework. 2 questions for your homework. Question number 208 for your homework from this chapter. Question 208 for your homework from this chapter. Zinc can be coated on iron to produce galvanized iron, but the reverse is not possible. But the reverse is not possible. It is because, kindly take a screenshot from this chapter. Take a screenshot of this question. Take a screenshot of this question from this chapter. Yes, done, everyone? Taken screenshot. This is your homework. Now, the last question from this chapter as your homework, question 209. That is, to protect against corrosion, the most durable metal plating on it is. To protect iron against corrosion, the most durable metal plating on it is. A option, copper plating. B, zinc plating. C, nickel plating. D is tin plating. Clear, students? Now we have ended with our electrochemistry chapter. Now at question number 210. We are going to start with our chemical kinetics. Yes, everybody. Now we are going to start with the chapter chemical kinetics. That is the second last chapter for today's session. Yes, everyone. We are going to start with chemical kinetics now. Yes, everyone. We are going to start with chemical kinetics. Yes, shall we start? Only 2 chapters are left. It will hardly take 1 hour or 1.5 hours. It will hardly take 1 or 1.5 hours. Rest we have done. Rest everything is completed. Yes, everybody? So students, now we are going to start with question number 210 for your chemical kinetics. Ready? Students, taking 10 minutes break over here. Exact 7 we are going to start. Exact 7 we are going to start. So we are going to connect at exact 7. We are going to start So yes students, welcome back. Now we shall start our chemical kinetics chapter. Yes everyone, ready? Yes everyone, ready? Do let me know in the comment section. Yes everyone, ready? Shall we start? Please let me know in the comment section. Now we are only left with 2 chapters. Show me your energy students. Yes, unseen world. Oh my god, everybody has solved this question. Ram has solved this question. Rehan, Jeevan Kumar, okay. Murugan, hello. Okay, new students now. Hello everyone. Hello my shimmering stars. I welcome you all back to PW English channel. And now we are going to start with the chapter Chemical Kinetics. Yes everybody? Ready. Okay, so the question is in front of you. I shall be reading the question for you all and then we are going to solve it out, right? So the question is basically for the chemical reaction N2 plus 3H2 gives 2NH3. The correct option is, okay, now see students, our reaction basically is N2 plus 3H2 gives 2NH3. Am I right? Am I right? Yes ma'am. Now we have to write in the form of rate of reaction. How do you represent them? See, for the reactant, that is change in concentration of N2 by change in time. For reactant, a negative sign will come, is equal to. Now for this reactant, negative sign, if there is any number written, you will write 1 upon that. You will write 1 upon that. If it is 3 written, it will be 1 by 3. Change in concentration of H2 by change in time. Now it's the time for the product. Now we have a product over here. Product is what? Ammonia, NH3. So for product, you will use a positive sign. For reactant, you will use a negative sign. For product, you will use a positive sign. 2 is written, so it will be 1 by 2. Change in concentration of NH3, that is ammonia, by change in time. Yes, everybody, this is the correct representation. It is the correct representation, everyone. So now let us see which of the following options is going to match. Let us see which of the following options is going to match. See, 3 into change in concentration of H2 by time. No, ma'am. Then minus 1 by 3 change in concentration of H2 by... Now this is previous year question. See, this is a previous year question. Minus 1 by 3 change in concentration is equivalent to minus half. No, ma'am. Now, minus of change in concentration of N2 is equivalent to twice of that of NH3. No, ma'am. Minus of change in concentration of N2 is equivalent to 1 by 2 of NH3. Yes, ma'am. So, option number D, students, is going to be your correct answer for this particular question. Clear, everyone? Shall we move on to the next question? Question number 211. Now comes your question 211, students. This question is the rate of the reaction basically is given to you as the change in concentration of N2O5 by change in time is K into N2O5, and the change in concentration of NO2 by change in time is K dash N2O5, while change in concentration of O2 per unit time is K double dash N2O5. So you have to find a relationship between K dash and K double dash. Right? Now see, if I am going to discuss about this particular equation, I have twice of N2O5 which gives 4NO2 plus O2. I have this reaction with me. You are finding it easy because you have practiced a lot of questions. You have practiced a lot of questions. You are preparing for your exam. So you are going through these questions a lot of times, right? That's why. Now see over here. If you are going to write now for the reactant, a negative sign, change in concentration of N2O5 by change in time. Now it is 2 written, so it will be 1 by 2. It is equivalent for product, positive sign, 4 is written, so 1 by 4. Change in concentration of NO2 by change in time. It is equivalent to, again, product is O2, nothing is written, 1 is written, positive, change in concentration of O2 by change in time. Now see, they have told you that this value basically is K into, this value is 1 by 2 into K into N2O5 concentration. It is equal to, now this value is being given to you as K dash N2O5. That is 1 by 4 into K dash N2O5. See, this concentration will get cancelled. Let us cross multiply. What will be K dash? K dash will be 4 by 2 into K. That means K dash will come out to be 2K. K dash will come out to be how much, ma'am? 2K. K dash will be 2K, K dash 2K, K dash 2K. This is incorrect. Now, relation between K double dash and K dash. So, what we are going to do is see if this first equation 1 by 2 into what we can write it as? We can write it as K into N2O5. It is equal to what? Positive of change in concentration of O2 by time. What is change in concentration of O2 by time? Ma'am, it is K double dash N2O5. Now, N2O5 concentrations will get cancelled. What we will get? K double dash. K double dash will be K by 2. What it will be, ma'am? It will be K by 2. K by 2. That means option number B over here is going to be your correct answer for this particular question. Option number B over here will be your correct answer for this particular question. Rehan, how C option is correct? Answer comes out to be option number B over here for this particular question. Kindly take a screenshot, my dear students, so that we can move on to the next question of ours. Done, everyone? Okay, now comes your next question, question number 212. Question number 212. See, for the reaction N2O5 gives to NO2 plus half O2, the value of rate of disappearance of N2O5 is given as 6.25 into 10 raised to the power minus 3 mole per liter per second. The rate of formation of NO2 and O2 is given respectively as. Ma'am, once again, please explain from the second step. Okay. See, the second step is basically I have taken this and I have taken this now. I have taken this complete and I have taken this complete. Okay, that means 1 by 2 into this value that is given to you is equivalent to this value that is given to you. Got it? Got it, Jeevan? Got it? Got it? Yes. Okay, great. Now coming back to the question. This was our question. Now see, let us write the first rate law equation. What is basically the rate? See, for reactant, negative sign change in concentration of N2O5 by change in time is equivalent to, for the product positive, 2 is written, so we will write 1 by 2. Change in concentration of NO2 by change in time, it is equivalent to the product O2. Now product positive 1 by 2 is written, so 1 by 2, it will become 2. 2 into change in concentration of O2 by time. So now what they are asking you as per the given question, they have given you the value of rate of disappearance. They have given you the value of this. What is this value? This value is 6.25 into 10 raised to the power minus 3. They are asking you the rate of formation of NO2 and O2. NO2 and O2. First compare these two both. What you will get? 6.25 into 10 raised to the power minus 3 is equal to 1 by 2 into change in concentration of NO2 by change in time. If you will cross multiply, it will get multiplied. 12.50 into 10 raised to the power minus 3 is rate change in concentration of NO2 by change in time. Yes, everyone? Yes, everyone. So it is now, if let us see the O2 concentration. Let us compare this and this now. So 6.25 into 10 raised to the power minus 3 is equivalent to 2 into change in concentration of O2 by time. This will take 2, it will be divided by 2. 3.125. divided by 100 into 10 raised to the power minus 3. This will be 3.125 into 10 raised to the power minus 3. Yes, everyone. So option number C is going to be, option number B is going to be your right answer. Option number B is going to be your right answer for this particular question. Option number B is going to be your right answer for this particular question. Clear, everyone? Once again, ma'am, teach. Okay, which question? This one or the previous one? This one or the previous one? See, it's very simple. Initially, I am comparing these two both. I have been provided with this information. I have calculated this one. Now, I have this information. Can I calculate for this one also, because equal to sign is given, right? Clear? Clear, everyone? Kindly take a screenshot of this question so that now we can proceed with the next question of ours. Shall we move? Shall we move to the next? We have just compared this first two and then this one and this one. The rest is just I have put the value of it. Right? Now coming to the next question, that is question number 213. Question is, in the reaction BrO3 negative plus 5Br negative plus 6H positive gives 3Br2 plus 3H2. Right? The rate of appearance of bromine is related to rate of disappearance of bromide ions. Now you can understand with the help of this question also. See, bromine, that means here you are talking about iron and bromine, right? So this is reactant, negative sign, 5 is written, you will write 1 by 5. Change in concentration of Br negative by change in time. It is equivalent to, this is product, so positive sign, 3 is written, so you will write 1 by 3. Change in concentration of Br2 by change in time. Right? This is the relationship. This is the relationship. Yes. Now see, rate of appearance, so how it is related, we have calculated, we have to calculate in terms of dBr2 by delta T. So change in concentration of Br2 by delta T will be what? This 3 will go on this side. It will be minus 3 by 5 change in concentration of Br negative by change in time. Right? So minus 3 by 5. Minus 3 by 5. This is D option is going to be the correct answer. Option number D, students, is going to be your correct answer for this particular question. Option number D is going to be your correct answer for this particular question. Clear, everyone? Shall we move on to question number 214? Okay, next question. Next question. Question is 214 now. Question is, for the reaction 2A plus B gives 3C plus D. Which of the following does not express reaction? Which of the following does not express the reaction? Yes, students, kindly solve first by your own, then I let you know how to do this. Kindly solve first by your own, then I will tell you. Very simple question. See, again, they have given us 2A plus B gives 3C plus D. So we can write, this is reactant, negative sign, 2 is written, so we will write 1 by 2. Change in concentration of A by change in time. It is equal to what? Now this is again a reactant, negative sign will be used. Change in concentration of B by change in time. It is equal to, now we have C, positive sign will come for product, 3 is written, so it will be 1 by 3. Change in concentration of C by change in time. And at last for D, it is again a product, that is change in concentration of D by change in time. So which of the following does not express the reaction? See, it is minus dA by 2 delta T, right? Minus dC by 3 delta T, wrong. Wrong. Here positive sign will come because dC, it is a product. So option number B is going to be your correct answer. It is the wrong statement. Rest you can match, each and every one is the correct. Rest you can match, each and every one is the correct over here. Yes, everyone? Yes, everyone? Clear? Option number B is the right answer. This is your question number 214. Now proceeding on to next question, that is question number 215. Now proceeding on to your next question, that is 215. Okay, now let us see the next question. Question is, mechanism of a hypothetical reaction x2 plus y2 gives 2xy. x2 plus y2 gives 2xy is given below. The very first reaction is x2 gives x plus x, which is a fast. Second one is x plus y2 gives xy plus y, which is slow. Third is x plus y gives xy, which is fast. Right? So the overall order of the reaction is going to be what? Now see, whenever you have been asked with the help of mechanism, students, how you have to solve this particular question. This matters really a lot. Now see, the slow reaction will help you to calculate a lot of things. The slow reaction basically is your elementary reaction. The slow reaction basically is your elementary reaction. And elementary reaction basically, stoichiometry is its order. So basically, if I see this particular reaction, what is going to be my order for this particular reaction? With the help of slow reaction, I am going to calculate my answer. What is going to be the rate for the slow reaction? Let us consider this as your second equation. So rate for the second one is equivalent to rate constant K for the second one into concentration of the product XY into the concentration of the product Y. Power will be 1 because nothing is written over here, right? So this is your rate number second. Now see, now which is your main reaction? The overall order of the reaction. Which reaction for this reaction? See, for this rate is equivalent to rate constant K into XY raised to the power n. Order we don't know. We want XY. We have Y over here. We need to replace this Y. What we need to do? We need to replace this Y. How we will replace this Y? See, if you will see over this reaction over here, we have this fast reaction. And what will be the equilibrium constant for this fast reaction? Ma'am, it will be product concentration divided by reactant concentration. So what will be Y over here? What will be the value of Y? Ma'am, the value of Y will come out to be yes everyone, this is the value of Y that will come out over here. Sorry, kindly correct it over here. I am writing again the rate for the second equation. I am repeating the same step again. Basically, when we are representing rate, we are representing in the terms of reactant. I by chance wrote in the terms of product, so kindly correct it. Rate for the second one will be reactant over here is X and the reactant over here is Y2 into rate constant K2. We have to use reactant over here, right? We have to use reactant over here. Now for this reaction, see, in the main reaction, what will be rate? Rate for the main reaction will be rate constant K into X2 into Y2. Now we have Y2 but we don't have X. We don't have X2, we have X over here. Let us replace this X. See this equation fast. In this fast equation, what will be K equilibrium? It will be product concentration 2, so X square divided by reactant concentration, that is X2. What will be X? X2 will be K into X2 and what will be X? X will be root of K into X2. Let us equate this over here. What you will get? Rate for 2 is equivalent to root K into root X2 into Y2 into K2. Now if you are comparing both Y2 same, that means it has the order 1. And if you compare both, what will be X2? X2 is raised to the power half. So the order on X2 is what? Half. And rest K2 into root K is K constant. So what is the overall order? Ma'am, overall order is half plus 1. That comes out to be 3 by 2. That comes out to be 3 by 2. That is 1.5. That is 1.5. Yes, option number C is the correct one. That is C is the correct one. Clear everyone? Shall I move on to the next question? Kindly take a screenshot of this particular question, students. Kindly take a screenshot of this particular question. Okay, now comes your question number 216. Question is, the decomposition of phosphine on tungsten at low pressure is a first order reaction. It is because the A, rate is proportional to the surface coverage, B, rate is inversely proportional to the surface coverage, C, rate is independent of the surface coverage, D, rate of decomposition is very slow, students. What do you feel is the right answer? See, at low pressure it is first order reaction and at high pressure, students, it will follow zero order reaction. At high pressure it will follow zero order reaction. It is directly proportional to the surface coverage. So option number A is the right answer. A is the right answer. If you'll increase the surface and you'll give high pressure, then it is going to be which kind of reaction? Zero order. But initially it at low pressure it is first order. Clear? Mohammed is saying option C and A may confused. Which question? In the previous one. In the previous one. How you are confused in A and C? It is 3 by 2, no? What is the problem? Let me, please tell me in detail, I'll explain you. Now comes a question number 217. Question is the rate constant of the reaction A gives B is 0.6 into 10 raised to the power minus 3 mole per liter per second. If the concentration of A is 5 molar, then the concentration of B after 20 minutes will be what? Okay, students, tell me about this question, the value they have given you, and they are asking you what is going to be the answer in this particular question. See, very first thing, they have given you the rate constant, and if you'll see the unit of rate constant, it is your which kind of a reaction? If you'll see the unit of rate constant, it is which kind of a reaction? Is it a zero order? Yes, ma'am. So for a zero order reaction, what is the concentration of B? It is equivalent to K into T. What is K? K value is given to you as 0.6 into 10 raised to the power minus 3, and what is T? T is 20. So what you will get over here? 6 by 10 into 20 into 10 raised to the power minus 3. This comes out to be 12 into 10 raised to the power minus 3. Right, everybody? The concentration after 20 minutes. The concentration of B after 20 minutes is going to be what? So students, answer comes out to be what? Is it the right answer? No, we still have to convert it. Why? Because it is given in minutes. We have to convert it into what? We have to convert it into seconds, because here it is written seconds. So 1 minute is equals to 60 seconds. So at last multiply it with 60. What you will get over here? 720 into 10 raised to the power minus 3. That is 720 divided by 1000. 0 will get cancelled. You will get 0.72 molar. You will get 0.72 molar. Clear? Video not clear? I guess now it is clear. The issue is resolved, right? Kindly take a screenshot of this question, students, so that we can move on to our next question of ours. Kindly take a screenshot of this question, students. Now comes your question number 218. Question is, for a reaction between A and B, the order with respect to A is 2 and the order with respect to B is 3. The concentration of both A and B are doubled. The rate increases by a factor of. Yes, students, what do you feel is the right answer? Now see, there is a reaction between A and B. The order with A is 2 and order with B is 3. The concentration of both are double. Let us say initial the rate is going to be the rate constant K into A and into B. The order with respect to A is 2 and with respect to B is 3, right? Now new rate is rate dash, so it is equivalent to K dash. Concentration of both are double. That means this becomes 2A square and this becomes 2B cube. So it increases by which factor? K dash into this will become 4A square into 8B cube. So can I take it outside? 4 into 8 into K dash into A square into B cube. Now this whole is equivalent to rate 1, right? So what is rate dash? Rate dash comes out to be 32 into rate. That means it increases by a factor of 32. It increases by 32. Clear, everyone? So option number C over here is going to be your right answer for this particular question. Clear, everybody? Shall we move on to the next question, 219th question, if it is done? Now comes your next question, 219th question. Let us see. Question says that which one of the following statements for the order of a reaction is incorrect? For the order of the reaction is incorrect. A. Order can be determined only experimentally. B. Order is not influenced by stoichiometric coefficients of the reactant. C. Order of the reactions is the sum of power of the concentration term of reactant to express the rate of reaction. While D. Order of the reaction is always a whole number. So you have to tell which of the following is the incorrect statement, students. Which of the following is the incorrect statement? So it is very clear, order is always whole number. This is incorrect statement. Order can be fractional also. So option number D directly is the right answer. Option number D directly is the right answer. Now shall we move on to the question number 220? Shall we move on to next question now, students? Now comes your next question. During the kinetic study of the reaction, 2A plus B gives C plus D. Following results were made. Following results were obtained. This is your question number 220. Concentration of A, B and given to you, and initial rate of formation of D is also given to you, right? So you have to tell based on the above data which one of the following is the correct one. See, very simple. First of all, for the main reaction, write rate. Rate is equivalent to rate constant K into A raised to the power X and B raised to the power Y. X is basically the order with respect to A and Y is basically the order with respect to B. Now see, can I write in these terms? The first equation will be, what is rate? Rate is 6 into 10 raised to the power minus 3 is equivalent to K into what is A? 0.1 power X. What is B? 0.1 power Y. Now for this reaction, what it will be? 7.2 into 10 raised to the power minus 2 is equivalent to K. What is A? A is 0.3. Power is X. What is B? 0.2. Power is Y. Now for the third reaction, students, what it will be? Third reaction will be 2.88 into 10 raised to the power minus 1 is equivalent to K into A is 0.3. Power is X. What is B? 0.4. Power is Y. Now for the fourth reaction, it is 2.40 into 10 raised to the power minus 2 is equal to K. Now what is A over here? 0.4 power is X and what is B? 0.1 power is Y. Now you have written four the equations. Now you have taken 4 equations over here, students. Yes. Mohammed is asking for break. A break after this chapter you can take. Let us complete this chapter only, then one chapter will be left. Please, please, please. And last chapter is very short. Okay. Okay. Now see. Here we have to cut any of the 2 statements. For example, let us consider that we are taking equation number first and fourth. What you will get first is 6 into 10 raised to the power 3 is equivalent to K into 0.1 X 0.1 Y. Divide first and fourth. What you will get? See, basically this will be divided on the table of 4 and this will get cancelled. KK will get cancelled. You will get 4 is equal to 4 by 1 X. So X comes out to be how much? 1. X comes out to be how much? 1. Now how you will calculate Y? See, Y also you want something to in which X gets cut off. See, so second and third, if I see second and third equation, see second and third. On the table of 4 it will get cut and this whole will get cut. This will go on the table of 2. So what you will get? 1 by 4 is equivalent to 1 by 2 power Y. So Y will come out to be 2. X comes out to be 1, Y comes out to be 2. X comes out to be 1, Y comes out to be 2. So that means if I put over here, what will be my new rate? Rate will be equal to K into X comes out to be 1, Y comes out to be 2. A, B, 2. That means option number D is going to be right answer, students, for this particular question. Clear, everyone? Option number D is going to be right answer. Kindly take a screenshot of this question so that we can move on to the next question of ours. Let us move on to the next question. Okay, now comes your next question, that is question number 221. Question 221 is in front of you. For the reaction A plus B gives product, it is observed that first, on doubling the initial concentration of A, the rate of reaction is also doubled. Second, on doubling the initial concentration of A and B, there is a change of factor of 8 in the rate of reaction. The rate of the reaction is given by, now you have following options over here, students, with you. You have following options over here in front of you. Kindly do this. Then we are going to match our answers. Yes, after this chapter, I am going to give break. No need to worry. At 8 p.m. I will give you 10 minutes break. No need to worry. Okay, we'll do that. Okay. Now, on doubling the initial concentration of A only, the rate of reaction is also doubled. Now, see, what is rate as per the reaction? Rate is rate constant K into concentration of reactant A into concentration of reactant B. Let us consider X and Y respectively as the order. Now on doubling the initial concentration of A only, the rate of reaction is doubled. When you are increasing the concentration of A, you are doubling the concentration. The rate will become double, that means twice of the initial rate. So divide both of them, rate by rate will get cancelled, BB will get cancelled, XX will get cancelled, you will get 1 by 2 is equivalent to, AA will get cancelled, 1 by 2 power is X. X will come out to be how much? X will come out to be 1. X will come out to be 1. Yes? Now, the next one. On doubling the initial concentration of both A and B. When you are doubling the initial concentration of both A and B, initial was K, A power X, B power Y. Now on doubling the both A, that means K into 2AX and 2BY. There is a change of factor of 8 in the rate of reaction. 8 rate will become this. Rate will get cancelled. Now X power is 1 you have got. This will get cancelled. This will get cancelled. You will get 1 by 8 is equivalent to 1 by 2 power is 1. Here BB will get cancelled. You will get 1 by 2 power Y. Now let us take this over there. When you will take this over there, you will get 1 by 4 is equivalent to 1 by 2 power Y. Y will come out to be 2. So x1, y2, x1, y2, x1, y2. Option number A is going to be the right answer. Option number A is going to be your right answer. Clear everyone? Option number A is going to be your right answer for this particular question. Clear everyone? Option number A is going to be right answer for this particular question. Kindly take a screenshot of this one. Now moving on to question 222. Let us move on to the question 222. Moving on to another type of question. Now this is your question number 222. Question is, the given graph is a representation of kinetics of a reaction. The given graph is a representation of a kinetics of a reaction. The y and x axis are for the 0 and the first order reactions respectively are. Now for 0 order reaction what it will be and for first order reaction what it will be. There is a graph given to you students over here. There is a graph given to you. For 0 order you all know that rate is independent upon concentration. How? See, rate is equivalent to rate constant K into concentration raised to the power 0. That means it is 1. So rate is equivalent to rate constant. So if you are making a graph with respect to rate and concentration, that will be for your 0 order. So concentration and time 0 order no. Rate and concentration yes. So option number C directly is the right answer. Option number C directly is the right answer for this particular question. Clear everyone? Shall we move on to the next question if it is done, students? Shall we move on to the next question if it is done? Now comes question number 223. Question is, the rate constant for a first order reaction is 4.606 into 10 raised to the power minus 3 per second. The time required to reduce 2 grams of the reactant to 0.2 gram is going to be what? A option 100 seconds, B option 200 seconds, C option 500 seconds, while D option 1000 seconds. So what do you feel, students? Which of the following is going to be the correct answer in this particular question? Basically, it is time is equivalent to 2.303 by K log A by A naught by A naught minus X, right? Initial concentration by final concentration. So here you have to calculate time required 2.303 by what is K? K is 4.606 into 10 raised to the power minus 3 into log A naught. Reduce 2 grams to this much. Initial was 2 and after that it was 0.2, right? So this goes on the table of 2. So time comes out to be 1 by 2 into 10 raised to the power minus 3 log 2 by, and 0.2 can be written as this. So log 10 is 1. Time comes out to be 1 by 2 into 10 raised to the power minus 3. That means 1000 by 2. That means 500. That means 500 seconds is going to be the correct answer for this particular question. Option number C is going to be the correct answer for this particular question. Yes, Arinjit Tiwari, Rehan, yes, exactly, the correct one. Clear everyone? Clear everyone? Shall we move on to the next question? The question number 224th. If it is done, shall we move on to the next question? Okay, now comes next question, question number 224th. Question is, if the rate constant for the first order reaction is K, the time required for the completion of 99% of the reaction is given by 99% of the reaction is given by. You have been given 4 options over here. Think for one, students. See, again I'm going to write the formula. Ma'am, T is equivalent to 2.303 by K log A naught by A naught minus X. Let us consider initial concentration was 100. So T is equivalent to 2.303 by K log 100. Now minus, see here we are saying 99%. That means 100 minus 99% of initial was 100. So 99% of initial. So this will get cancelled. What you will get, T is equivalent to 2.303 by K into log 100 by 1. Now log 100 can be written as 10 raised to the power 2. What you will get, T is equivalent to 2.303 by K log 10 raised to the power 2. Now this 2 will come in front. It will be T is equivalent to 2.303 into 2 divided by K into log 10. Log 10 is 1. So this comes out to be how much? 4.606 by K. T comes out to be 4.606 by K. That means option number D, students, is going to be your correct answer for this particular question. Yes, everyone. Yes, everyone. Clear, everyone. Shall we move on to the next question if it is done? Shall we move on to the next question if it is done? Okay, now comes the next question, question number 225. 225. So when initial concentration of the reactant is doubled, the half-life period of a zero order reaction A is halved, B is doubled, C is tripled, D remains unchanged. What is the formula for half-life time? T half for zero order is A naught by 2K. A naught by 2K. A naught by 2K. Yes? So now they are saying if initial concentration is doubled, the half-life period will also become double. It will also become double. Simple. Because it is directly proportional to it. Because it is directly proportional. Clear, everyone? Clear, everyone? Okay, let us see the next question now. 226 question now we are going to do. Question number 226. I am reading the question for you all. In a first order reaction, A gives B. If K is the rate constant and the initial concentration of the reactant A is 0.5 molar, then the half-life is what? Then the half-life is what? Then the half-life is what? See, for first order, T half is equivalent to what? 0.693 by K. Yes, everyone? So if it is saying that if K is rate constant, initial concentration is 0.5 molar, then T half is what? Yes, students, very simple question. 0.693 basically is your log 2. 0.693 basically is your what, ma'am? It is basically your log 2 or not? It is basically, see, let me tell you, what is ln2? What is ln2? ln2, not log 2, ln2. ln2 is 2.303 log to the base 10 2 divided by K. So when you are going to solve it out, you are going to get this answer. That means option number C is the correct answer. Yes, option number C is the correct answer. Right? Option number C is the correct answer. Clear, everyone? Shall we move on to the next question now? Shall we move on to the next question now? Question number 227. Okay, now comes one graphical question, which is your question as a homework from this chapter. This is question number 227. This is your question number 227 as your homework question. Okay, this was the simplest question. That's great if it is simplest. If you're feeling the simplest, then it's wow. Okay, now students. Okay, that's too good. Now see, that's the spirit. You are considering yourself that yes, you have studied so much hard. So that's like, my students. Like, come back to the question. This is your homework question. For a reaction, A gives B, enthalpy of reaction is minus 4.2 kilojoule per mole and enthalpy of activation is 9.6 kilojoule per mole. The correct potential energy profile for the reaction is shown in which of the following? Right, everybody? This is your homework question. Try by your own. Let us move on to the next question now. Next question is question number 228. The activation energy of a reaction can be determined from the slope of which of the following graphs? Okay, from which of the following graphs? Now, what is the formula of activation energy? K is equals to AE raised to the power minus EA by RT. Now, you're going to take log K, it will equivalent to log A plus, now log of E will be what? All of these stuff will come in front, minus EA by RT. Minus EA by RT, everybody. Yes, is it clear or not? Now we are going to plot a graph between what? We plot a graph between, ma'am, log K and 1 by T. Log K and 1 by T, or you can say ln K versus 1 by T. So option number A is the right answer. Option number A is the right answer. Yes, everyone. Clear, everyone. Clear, everyone. Now let us proceed towards question number 229. Two more questions and we'll end up this basically chapter over here. Question number 229 is in front of you. The temperature dependence of rate constant of a chemical reaction is written in terms of Arrhenius equation. It is written in terms of Arrhenius equation. K is equals to E, A into E raised to the power minus EA by RT. E star is the activation energy. It can be calculated with the plot of, now only we have done this, log K versus 1 by T. Log K versus 1 by T. Same question, easy question. Okay, now moving on to the next question. Last question for your this chapter. 230th question, last question. The activation energy for a simple chemical reaction A gives B is EA in forward direction. The activation energy for the reverse reaction A is negative of EA. B is always less than EA. C can be less than or more than EA, while D is always double of EA. So what do you feel, students? Which of the following is going to be the correct answer? Rehan is saying C. Anyone else? Anyone else? This is the last question for this particular one chapter. Yes, it can be less than or more than EA. It can be less than or more than EA. Clear? Now students, we are going to start with our last chapter of our today's session. We are going to start with the last session of our today's session, that is with question number 231. 231 with the last chapter for our today's session. Yes, everyone. So now we are going to take okay. Now we are going to take a 10 minutes break. At exact 8, we are going to start with our last chapter and we are going to end this over here. Exact 8, we are going to start with our last chapter and we are going to end it. At 8 p.m. we are going to start with our last chapter and we are going to end it, right? So stay connected, students. So Hanji students, welcome back students to amazing channel of our. I guess each one of you has attempted the question, right? So we are going to wait for about 15 more minutes and then we are going to start. Okay, because we should respect each and every religion. And yes, I am giving 15 minutes break more. We are going to start at 8:15. So there is no problem. Till then you can solve this question out. Okay, and you can solve the questions that I have given you for your homework. Right? Okay, after 15 minutes we are going to start. We will start at 8:15. No worries students. Right? We will start by 8:15. Okay, see you in 15 minutes then. So yes, students, I welcome you all back to this amazing platform. Now we shall start with our last chapter for us for today. Yes, everyone. Kindly join fast so that we can start with the last chapter, that is going to be your surface chemistry. Yes. Shall we start, students? Please let me know in the comment section that my voice is audible to you and I'm clearly visible, so that we can start with our today's session. Yes, everyone. Yes, students, please let me know in the comment section. Yes. No, Rehan, not at all sorry. There is no sorry needed for this. Shall we start? Shall we start? Okay. So the question is, which one of the following statement is incorrect about enzyme catalysis? Okay, about enzyme catalysis, which is the incorrect statement? You have your A option with you as enzymes are mostly proteinaceous in nature. Enzymes are mostly proteinaceous in nature. B option is enzyme action is specific. C is enzymes are denatured by ultraviolet rays and a high temperature, while D is enzymes are least reactive at optimum temperature. Yes, students. So which of the following option is going to be the correct answer? Everybody, very simple question. Very simple question. They are asking which is incorrect. They are asking which is incorrect statement. Everybody. Yes. Very simple question. If you see the property of enzymes, okay, I have read that chapter like 6 times. So answer fast, students. What is going to be the answer for this particular question? Yes, everybody, be fast. So enzymes are basically, students, least reactive at optimum temperature. This is the incorrect statement. They are most reactive at the optimum temperature. Right? So this is the incorrect statement. Yes, everybody. Very simple question. Now bringing you the question number 232. The enzyme which hydrolyzes triglycerides to fatty acid and glycerol is called A option maltase, B option lipase, C option zymase, while D option you have over here is your pepsin. So students, which of the following is going to be your correct answer over here? Which of the following is going to be your correct answer over here, students? Mohammed, Rehan. Rehan is saying D. Mohammed is saying D. Amrita is saying B. Yaku Naik is saying B. Anyone else? D. Halwa question. Okay. Rams is saying B. C. Santosh is saying B. They are saying the enzyme which hydrolyzes triglycerides to fatty acid and glycerol is your which enzyme? Is your which enzyme? Students, it's your lipase enzyme. Which enzyme? Lipase enzyme. Let us move on to the next question. See, this chapter is a kind of a theoretical that you will observe. Now, this is also again an easy question. 233. A colloidal system has a particles of which of the following size? Colloidal system has a particle range of which of the following size? Mohammed is saying bio starts. No, this is not we can say exactly bio, but yes, chemistry also holds a vital role in surface chemistry. It is an interesting topic to study, right? A option is 10 raised to the power minus 9 to 10 raised to the power minus 12. B is 10 raised to the power minus 6 meters to 10 raised to the power minus 8 meters. C is 10 raised to the power minus 4 meters to 10 raised to the power minus 10 meters, while D is 10 raised to the power minus 5 meters to 10 raised to the power minus 7 meters. So students, which of the following is going to be the colloidal range? Very simple question. Laddu Sharma is saying B, Jeevan Kumar is saying A. This question also you are giving so many options. I don't know why you are doing so. This question also you are taking, you are telling so many options. Yes, students. Hi Ganesh, I am new ma'am. Hello. In meters they are asking, not in nanometers. In meters they are asking. That is 10 raised to the power minus 6 to 10 raised to the power minus 8 students. Ashok is saying D. Yeah, Yaku, you are right. It's B. Let us see the next question. Question number 234. The right option for the statement Tyndall effect is exhibited by first urea solution, second NaCl solution, third glucose solution, D starch solution. Yes, students, it is exhibited by which of the following? By which of the following? See, you have to analyze yourself. You have to check whether which chapter you are lacking. Like I am seeing many of the students are not giving the correct answer. Answer is going to be NaCl solution. Answer is going to be NaCl solution. Yes, Jeevan is right. Unseen World is right. Rishik is right. Yes, everybody. NaCl solution. NaCl solution. One second. Okay, before answering this question, can anybody tell me what is Tyndall effect? Then we are going to discuss more about it. Can anybody tell me about Tyndall effect? Okay, you have studied your chapter solution. In your chapter solution, you have studied for the cases of electrolytes and for the non-electrolytes. Yes, Amrita, Sai Ganesh, FC, PVNs, your answer is absolutely correct. Now let me tell you why. Understand it very carefully. See, if you open up your NCERT or if you have studied upon that the difference between true solution, colloidal solution and suspension, you'll get over there. Yes, this is the previous year question exactly. Now understand this over here. Tyndall effect in which light is scattered. Okay, now understand this. When I'm talking about urea, when I'm talking about glucose, when I'm talking about NaCl, I am talking about, solutions. I'm talking about what? True solutions. But if I talk about starch over here, it is not a true solution. Starch is not a true solution. Starch solution is basically not a true solution. It comes under the area of which? Colloidal particles. Right? And Tyndall effect is a property exhibited by colloidal particles, not the true solutions. Okay, if you remember the chapter solution also you have studied over there. So they are asking as per the question that Tyndall effect is shown by which of the following? So it is starch solution, not NaCl, neither glucose, neither urea. Okay, now in the next question what I am going to do is I am going to tell you the wrong answer and then I am going to see which of the students are going to follow that. I am going to see whether you are able to analyze or not. You have to think before answering, right? Okay. What happened? I am writing the number of question over here. It is again and again going. It is 234th question. Now moving on to, this is your 235th question. Question is, on which of the following properties does the colligating power of an ion depend? Now this is also very really important topic. Let me tell you students, while you are covering the surface chemistry chapter, cover the colligating properties, cover the goal number topic and also cover the topic with regard to your initial surface chemistry. You should know the very basic things about it, for example adsorption theory. Okay, now the topic is that colligating power of an ion will depend upon which of the following factor? A, magnitude of the charge of the ion alone, B, size of the ion alone, C, both, and D, the size on the charge. Very simple. Arinjay is saying, ma'am, I did say starch at the start. Very good if you said that. Yes, the answer is going to be that it depends both on the magnitude and the size. It depends upon both the magnitude and the size. Right, everyone? Next question is question number 236. The question is the coagulation values in millimoles per liter of the electrolytes used for the coagulation of AS to S3 are given below. The correct order of their coagulating power is. The correct order of coagulating power is. Yes, FCPVNs, yes, you were also right. The correct order of them will be what? Now, coagulating power is inversely proportional to the coagulation value. It is inversely proportional to the coagulation value, my dear students. So here coagulating power is inversely proportional to coagulation value. Less the coagulation value, more the coagulating power. This has the less value, so its coagulating power will be more. Third coagulating power will be more. After this, which has more? 0.69, that means second and then first. So option number C over here is going to be the right answer. Again, I am repeating, coagulating power is inversely proportional to coagulation value. Yes, C for C is so easy. Well, so starts for from S, right? But it's okay. Arshdeep Kaur is saying C. Ram is saying C. Sai Ganesh is saying A. How A? How A? It is not directly proportional. It is inversely proportional. Yes. Now moving on to question number 237th. Question number 237th. Which property of colloidal solution is independent of charge on the colloidal particles? Which is independent of charge? Ma'am, your voice is not clear. Please let me know if my voice is not clear. Hello, hello. Please let me know if my voice is not clear. Okay. Now, A is electroosmosis, B is Tyndall effect, C is coagulation, D is electrophoresis. Which is independent on the charge? Tyndall effect, students, is basically the one that is independent on the charge. So option number B is the right answer. This is a question number 237. Now moving on to the next question, that is 238. The protecting power of lyophilic colloidal sol is expressed in the terms of A. Coagulation value, B. Gold number, C. Critical missile concentration, D. Oxidation number. Simple question yet again. Simple question yet again. You are talking about the protecting power. So which of the following is the right answer, students? Gold number? Gold number? Okay, let us move on to the next question. That is question number 239. 239. Okay, which one of the following forms missiles in aqueous solution above certain concentration? Missiles in aqueous solution above certain concentration. You have been provided with 4 options over here. A is dodecyl trimethyl ammonium chloride, B is glucose, C is urea, and D is pyridinium chloride. Pyridinium chloride. So students, which of the following is the correct answer? Which of the following is the correct answer for this particular question? Yes, option number A is going to be the correct answer. Now, discussing the last question for your today, which is your homework question with regard to this chapter, that is question number 240. That is position of non-polar and polar pattern missile. Position of non-polar and the polar pattern missile. A. Polar at the outer surface. B. Non-polar at the inner surface. B. Polar at the inner surface, non-polar at the outer surface. C. Distributed over the surface. D. Are present at the surface only. Now this topic you may have done in your 10th standard also. Missile formation, the cleansing action of soap. Yes everyone? Yes everyone? Done? Done, done, done. So now students, we shall end our today's session over here only. Right? So we have completed our today's session. Before ending, there are few lines for you all. There are few lines for even you all. Kindly listen to me very carefully. Play your part and leave the rest. Play your part and leave the rest. Life gives us each day a new test. Life gives us each day a new test. It is up to us. It is up to us how we tackle the same. How we tackle the same. It's all about a positive mind frame. It's all about a positive mind frame. Just do your best and leave the rest. Just do your best and leave the rest. Good luck to you. Always stay blessed. Good luck to you. Always stay blessed. So, students, before ending, I am going to sing few lines for you all, as I have spoken in between the lecture also. Okay, so there are few lines for you all which always motivates me, you know, and see, each and everyone has one person in his or her life that always motivates, you. So in my life, I have two major persons in my life which always motivates me. That's my mom and dad. And whensoever I look up to this video of the song that I'm going to sing in front of you, I always remember my mother, just as the mother of the hero. So this line really, really means a lot. So listen to it very carefully, though it is in Hindi, but still, yes, this line will motivate to you people also. घायल परिंदा है तू, दिखला दे जिंदा है तू, बाकी है तुझ में हौसला, तेरे जुनू के आगे अंबर पनाहे मांगे, कर डाले तू जो फैसला, रूठी तकदीरें तो क्या, टूटी शमशीरें तो क्या, रूठी तकदीरें तो क्या, टूटी शमशीरें तो क्या, टूटी शमशीरों से ही हो, कर हर मैदान फतेह, कर हर मैदान फतेह, कर हर मैदान फतेह रे बंदियां, हर मैदान फतेह, कर हर मैदान फतेह, कर हर मैदान फतेह, कर हर मैदान फतेह रे बंदियां, हर मैदान फतेह. So students, the one that the one who won't understand Hindi, I would say its conversion in English is basically that you have to achieve whatsoever you want to achieve in your life. In whatsoever field you go, just achieve your best, just achieve the heights, just achieve the zenith of success, that I will say, right? So like this song motivates me, my mother and father motivates me. I am there for you people, your parents are there for you all. Just give your NEET examination your best, okay? Give your 500%, and yes, don't get panic in the examination. This I would say to each and every one of you. Whenever you are taking any exam, so just remember that the whole year, hard work, the hard work of whole year depends upon you, your mindset. If you are thinking positive, your exam will automatically be positive. If you are thinking negative, automatically you will not be able to solve questions. And one more thing, students, sometimes what happens basically, when you have taken your exam and you are attempting it, okay, so one or two questions you are not able to get it, so you get panic. Oh my god, I don't know how to solve this question, and due to that your whole exam will go in that pressure. So what you can do is you can analyze the question paper. Whensoever you are having the question paper, just see all the questions. When you are seeing all the questions, try to find out those questions which you can solve in a very less amount of time. First complete that questions, and then approach to that questions which you feel like is a medium level, and then go for the hard ones. Or what you can do is give 3 rounds, okay? In the very first round, try to solve that questions which you are able to do very easily. Then in the second round, go again with that question paper and see which questions you are able to do now. And in the third round, you will be able to analyze the last question set that you will be able to do. So this is the way to solve question papers. And yes, all the very best. We have covered the complete physical chemistry of yours in this particular session. I hope so it helped you a lot. Now we shall meet, okay, in the next sessions of your whensoever it is going to happen. So I will wish you all the very best for your examination. Keep smiling, my shimmering stars. Thank you so much and have a good day. Take care, everybody. Take care. Thank you so much. Have a good day.